Vishnuji, could you please help us in loading this PPT? Kindly cast it on the main screen. Okay, okay, thank you. Yes, please.
Yeah. Can you check if the audio is playing too? It's playing. I think audio is not working.
Audio is not coming. Okay. You're based out of Bangalore, right?
Yes.
Okay.
Yeah, it's on HDMI. It should go.
He'll help.
Yeah.
Screwdrivers.
I am, yeah.
Just check the jack. Is this audio jack connected? It's not connected, so audio won't come. It's connected to. Yeah. Is it playing? It's coming here.
It's coming?
Yeah, it's coming here.
No, I think that it crashed probably. It's fine. Should it play there? Yeah.
I'm not hearing anything. Is
Yeah.
there audio in this?
There is, yes.
Can you just play any random YouTube video?
Oh yeah, it's playing, right?
Prepare your teams to handle any
Yeah,
situation.
just so that the volume,
Yeah.
is this volume level fine?
Technology has completely transformed several aspects of our lives, yet many industries still rely on old
But
school.
just make sure this is connected to all the laptops which are coming here. Sure. Thanks.
Yeah, it's working fine now.
Come.
Working fine?
Yeah. I think we're good. I think you can stop this video. Do you want to?
You can
maybe
stop
do
it now
setup?
and just please take our screen and please run that video.
So come here. Basically,
You can take out your laptop.
so come. I'll give
Saurabh,
you
run our
Wi-Fi.
yes, video. Now switch to anchoring video, anchoring
You
PPT.
can do there also.
लेके जा रहा हूँ, रेडी करके लेके आता हूँ।
Okay, thank you. स्टेपलर है कुछ काफी हो गया स्टेपलर
क्या नाम है
सौरभ आर वी रनिंग द पीपीटी ओके
स्टार्ट करते हैं ना.
ये लो, रख के। Yes, please go ahead. Check it completely.
यहाँ की लाइट्स क्यों बंद कर देते हैं? यहाँ की लाइट्स थोड़ी ऑन रहनी चाहिए, चाहे पीपीटी
जब होंगे तब डालेंगे. Yes, good. Now move back to the video. Now start playing the video and make this PPT at the slide 1 so that whenever Kumud will be starting, we can put that Sangam Bangalore wala slide. Yes, go ahead. ठीक है?
अभी कुछ लोग आए हैं बाहर स्टार्ट करने के लिए.
है जनता बात?
अभी नहीं. The speakers who have not given their presentation, you are requested to please raise your hand so that Mr. Nandan come and take your PPT from your pen drive. I request everybody who is outside to please come in so that we can start with the inauguration. Everybody is requested to please sit in the middle row. There will be a better view for you. We are starting with the inauguration session in another minute. Everybody who is outside is requested to please come and sit. A very good morning, ladies and gentlemen. Respected Director General Telecom, Shri R.R. Mittal, Director IIT Bangalore, Dr. Debabrat Das, all dignitaries, officers, our guests from the industry and startups, academia and enthusiasts from various fields. A very, very good morning to all of you. I am Kumud Jindal, ADG from Department of Telecom. On behalf of DOT, I extend a very, very warm welcome to all of you to Sangam Bangalore, the second outreach program for Sangam Digital Twin Initiative with AI-driven insights. The Department of Telecom has unveiled the Sangam Digital Twin Initiative, an unparalleled venture inviting expressions of interest from industry pioneers, startups, MSMEs, academia, innovators, and forward thinkers. So, to begin with the program, I request our esteemed dignitaries, Shri R.R. Mittal, Director General Telecom, and IIT Director Dr. Debabrat Das for your esteemed presence on the dais for commencement of the event. Thank you, sirs. Now I would like to request Shri Sunil Ranjan, Director from DOT, to welcome our esteemed guest, Shri R.R. Mittal, Director General Telecom, by presenting sir a bouquet. Please give a huge round of applause. I would like to now invite Ms. Ashwati from DOT to welcome Dr. Debabrat Das, Director IIT Bangalore, by giving a bouquet to sir. Thank you so much, ma'am. Dr. Debabrat Das, who is the Director of IIT Bangalore, prior to joining IIT Bangalore, has served at IIT Kharagpur and at Kirana Networks in New Jersey, USA. Sir is the Project Officer at National Mission for Interdisciplinary Cyber Physical Systems in the areas of advanced communication from DST, Government of India. Sir's main research areas are IoT and wireless access networks, QoS, power saving, and MAC. Dr. Das received his PhD degree from IIT Kharagpur. I would like to invite sir for his welcome address. Please welcome sir with a huge round of applause.
Thank you, Madam Kumud, for your kind words. So nice of you. And very good morning and warm welcome to all the esteemed delegates to Sangam on Digital Twins, organized by Department of Telecom, Government of India. First of all, let me tell, I am a telecom man. My life is last 40 years as a student, and later on I was working in my research, teaching, and also in the deep into now into advanced communication systems is a telecom area. So I'm so happy and proud that Department of Telecom chosen our campus to host this Sangam on Digital Twin. My heartfelt thanks to the Secretary of Department of Telecom, Dr. Neeraj Mittal, who will be here in the afternoon, and also the keynote address which will be there in the afternoon by CEO of Niti Aayog, Mr. BVR Subramaniam. And also, I really appreciate their vision and direction to the department in this digital twins, which is an important area. I also want to thank Director General Sri R.R. Mithra, who has come from Delhi and graced this occasion, and also will talk and give the keynote address after this welcome to give us the vision and the roadmap for this occasion, and also the multiple years of the events going to work. I also want to thank DOTs Sri Ashit Kandayan, who has been one of the driving force to bring all of us to here to work on this and think about this area. Thanks to Mr. Anurag Vibhuti and Ms. Kumud, ADG of DOT, and the whole team of the DOT for such an important, which has a huge impact for next generation industry evolution. This Sangam is to generate interest for industry, academia, and startup in digital twin to design and solve some of the very pertinent problems which we are going to face in the practical life and also in the industrial evolution. I welcome eminent speakers from the industry for this event who has been contributing in these areas for many years. I welcome my CDOT delegates and also my friends from the industry and also the R&D labs to this campus for this event. Digital twin will give multiple notch more on realization of a system in virtual world, which you know. But to be reality, it has multiple dimensional of the research has to be done and also the proof of concepts which is people have been doing. And in this regard, IIITV, we have worked on a smart irrigation and agriculture to find out through the digital twin the anomaly of detections of various challenges. In these words, I request all of you after the lunch to visit the COMET Foundation, which COMET stands for COMET, Communication Enterprise Technology, which is a lab just behind this auditorium, one floor below, which has been, we are working on very advanced technology on ORAN, Open Radio Access Network, and Reconfigurable Intelligent Surface, RIS. These are the two advanced technologies and also leading to the 5G advanced to the 6G you will find in that lab. If your time permits, also visit two of the pet projects of the Government of India's by the PM's office is called e-health, called Telemanas, which is on another 2 floors below. So you can see how the telecom network has been designed to collect the information across the India by a single number for mental health supports. And also in the same floor, you will find another lab called MOSIP, Modular Open Source Identity Platform, which is the largest open source and a digital platform for the world, from any academia in India to the world, which is successfully deployed in 17 countries. So I request to please visit all these labs of the COMET Foundations, eHealth, and also the MOSIP if your time permits. And between after the lunch if you have time free, but come back to all the eminent talks in this room from the industry and also the DOT. With these words, I want to stop at here and warm welcome to all of you to IIIT Bangalore for this Department of Telecom's Digital Twin Sangam. Thank you.
Thank you so much, sir, for your enlightening and motivating words. Moving further, I would like to invite Shri R.R. Mittal, Director General Telecom, for his special address. Shri R.R. Mittal is an ITS officer of 1985 batch, having experience of over 30 years of service in various capacity in Department of Telecom, Government of India. He is having vast experience in the areas of standardization of telecom equipment and network. So I would like to welcome Sir. Please give a huge round of applause.
So thank you, Kumud, for your kind introduction. Dr. Das, Director, IIIT Bangalore, and experts of the dais. It's a proud privilege to be amongst you all here on this very important initiative of Department of Telecom on Sangam. Of course, as was mentioned, the first of the series of this outreach program was in Delhi on 5th March at IIT Delhi, and the next one is in Hyderabad on the 12th. So this outreach program has quite a significance for the country as a whole. Now we have all witnessed the huge technological march in terms of communication technologies. We can start with the proliferation of broadband, then there was IoT, M2M. So there are a number of areas where we have seen advancement in technology. Then if you come to the mobile technology, we have 5G and 5G advanced. Coupled with the new features like AR and VR, it is giving a lot of possibilities for a lot of services to be implemented by I believe there are good amount of startups here, everyone actually. For the first time, we have Bharat 6G vision document. That means before the technology arrives, we have a 6G document which lays focus on the areas that we should be focusing. And I am glad to share with you that one of the features of the vision document, which was ubiquitous connectivity, has been accepted by I2R with lot of intensive efforts of the industry, of the academia, and of the government, that ubiquitous connectivity should be taken into account as we develop 6G technology. Of course, the 6G is ahead, but it is the idea is that we have a vision document. See, for the 5G, we never had a vision document in place. So that means that whatever technology is coming, we are utilizing that technology. But so there is a definite focus from department to have 6G patents in place, and I can tell you that there are more than 250 patents related to 6G technologies that we have, and I'm happy to note that IIT B here has lab on reconfigurable intelligent surface, as Dr. Das just mentioned. I'm sure it will be one of the candidates for the 6G technology. So this is about the technology development that we have. Then we have cloud. So the cloud has made kind of commoditized storage, processing, software, everything is there in place. Now, digital twins, if we say, may not be a new concept. It has been used in the product development. If you see your cars, any state-of-the-art car today will convey a lot of data to their, let's say, Hyundai or Toyota, and they will have some kind of a digital twin to predict what kind of maintenance that you need. So all this is in place, but the present initiative is for the infrastructure provisioning, which is very, very important. Under the leadership of Honorable Prime Minister, we already have India at 2047 push, that where we want to be after 100 years of independence. Okay, so and all government departments, let me tell you, are working very, very aggressively to meet that vision, to make India a developed country. So the siloed working that we were always telling, at least I can tell you in the government, it is quite integrating. The data that we have through the various verticals in the sector. For example, we have made progress in geospatial imagery through the drones, through the satellites, through the aeroplanes. So we have that data. We have a data with the telecom service providers in terms of mobility, in terms of where the workforce goes out from the morning and where do they reach. So that origination termination matrix is there. So this is another data. Geospatial, as I mentioned, there is a data. So there is a need of making it a unified data and seeing how to contribute, how it can contribute to a better planning for our cities, for our infrastructure. So this is the real crux of the kind of, not a problem, but here we are initially. The march of technology will never stop. But it is the duty of all of us to give it a direction so that we achieve our national objectives. So this is one of the forces behind the initiative of Sangam, and actually I would like to congratulate our team also from DOT, TCOE, and industry, startups, and as Kumud mentioned, enthusiasts. So they all, when we all come together, so we can make it happen. So this is the belief that we have, and I thank you all for being here, and I also thank Dr. Das for hosting us in this very beautiful auditorium, and I am sure that the deliberations today will, through which, of course, DOT will explain what the EOI process that we have initiated is all about, and we have key expert speakers. They will showcase what they can do towards this, and I'm sure together we can really make a difference in the infrastructure planning of the country. Thank you.
Thank you so much, sir, for your inspiring and engaging words. Thank you so much for everybody for joining for the inauguration session. With this, we come to the end of the inauguration session and the start of the event. So, as we start, I would like to explain the flow of the events for today's occasion. The first session will be giving the overview of Sangam Digital Twin Initiative, which will be taken by Shri Asit Kadyan, DDG, DOT. Following that, we have divided all the sessions into 3 groups. There are 3 groups, and each group will be presenting a journey from the physical world to the virtual world. And in each group, there will be members who will be from the industry who will be presenting different perspectives, like there will be geospatial players, data analytics players, visualization players, and there will be one moderator from DOT who will be moderating the session. And also all speakers are requested to adhere to the timelines of 15 minutes which is given to you, because we have got the closing session at 4 p.m. In the closing session, we will be having with us CEO from Niti Aayog, that is Shri BVR Subramaniam, and we are also having Secretary Telecom, Dr. Neeraj Mittal with us. So I request everybody to stay till then and to witness the closing session as well. So thank you all. So I would like to invite Shri Asit Kadyan sir, DDG, for giving an overview for the Sangam Digital Twin Initiative, and I would like to thank our guests for the inauguration session. Thank you, sir. I also want the volunteers to please come on the stage and, get the arrangements. If you can help us with that. For starting with the first session, I would like to invite upon stage Shri Asit Kadyan, Deputy Director General in Department of Telecom. Asit Kadyan sir has served 6 years as an advisor in Telecom Regulatory Authority of India. His expertise lies in the regulatory aspects concerning quality of service in 2G, 3G and 4G mobile networks, as well as broadband fixed line networks. He has actively contributed to consultations on regulatory matters in emerging areas such as net neutrality, cloud computing and OTT services. Sir has played a pivotal role in formulating regulations related to unsolicited communication and ensuring consumer protection and privacy. So I would like to welcome Sir for his session.
Thank you, Kumud, and thank you, IIIT Bangalore, for hosting this. When it is a right place to organize such an event, when I saw a sculpture at the down of this auditorium, there is a iconic sculpture, the thinker, the world-renowned architect Auguste Rodin. And it depicts free thinking. And it is the moment we want to think freely. We want to rethink, we want to reimagine. And it mentions that progressively and remarkably the way we think that has changed. And quality of thinking has also changed. And their results will be different. So it is a good place to organize such an event. And this Sangam Digital Twin is a Sangam because it is a confluence of mind and data. And we are at the place of Indian Silicon Valley, so it is a good place to discuss and debate on the issues. How to change this? Okay. Make it clip. This Sangam initiative was launched, expression of interest was launched on the 15th of February, means last month. And deadline for the submission is 15th of March, just very close. A few days are there. We are already having 9th March. And this is the second outreach program, as DGT mentioned in his opening speech. And first was at IIT Delhi, and second is this one, and last one is at Hyderabad on 12th. The agenda of this program is to unveil the vision of the Sangam, what it is about. We can discuss and deliberate and highlight. We have speakers who will be highlighting what the work they are already doing, and showcase the technological foundation and capabilities they have, which can be leveraged by the Sangam Digital Twin initiative. And last and the most important is this, that everybody should seize the movement for innovation. What are the issues when you plan infrastructure? There are three issues. One is that data is siloed or outdated. And when data is siloed or outdated, there is a limitation in the imagination. That reminds me the quote from the Albert Einstein, that if you can imagine, somebody will deliver it. So if you will not imagine, then you can't deliver it. So if data is related to the imagination, if you have a unified data, you will imagine more. So you have to think about the data possibilities, and for that purpose there should be a unified data. You should have access to that data and you should imagine. Second is that, especially in the infrastructure, because it is a heavy capex intensive industry, that experimentations are risky. You can't make more experiments. If anything goes wrong, it is very costly. So risk-averse experimentations are there. So either that has led to the reduction in the frequency of the experimentation, and that has led to the reduction in the breadth of the experimentation, iterations. So you can't iterate. And third issue is related to the feedback loops. Means you make a claim on the basis of certain data, but whether those claims were correct or not, means if some infrastructure was built, whether it has led to the same outcome or don't know, those outcomes were met or not. What is required is to have a feedback loop. So how this new TechEd solves these problems, infrastructure problems? So first is that if we have an enabling framework that integrates diverse data sets, but this expectation was there for many decades, that we want to unify, we want to share. What has changed in the past decade, that now it is possible, which was not possible earlier. So we will see in the presentations, upcoming presentations, that there are advancements in the computational technology that has enabled that the concerns which were related to the data sharing, like privacy concerns or the commercial sensitive data concerns or the incentive alignment concerns, have been met, can be met if you create a right architecture for this data ecosystem. So it is not just about the data sharing, it is beyond that. It is to address the concerns. And when digital twin is there or the infrastructure, you can simulate. And this simulation helps in doing scenario thinking. You can imagine what is possible, you can make any suggestions, and you can test that hypothesis. And hypothesis testing can be done if you have a data and AI models which is developed and trained with the real data. So if IoT and M2M is providing you data and you are also collecting data from other sources, and you have a good model, good data and AI model, and if somebody suggests that yes, you should consider this option, that option can be tested whether it is of worth or it is not. How that can be done. And about the feedback loop, you are not confined to the IoT data. There are many other sources which have not been leveraged so far. One of the example is telco data. Telco can provide you, and that was mentioned in the last outreach program, that they can generate mobility insights of the city, and that is more accurate, more reliable, and more recent. And that is very useful for planning and designing a metro route plan or a road network plan, which is not available with the conventional methods of the sample survey, which are unreliable. And one important, this feedback loop system is public. Today, how you are collecting the data from public, either it is through some social media or through emails or through some websites, but whether that data, whatever you are suggesting, suppose whoever is from Bangalore, he might be having some ideas that how this traffic problem can be solved. But how it is getting conveyed, if it was a powerful suggestion, how it is getting conveyed to the infrastructure planners and the designers. Whether he has a time to read through all the tweets, through all the comments and the opinions, or through all the audio clips, or through all the discussions and debates what are happening in the public domain? No, there is no time. But how AI and ML can help in this, how generative AI can help in this, that whatever is being suggested by thousands, several thousands of the people, that goes to the planner and the designer, and that goes in a manner that it is not a burden on them. It is not a burden. So it can be summarized, it can be mapped on the digital twin, and it can be evaluated that yet it is of worth. And that can be done through the data and AI models. Yeah. So its journey, how to take this journey forward, there are 3 steps. First is to create a replica of the physical world, and that is geospatial digital twin. That is a foundational layer. And we are building accurate and comprehensive. So it is already happening, but the level of the details and the number of cities and the areas which are getting covered, that is increasing day by day. And second, how to give breathing life to this digital twin. For that, dynamic data integration is required. And how to infuse that real-time data. And as I mentioned earlier, it is not limited to the IoT. You can collect data from various other sources like telcos or the cab service providers or connect cars. As sir mentioned, that many data may be available with the connected car. And I will cite one example that when tsunami happened in Japan, the normal road infrastructure was destroyed. How quickly they discovered that what was the residual in road infrastructure. That was discovered using Honda Connect car data. Because immediately you can discover that where cars are moving, where the cars are not moving. And computational technologies are allowing you to preserve the privacy, enhance the privacy, and interconnected federated digital twins are allowing you to participate in a manner that incentives are aligned. That can be done. And the last and the culmination stage is this, how to create an interactive virtual world. And we can make experimentative iterations and that. And it is easy to see. When we talk in a virtual world, even the non-IT people or non-tech people can easily see that what is happening and what is being suggested and what is impactful. And that allows to do scenario thinking, and that allows to consider and evaluate the public suggestions. So this EOI, in short, is of 2 stages. First is exploratory, and the purpose of first stage is to make clear, bring clarity, do creative exploration, and become confident to choose a specific use case and develop and demonstrate that use case. Second stage will be narrower, and the conditions of those will be emerge during this stage 1, and then we will articulate those stages. There are no financials, no commitments, no risks in the stage 1. So I request everybody to participate in stage 1. That is easy to enter and demonstrate what they are thinking, what they are planning, what can be done. So already 3 outreach programs were planned, and 2, it is second one more is at Hyderabad. And once these outreach programs are over and EOI deadline is over, then 4 networking events will be conducted, at least 4 networking events, where the players and the participants will be invited and discussions will take place. As Kumud mentioned in her speech that today's program, so we have speakers who will be talking about how to construct the future. There are speakers who will talk about the dynamic data integrations and how these advanced technologies can be used. The important thing and difference from IIT Delhi outreach program is that there is a panel discussion. We will have a panel discussion where we will invite industry people and talk on few aspects. And there is a last and most important part of this event is that CEO Niti Aayog Shri BVR Subramaniam ji and Dr. Neeraj Mittal will be addressing, and they will be sharing their perspective and how to steer this Sangam towards transformative success. Finally, it reminds me the quote from Henry Ford: coming together is a beginning, staying together is a progress, and working together is a success. So Sangam is about coming together, staying together, and working together. So unite, collaborate, and innovate to leverage unified data and collective intelligence. Thank you. Thank you very much.
Thank you, sir. Thank you for enlightening us and telling us about Sangam and how we will be moving forward. I hope everybody here will be participating in Sangam expression of interest and help us in taking this forward. Now, I would like to request Shri Naveen Jakhad, ADG from DOT, to host the Group 1 panel discussion.
Thank you so much, Kumud. So Sangam means confluence, and the confluence of eminent speakers, innovators, and experts from academia, right? So starting for the first session, I would like to request Mr. Sunil Abraham, Public Policy Director, Meta, to kindly come on the stage. Meta specializes in geospatial digital twin, laying the foundational layer that we talk in the digital twin. I would request Ashwin Jaishankar, who is the CEO and founder of Autoverse, to kindly come on the stage. I would request Puneet Badrinath, founder and CEO of Fabric Space. They specialize in reactive and predictive digital twin, to kindly come on stage. Please, sir. I would like to request Karthikeyan Subramaniam, who is business head in Samsung, and they specialize in proactive and virtual digital twin, creating interactive virtual world. Please kindly be on the stage. Please. So in the first session, what we'll be doing, we'll be having quick talks of 15 minutes each from all the esteemed speakers, and I'll be doing the moderation part, wherein each of the presenter will be presenting their presentation and showcasing, their innovative thinking and the way how they have laid their foundational work in the digital twin arena. So to start with, I would like to request Mr. Sunil Abraham, who is Public Policy Director in Meta. Mr. Sunil Abraham brings a rich experience on the stage. He is an executive, entrepreneur, and researcher with 24 years of experience working in the ICT for development and public policy research sectors. He is a serial institution builder who has founded 2 organizations, Mahiti Infotech in 1998 and Center for Internet and Society in 2008. We are glad to have you here, sir. The stage is all set for you. Please. Please give a big round of applause for sir.
No.
Okay.
Yeah, just... good morning, everyone. Dignitaries from IIIT Bangalore and DOT, ladies and gentlemen. I'm not really a technology person, I'm a policy person, so I'll take only 5 to 6 minutes to quickly thread some thoughts together, connecting what we have already heard to some of the perspective that my employer, Meta, brings to the table. So we heard from R.R. Mitter about the 6G patents that have already been applied for or registered or granted for Indian inventors. That's a very interesting balance, if you think about it, between the proprietary approach to innovation and the open approach to innovation. Because when you apply for a patent, you have to make public your trade secrets. And in order, and once you make those trade secrets public, you get a limited monopoly for a fixed number of years on the royalty or the use of that technology. And Dr. Das gave 2 wonderful examples of open innovation. ORAN, where there is a lot of open standards being developed, and MOSIP, which is an open source or what is also called a free software project. So you can imagine that in the future, whether it is Sangam or any other digital society, there has to be a balance between openness and proprietary approaches. There has to be the commons, and only when these commons exist, what is also called digital public goods. Economists define digital public goods as being non-rivalrous and non-excludable. And good examples of digital public goods are free and open source software, open standards, open data, open access to scholarly publications. If we put all those terms of openness together, what we get is open science. And that speaks directly to what Mr. Asit Kadian had mentioned. One, we will allow the data to burst out of the silos and be shared. And second, the business of hypothesis testing is more reliable if all the information required to replicate your scientific experiment is available. So therefore, this openness paradigm is very, very important. In India, when the government tries to address market failure or bring private sector participation into certain key technology areas, they use a slightly different approach. It is called Digital Public Infrastructure, DPI. DPI, you can imagine, is a way in which we bring the open world and the proprietary world together. And there are many examples of how you can make a lot of money and be very successful by leveraging open source and then building proprietary layers on top of it. For example, Apple is really the most successful open source company on the planet because they took FreeBSD and built a proprietary layer on top of that. So that is my submission to you, that we need openness, we need proprietary approaches as well, and ideally in a good situation there will be a balance. My employer, Meta, is very clear that we are on the openness side of the business. That is why we believe that we are an ally for the Indian government and for all Indian innovators and everybody else. If you go to Hugging Face or GitHub, you can download 650 open source AI models released by Meta scientists over the last 10, 15 years. You can also download 350 open data sets, which you can use, hours and hours of recording of human voice, several thousand hours of recording of various physical infrastructures so that your computer vision models can be more and more effective. But we are aware that governments might see this as some kind of trick by Meta to pull governments towards meta technologies. So especially for key technologies, we go one extra step. For example, PyTorch, we handed over the intellectual property and the trademark of PyTorch to Linux Foundation. So the future of PyTorch, which is a very popular framework for AI developers, will be handled by an independent nonprofit and will not be restricted to a corporation like Meta. Llama 2 is a very interesting open source large language model that Meta has released. What is wonderful about it is you can download it, only 2 files. One C file, 500 lines, and then the parameter file. And you can choose the size of the parameter file from 7 billion to 70 billion. Then you can have an advanced generative AI model working on your own laptop. That is cyber sovereignty. So none of the secrets of you as an individual or you as an entrepreneur or you as a government department will leak to anybody else. You will be digitally sovereign by using open source technology. So when we think about the metaverse and of XR technologies, one of the many building blocks that DOT has envisaged for the Sangam project, even there we think it would be better to build the metaverse openly so that there is no Google metaverse or Meta metaverse or Apple metaverse, and entrepreneurs like the next gentleman, who is much better than me, can build for all these metaverses without getting stuck in one. Thank you so much for indulging me with this time. That's it from me.
Thank you so much, Sunil Abrahamji, for sharing your valuable thoughts about how we need to have openness as well as coming forward approach for contributing and designing innovative solutions for the benefit of the mankind. Now I would like to request Mr. Ashwin Jaishankar, who is founder and CEO Autoverse. He brings with him a rich experience of 80 years, and he has helped enterprise in designing scalable solutions in the AR and VR segment. Please. Give him a big round of applause, please.
Yeah, am I audible? Okay. So, just a minute. Yeah, okay. So yeah, thank you everyone for the opportunity to speak here. Implementing something as ambitious as a digital twin, working with VR, AR technologies like this, it's essentially, it starts off with a dream, right? And so I want to start this talk asking you all to just join me in a small exercise in dreaming, right? So I want you all to dream, to imagine that you are a fighter jet pilot. You're in the cockpit of a fighter jet going at hundreds of miles an hour, and your objective is to land on this aircraft carrier, right? So in the middle of this massive ocean, there's a small 200-meter strip that you need to land on, right? And just think for a minute, what all is going through your mind at this point? All the things that can go wrong. A small error here or there, and you are destroying billions of dollars of equipment, of course your life, many other lives, etc. And consider that in every fighter jet pilot's life, there is a point when they have to do this for the very first time. So how do you even prepare someone for a situation like this? For years now, I think that answer has been virtual reality, right? Simulation. So that the first time they're doing this, they've already spent hundreds of hours in simulators going through that scenario over and over again, so that at this point, muscle memory has kicked in and they are adequately prepared to handle it. And the magic of technology that companies like Meta have made a reality is they've democratized this to that what was now, the simulators were millions of dollars a decade ago. Now it's $300, 20, 30K, which makes this technology accessible to anyone. And specifically, I think in the context of National Safety Week, to all the workers out there who work in extremely dangerous situations, who are asked to possibly climb telecom towers for the very first time, install cables, etc., we can use this technology to better prepare them for this kind of danger. And so, while this may be a very specific example to this industry, for the last 8 years at Autoverse, what we've been doing is helping companies like this in the manufacturing space, the industrial space, anyone working in dangerous situations to be trained first in VR before they're exposed to that real world. Right? So here is just an example of some of the work we've done for Ultratech Cements, for Tata Motors, etc. Just some visuals of what this looks like. But essentially, it is the more detailed the simulation you can create, the more high resolution it is, the more interactive it is, the more immersive it is, the more effective the training is, right? And the more the more knowledge the user retains at the end of it, and yes, the safer they are in that workspace. I'll just skip ahead. Yeah. So over the last few years, we've deployed almost 300 VR AR projects. I think we are a 100% team building out of Bangalore here. We started with it's a typical startup story, just a couple of us who were building. And yeah, over the years, we started with virtual showrooms, more marketing use cases, stuff which, ultimately this technology is wow. It started with those kind of use cases, but as we worked with enterprises, we started unlocking the real value, and that is in training. Right? We know that now training users in simulations is the ideal way to prepare them. But yes, creating these is very hard. And I think that's the question we're all here to answer, right? How do we get to a point? What is the culture that we need to develop? What are those steps to, as we scale up to that ideal digital twin where we have a virtual replica of every real world part of our infrastructure? How do we get to that point? So safety training is the first part there. I think creating amazing content is one aspect, deploying it with the right infrastructure is the second aspect. And so the product that we have created, which incorporates no-code AI editors to help you create VR content very easily, to help create these virtual interactive simulations, these virtual worlds very quickly. That's one aspect. But also, how do we now roll that out in more traditional settings? How do we make workers who maybe are not comfortable with technology like this, how do we slowly ramp them up? How do we deploy this across organizations, across thousands of workers, hundreds of sites? These are little problems that we've solved. We've helped Ultratech train almost 50,000 workers across 47 plants in the last year. And today, I would like to give you all a small demo of, this is my colleague Vishal, he's in VR. So we're going to see him just sort of go through a simple work at height training module. Just give me a second while he casts. Yeah, Vishal, you can cast now. Perfect. Okay, so he's starting off with, one sec. Give me a second. Yeah, I think you can see that there. Give me a second. Yeah. So as you can see here, right now he's starting off in MR mode. Sometimes it's very disorienting for a worker to immediately enter a virtual world without any context of the real world. So right now there are some virtual elements in front of him. You can probably see yourselves there. It's a little low resolution because of the mirroring, but yeah. We've skipped over the first part where he was asked to wear all the PPE equipment and prepared, he was also tested on if he knows what PPE equipment to pick up. Now he's being trained on just the procedures in work at height, right? So first step is placing barricades around the spot where you're going to do some work at height. He's just running through that really quickly. Through this entire demo, there is a voiceover, which I've muted for now. There is small tests so that the user that's being trained, right? A lot of learning right now is just presentations or videos. You don't know if people are actually paying attention or if they're even able to understand. With VR, all of this is interactive. At the end of every piece of knowledge, you can have a little test to see if the user actually fundamentally has understood what we are teaching them. And then, of course, at this point, he's asked to attach the lanyard and climb up the ladder. So, yeah, I think with the Wi-Fi, there's a little bit of course, it's far higher resolution in the headset. I would advise everyone that, again, try it in VR. But yeah, so he's attached the lanyard, and now he starts climbing up the ladder. If he falls down, it will also simulate that situation. You can use technologies like this to show the consequences of making mistakes. Yeah, and once he gets up there, he can also perform the task that he's asked to do. So in this case, the lockout, tagout, etc. And yeah, of course, this is a factory environment where he's being trained. You can easily replace this with, working on top of a skyscraper, a telecom tower, anything very easily. That's sort of what our platform enables. I'll just skip ahead. Yeah, thanks, Vishal. Let's carry on. So, as we've scaled our projects with different clients, what I'd like to say is, so we found that VR is kind of the gateway to fully fledged digital twins, right? How we sort of see this roadmap is you start with a small project where you build a virtual world, a use case where you can immediately prove ROI, because it's very key to win the faith of key stakeholders in the technology, in the use case. So right now, with the hardware at its present state, training is something where you can scale and begin building that infrastructure on which your eventual digital twins will rest. So in this case, of course, we've started with training. Once that happens, usually we then scale with with a few of our clients. What we see is multiple teams, multiple organizations start utilizing it for either different training purposes. Those same virtual worlds created for training are then used for sales demos or for design reviews, for planning, for turnarounds, etc. And with each team that then adopts it, your digital twin becomes richer. It becomes more real-time data can be added to it. It's also a gradual scale up in the budgets allocated, etc. And as this kind of scales, at one point you finally get to that point, which is, I guess, the dream of having a matrix-like simulation for all the real-world infrastructure you have. You're able to plan and and you're able to visualize any plan, have multiple decision makers in virtual worlds, wherever they may be able to see the consequences of any decision they make before they actually make it. A few examples is with Vedanta, we have helped them help their jumbo drill operators be trained in VR, seeing a huge drop in both training time and in costs. With Tata right now, it started with their auto components division, where every worker, before they go to the actual assembly line, is first trained in VR, can go through everything that is tested thoroughly before they go to the actual assembly line. We now work with Tata Power as well to help with training in dangerous chemical handling. And probably our most ambitious deployments and where we made the most progress is with Shell, where we have created a complete digital twin for one of their refineries and are in the process of scaling it up. But it began with fire safety training, installation training for some of their other more very complicated refineries. Each of these sort of helped us invest more and more in the infrastructure required before eventually getting to the point where now, for a refinery sitting 10,000 kilometers away, engineers in Bangalore and Chennai have real-time data streams from every machine, pipeline, whatever it may be. They can view it sitting here. They can jump into it. They have AI models running on this data to see if there is any predictive maintenance that needs to be done, to just flag any issues that may happen before. Yeah, I'm nearly done anyway. That's pretty much it. Thank you so much for this opportunity. And yes, looking forward to seeing how the DOT implements this technology. Thank you so much.
Thank you so much, Ashwin, for bringing a different perspective, how, AR and VR can simply change the way we see the world, and how, efficiently we can provide trainings at scale for handling not only training, related requirements, but for handling life emergency type of situations. So next, we have with us Shri Puneet Badrinath, who is founder and CEO in Fabric Space. Puneet has strong entrepreneurial background, worked with startups and big companies in both B2B and B2C segment. He works on tech-driven products that scale quickly and directly translate to the bottom line of businesses in B2B or create repeat customers for B2C. As metaverse becomes mainstream, his background has given him a unique insight into solutions that can create long-term values for individuals, businesses, and enterprises. So, Puneet, please give him a big round of applause.
Perfect. Works. Yes. Hi everyone, good morning. Thank you so much for your time, and thank you Asit and his team for the opportunity. Just to quickly thank the Department of Telecom for the lot of good work that they're doing. I'm running this on my 4G/5G internet connection on my phone, and I'll be doing the entire demo through the 5G or 4G that's running on my hotspot. So a testament to the work that DOT has been doing for a long time now. Try to find my cursor first. Okay, perfect. So I have a couple of examples. I'll run you through it and I'll quickly walk you through a deck. But a quick background about myself. I'm Puneet, I'm the founder of Fabric, and I've been in the startup world for the last 12 years. Fabric is the fourth startup that I'm a part of, second as a founder. I've been involved in both B2B and B2C enterprises. Fabric is the one that stuck. So started in 2018 and it's been one hell of a ride. Where we've seen traction with Fabric is predominantly in the realm of enterprises. trying to solve for challenges of digital twins, and I'll walk you through what those challenges are. But let's look at this example first, right? This is a Revit model. So for people in the AEC sector, architecture, engineering, construction, they'll be familiar with this. And the biggest challenge is running this on a GPU-driven machine with a Revit license, with skilled experts, CAD engineers. And these only when these three conditions are true is when you can open this file. Now what I have done is, with the 4G connection on my computer, this is a regular computer, I don't have GPU on this, I've been able to run and load it on my computer. This is an example of design review. So this is a building that's not present. This is a customer in Japan. They're building this building right now. And they want to do review, and they're not able to do it very quickly, because if you have to do design review, you need to have stakeholders confined to a conference room with 2 to 3 massive computers connected to a projector screen and saying, "Acha, ye dikhao, wo nahi, color acha nahi hai." So there's another person changing the color. You go through this process again, many times over months before a design is finalized and the first brick is laid. So this is one area where you create a digital twin from design to decommission. It starts here. I will monitor what are the changes needed. I will approve the design, and during the course of construction, my field team will follow the instructions given to them and then continue their process. In fact, I can replace this building with a ship, and it's the same story. I can replace this with an aircraft, it's a similar story, right? So from design to decommission is one area of application where digital twins are used, and I'm sure there'll be more such examples that you'll come across over the. Oh, before I do, this is what comments look like. I didn't like this, so I reject this, right? So this is the entire Revit model, and you'll be able to appreciate the depth of being able to load such a complex model on a thin client device like my computer. The second example is what my friend was talking about a little earlier, about the oil refinery. This is what it would likely look on the Quest 3 like. So you are looking at an entire oil refinery with real-time data coming in, with alerts, notifications telling you exactly what you need to do, how you need to do it, with step-by-step instructions, with an opportunity for you to connect with the field teams in real time. And all of this, if you notice, is running on the browser. All of us are familiar and comfortable with the browser, and the best part of a browser is it runs on all devices, starting from a smartwatch, to a phone, to a laptop, to a tablet, to a VR headset, to HoloLens, to, if Elon Musk has his way, a chip in your brain, right? And that is where we will play. So Fabric, as a technology company operating out of Bangalore, primarily works on the application layer infrastructure for digital twins. So we have DOTs, the Airtels of the world, creating the infrastructure to enable us to play, and we play at the application level, allowing people to create their environments within minutes with regular computers that you have and you use on a daily basis. Just to take you through this, in fact, you get messages that says, they in fact have a robot at site because it's a hazardous environment. You don't want people visiting. So you have a robot that goes to the site, beams back video feed that tells you exactly what is wrong before you send in people. So what we've done as a business is we've abstracted the underlying infrastructure, and we run on any device. And we take it as a personal challenge. Whenever there's a new device, we'll be running on it. And in all likelihood, while we run on all Oculus Meta devices, we will run on Apple Vision Pro within the next few days as well. All right, so what is the challenge today when it comes to digital twins? There are 3 core challenges, right? First one is accessibility, and I'll walk you through some of it in the demo, but you need to be highly skilled because you need to run, you need to work with CAD. You need to write a lot of programming code, either on Unity, Unreal. You have enough programming languages. That creates a gap. So you need high skills, and high skills has a higher cost. You need massive machines. You need computers with GPUs running NVIDIAs either on the cloud or on the machine. That is another cost. And put all of this together, you have a lot of time, right? What that means is accessibility becomes restricted. So how we've turned this around, so just to give an example, right? This is an intersection for one of the smart cities that we're working on currently in the middle of Bihar. And we have to aggregate a lot of data from the field, put it together. Now, if I have to do it with high-skilled folks using massive computers, it will take me forever, and it will not scale. By cutting down on the cost of people, cost of the skills needed, cost of the equipment, and using interface like this, which is a no-code layer, I am able to add, once it loads, an MG car in the environment. Now, if I'm able to connect that MG car in the environment with field data, car is really big. All right, never mind. So if, oh yeah, there it is. So there's a massive car, right? Now, I was able to do this. This is what a 7th standard or 5th standard child can do, right? That's the level of skill you'd need. You don't need anything beyond this. What that means is accessibility to digital twins is there today. You have data and infrastructure that allows you to connect that to digital twins today. What is left are the use cases that one needs to create to utilize digital twins for various use cases on a day-to-day basis. So I just have to resize this. Quite possibly place it on the highway. Clearly, it's still not there. But you get the picture, right? This is something that middle schoolers can do and solve real-world problems without the need for high-level skills, high-level equipment. Just with a browser and with an Oculus Quest 3 costing $500, it becomes accessible in VR as well. You can use your phones for AR and any other device that might come in the future. So let me come to my presentation, and I'll keep it short, but that is the IP that we built sitting out of Bangalore over the last 6 years, building from scratch, building technology that makes rendering possible on thin devices on a browser. And I wanted to use this opportunity to just talk about how we combine digital twins and generative AI. You can clearly see digital twins can be visualized, it's easily accessible, and it's affordable and easy to use, right? And how are we able to combine digital twins as well? And those two examples will give you an idea, whether it's a building, a facility with a bunch of buildings, or an intersection, or a smart city, or the country or the continent, right? So you can go multiple levels as well. Just to set the context, right? What digital twin means for all of us here is a combination of physical assets, processes, systems, data, tacit knowledge in people's minds, which we found is something that people tend to walk away when they retire with. Overlay all of it on CAD so that it becomes visual, easy to see, easy to understand. So one of the professors in Andhra University told me there are 240 types of digital twins. I'm not sure what those remaining 239 are, but this is one form of digital twins that people on the ground can use every single day. It's a no-brainer that you have a lot of digital twins, a lot of data that's already accessible, but no one is really using it. And like I mentioned earlier, it's because accessibility is difficult, high scales, it's not affordable, GPUs, not easy to use. If it is running on a massive CPU, I cannot use it on the field for the oil refinery guy in the middle of the desert, working at 35 degrees Celsius temperatures every single day. But if I bring it on the tablet, which is ruggedized, you could possibly find more applications, right? And that is where Fabric as a business plays. We bring digital twins in the hands of the people that matter. These are the guys who work with machines, equipments, processes day in, day out, every single day, and they'll continue to do so for the next few decades. And we bring that CAD, that 3D, that process, that system in their hands. There are some more examples. We've been around for more than 6 years. We worked with 30, 40, 50 enterprises globally. Interestingly, we are seeing a lot of traction in Japan. These are a couple of examples of customers in Japan, and I quickly showed you these. In both of these instances, these are being used on the ground for operational activities on a day-to-day basis. In the interest of time, let me move on. In the context of design thinking, combining, I'm using DT here because everyone knows what DT is. It's a digital twin and generative AI. Where are the areas of applications that we see? First is we're able to aggregate data from multiple sources. These can be field data, process data. It can be inference data from inference algorithms. While the algorithms are trained on the cloud, the inference algorithms runs on the device and it feeds data. We capture all of this data, overlay it on a 3D with various simulation conditions. You know we can already simulate. We simulate the movement of a car either north to south or south to north, depending on time of day. Simulate all of these conditions either for emergency scenarios, day-to-day usage, VIP movement, green corridor, ambulance, whatever when it comes to the traffic context. It can be disaster response when it comes to national emergencies and so on. So simulate various conditions, visualize all of this information, and make it available for the stakeholders. The stakeholders are the government departments, the stakeholders are citizens who live in the area, the stakeholders are businesses who operate out of that area. Make it visually accessible easily for them to give you comments, give you suggestions, give you inputs for you to make changes. That is when, like Asit mentioned earlier, instead of reading 1,000 tweets, you have all of it visualized easily. You put a bubble, for lack of a better word, on the 3D model. So you know if the bubble is big and red, you know there's something wrong. That is when you as a designer, as a planner, as different stakeholders, you're able to take inference, understand what people are asking for, what the comments are, what changes are needed, implement, improve the design data, and repeat this exercise 3 times. Now, combine generative AI, which generates a lot of synthetic data as well. Use a combination of these data points, run the algorithms, provide various conditions, and improve your design. Now, all of this without going through the loop of high skill, high tech, lot of time scales where the turnaround time is of the order of a few days to a couple of weeks, not few months working with a team of 20 people, developers going back and forth, 3D artist models and so on. So that is where a combination of generative AI and digital twin with the power of visualization in the hands of people will be of value for us to plan the infrastructure for a city like Bangalore, because I'm local and I struggle with traffic like all of us, or any other city for any other use cases across the planet. If you'll indulge me, this has been our vision, and these are all Apple Vision Pro examples, but you can see this, right? Spatial computers, metaverse, the Oculuses of the world are the future. And we will be the application layer that will be used to build apps on top of this, irrespective of the underlying infrastructure or the hardware or the device that's being used. Thank you so much for your time. Really appreciate it. And do join us in creating a digital twin of the world.
Thank you so much, Puneet, for sharing your experiences, how you have used the technology for solving real-life problems, and how you, have provided lightweight approach solutions for cases. Going forward, we have with us Mr. Karthikeyan Subramanyam, who is business head Samsung, and he has been working in telecommunication system for 2 decades. His primary interest has been research and development of managing 4G and 5G systems. He is currently managing 10 plus global operators as business head of management SW Group, Samsung Research Institute, Bangalore, India. He is also involved in driving operational efficiency for solution deployments that is also published in 3GPP SA5 standards. Sir, please. Give him a big round of applause, please.
प्रेजेंटेशन वहाँ से लोड हो जाएगा हाँ जी ये मूव करने के लिए फॉरवर्ड ये बैकवर्ड दिस इज 4 पॉइंट ओके ओके फाइन दिस इज फाइन यस दिस इज लोडेड
Thank you. Thank you, Dr. Mittal, Dr. Das, for hosting. For industry person, this is really a unique opportunity for us to kind of come and see how we can cooperate and kind of bring some value add to the society. And one of my proposal, what I'm going to discuss today is also about how we can add value add to the society. This topic is about, so we kind of in metro, basically in metro, we face a lot of problems. The problems are kind of because of traffic, and also it can be because of any certain conditions like sudden rain can disturb the traffic and bring a congestion in the road. So basically, a few weeks back when I was discussing with Asad, actually I heard that actually telecom KPIs are very helpful for this. I also acknowledge that, and I also feel that actually we can do something on this. So this proposal is on that. Okay. When we are kind of discussing about the telecom APIs, so how we can manage the traffic here using the telecom KPIs. So as you can see that there are, these are basically one junction where you have a traffic moving from A to C, A to B, A to D. And how can we kind of really handle this situation? To the extent that there is a kind of a less disturbance to the public. So when I say the less disturbance to the public, I need to kind of know how many users are moving from this cell to this cell. In telecom world, we call this cell because where your end users are latched to this system. So basically, when this user, basically when I say user, the user can be a car, user can be a kind of bus or anyone who is kind of using the 4G and 5G services here. So when they are moving from one junction to the other junction, we do have some kind of KPIs maintained at the standard level. So that is called your telecom KPI. And this is nothing but a kind of a unique KPIs where you will know how many handovers happens between the different cells. So there are some challenges involved here. Basically, we cannot directly make out how many users are moving from A to B or A to C or A to D. So we have to kind of come up with some manipulation in the standards to kind of bring this solution, saying that there are so many density of users are moving from A to D and A to C. And in order to bring this intelligence, we have to, as I said, we have to kind of tweak some parameters in the standards. And also, since we also need to know the direction of end user mobility, we need to kind of say that, for example, this is my kind of target cell and this is my source cell. I need to move from A to D. So this is going to be the source for me. And not only that, actually, I need to calculate how many of the traffic are moving from B to D, C to D at any point of time, and also the volume of the traffic at each point. So this will kind of give me a kind of a situation where I can program my traffic timer associated with this. So that way, actually, I will know that at this point of time and this point of day, I have this many number of cars or vehicles moving across these zones. So this is one aspect we can kind of see. But how do I kind of roll out this policy before testing it in the real world? So basically, I need a kind of a replica of this physical world in the virtual space. and I need to test with various combinations. The combinations can be anything like uncertain conditions like instance rain, social events like product launch, release of a new movie that has influence on the traffic, and it needs a kind of dynamic and optimized policy enforcement. So you can see that there is a telecom system here which collects the data, and it kind of feeds into the virtual replica, and the replica is nothing but the different instance. For example, in case of typically in Bangalore, actually where we have a work from home and work from office concept, where in typically in 5 days a week of time, you can see that mostly Wednesday the traffics are very high when compared to the Monday or Friday. So that way actually you can program your traffic accordingly. So not only that, through this actually we can also find the metro footfall in the kind of wider area. Say for example, I have a metro operating from take purple line in case of Bangalore from Chalagata to ITPL. Actually, I don't need to kind of operate all this service because some of the service till Majestic will be very at peak, and some services from Majestic to Chalagata can be very lean. So that we can also know from the footfall of the user moving handover, we will know that actually this situation can bring some kind of optimized policy wherein actually I can control the frequency of the metro in between the stations also. So this is one aspect. There are quite a challenges here, which I will discuss in the subsequent slide. So basically what we are trying to do at Samsung is we are trying to derive an end-to-end solution for any pattern. Actually, basically here we started with conceptualization. So conceptualization, what are the challenges here? As I said that we need to kind of do the performance management data. This performance management data, nothing but the cell data. Basically, this cell data will indicate how many number of users are moving across the different cells, basically. And this has to be collected, and this is a kind of a novel thing which is not there in the 3GPP standard now. So we are going to bring that, facility, build that for building the data set. And after that, actually, with this, we'll be able to see the handover pattern, including in volume and direction of the roaming mobile users. We can analyze it. And what we are going to do is, in the conceptualization stage itself, actually, we have see that how we can kind of bring an enforcement. For example, in case of traffic signal control, how can we configure green, orange, and red timer duration, and how can we plan the metro frequency? These are some aspects which we can think about. And next important thing about how we kind of profile it. Basically, say for example, some areas will have a more users and some area will have a less users. So we need to kind of build a compute resource accordingly to the type of situation we are dealing with so that it can undergo varied profile configuration. For example, one profile can help us to kind of bring a policy on traffic signal policing. Other thing can be a metro frequency. These are some of the policy which we can do in the profile creation. So whatever I am going to cover, this is a life cycle and development of digital twin. These stages, we cannot kind of really enforce in physical world without physical network without realizing it, because as I said, actually it can create some kind of problem if you don't test it in proper ways. Say for example, in case of some metros where actually I heard that basically for easing the traffic congestion, the number plate was decided basically based on odd or even number. So, but that didn't work out properly because sometimes what happens actually, one person itself can have both odd and even number cards. So these are things can be kind of quite thought about. So this can be kind of, before deploying in the real world, actually we can simulate this in our virtual world and check and then kind of enforce it. So next is about the real-time data, which we will get, and how we can go repeated analysis of the received data, ensure to that accurately is kind of reflected everywhere. So basically, there are possible that when we are doing a data manipulation, we may have some unused statistics, some statistics which are not useful for us. So these are some things which we can kind of filter out when we are doing this exercise. Okay, now, so now we have the system. Now, how can we kind of make it very robust? So there are certain things which this system has to kind of undergo evolution. So basically, what are evolutions? Say, for example, the digital twin must be able to identify and data that are corrupted. Basically, it should find out what is the what is valid data. And it also needs to kind of imbalance some kind of data in time series model. So for example, we cannot predict accidents, right? Because it is a quite unnatural thing, and it's virtually impossible. So what we can do from DT is to detect the occurrence rapidly so that we can configure that signal in a detour way, so that this way can be avoided. The points where accidents happen, that can be avoided so that we can configure, we can detour the traffic accordingly. And also, these are some uncertainties, basically, which we also need to kind of plan it in digital twin. Say, for example, when we kind of program our system, and we found that actually there are some events, local event calendars, like for example, some Karnataka function where actually there we can hear, there we can go for like massive organization of traffic. So this kind of events can be kind of inputted as external data, and also we can say that basically, for example, in case of this local, if it is a local geographical to Karnataka, if we have a Karnataka Rajotsava, so this time we can expect some kind of less traffic near the office. So these are some things which we can feed in the external data. And finally, what I'm trying to say is, even though the physical network ceases to exist and no further input is fed, the digital twin should continue to provide the value. So this should act as a rich resource of information for designing and development of future assets. So this is the overall summary I want to talk. Thank you.
Thank you so much for sharing the insights, sir. Let me tell you, telecom is one of the most complex networks, but where decision is taken in microseconds and the impact is displayed to the user within milliseconds, right? And how telecom is going to play a key role in realizing the interactive digital twins. Now, we can open the floor for Q&A, then we'll have a group photograph, right? So kindly turn on the lights of the stage. We will be having a Q&A session. All the participants who want to ask questions, they can raise their hand. The volunteers are requested to provide the mics to the persons who will be asking the question. Thank you. Anyone? Sir.
Sir. I had a question. I'm from IUDX ISC. We have a talk later in the afternoon, and I hope some of you can attend. But about telco, actually we worked with many different types of data from the city, and actually 38 cities across India. And telco is one area we don't really have much data. And I was wondering, because the Samsung person was talking about data, creating certain types of data, etc. Is it possible to share any of this data? I think it will be, even for example, a sample would be very useful for building some of these scenarios and checking it out. And we would be interested in partnering with someone like that. And also DOT, I have the same question, if they can make something available, because without data we cannot really demonstrate very much. Yeah.
Karthikeyan, you would like to have this question, right?
Okay, firstly, data, it's very confidential, basically, and also we can kind of simulate the data. Basically, we have achieved by some percentage, really a good percentage, I would say 90%, we have simulated in kind of with respect to example is, for example, this time series modeling actually. So what we did is we kind of simulated. So one way of simulation is we asked, basically a security guy to kind of note down how many devices, how many cars or any vehicles enter. And basically one thing which we have to understand is all this data are kind of maintained closely with the operators. And it is very difficult to get the data. And in fact, we also had this talk with Asad also. So we also discussed how we can kind of bring the data part to, in nutshell, what I'm trying to say is we can simulate, but getting real data is very, very tough. Thanks.
to add to what Subramaniam ji has said. Sir, we tried an exercise in Chennai wherein we used the telecom network data for understanding the mobility patterns. And in the subsequent sessions, it will be delivered by one of the speakers from Airtel. And then you will come to know sharing complete data is not a solution, sir. What we want to share is the insights or the intelligence that we derive out of that telecom network data, and we can try to share that maybe in an aggregated way. Some, privacy enhancing techniques will have to be deployed by the telecom operators, otherwise it will lead into the privacy issues. Thank you.
Hi, I'm Nagarjun. I'm an urban planner with 10 years of experience in the field. So it's not a question to anyone, but I would like to express my thoughts and then the points over here. So regarding the traffic simulation, there have been established models which most of the planning exercises we have been doing in our organizations and the field. So just wanted to highlight some of them are PTV, VISM, and then VISUM. These are the transportation models that have been there, and then most of the models has been put together to simulate and then put forward the micro level to the macro level. So we have prepared the more strategic active plans for many of the states in the country, and RAMS is another road asset management system which has been with many of the highway departments in the country. So this RAMS has a lot of information about the road asset and its management, and they do have the information on the environment and social assets along the highway systems. So that's one of the point probably you can consider while these studies have been going on with the highway departments, which has to be integrated so that groundwork can be reduced over that. And this is all in the geospatial information layers only. And second, I saw Puneet's presentation on simulations. So similar to this, there has been a move by Autodesk has taken over the MIT and Autodesk. They collaborated with an agency, and then they have worked on a spacemaker. It's an artificial intelligence. They are successfully using it in European and then US countries, the similar platform, which can simulate, and then it is also on the browser itself. So they are planning to expand to many other countries. Right now, India, many of the states on the urban planning front, the building permissions are all happening through the, there is a software pre-DCR, post-DCR, where they scrutinize whether this particular building can be permitted or not, whether it is as per the regulations or not. But the spacemaker is much more advanced, where people can also see whether ambient light is there within that building or not. So such a level of simulation has been worked out, but since they don't have access to the ground situations what we have, like what is the geology of this area, which will be with the Geological Survey of India, what is the contour levels, and then the ground points over here, which will be with the Survey of India, and then what is the revenue survey parcels, which is with the revenue department with someone else. But they brought in all these layers together to say what these are all the ground situations, these are all the building regulations, zoning codes that will be applied on each parcel of the land. Now they have brought in all the algorithms to simulate thousands of models how the building can be really coming up, and then we can select among this 1,000 and then work upon what will be if I'm going to have a sunshade more into one interior or posterior of the wall, and then how it will impact on the health of the public. So to that level, these platforms had already created. Probably these are some of the examples that can also be looked in.
I would request you to submit these kind of use cases as part of EI also. We want to create a living list of the use cases, right? So your valuable thoughts can directly go into that living list.
Sure.
So go to the website and submit the EOI and the use cases.
Sure, I'll do.
Thank you. Thank you so much for sharing such a wonderful use case. Anyone else?
Yeah,
Yes,
this is Madhu. Just have a question more. Most of the discussions are related to urban planning using the network infrastructure, right? As a part of Sangam, are we also looking to manage the natural resources, in a sense, the water usages and digital twinning, those kind of aspects also? Or I'm just trying to correlate it with the Sangam initiative itself.
So I would like Asit sir to respond to this. Sir has asked a question that whether we want to include cases where we want to conserve the natural resources as a part of the living list of the use cases that we want to build in digital twin Sangam.
Yeah, this infrastructure, Sangam initiative includes all kinds of infrastructure, public infrastructure. It includes water, it includes transport, it includes electricity. So, but it is from the perspective that how these technologies, the advanced technologies can help. The sectors can have their own digital twins. So it is not that it will be a single digital twin, what we are aiming to. It is a interconnected, federated digital twin model. So sectoral digital twins will participate. So how that federation will took place, that will be debated as a part of the Sangam initiative. But core expertise and the domain expertise will lie with the sector, and they will be doing their task. So that is how we are planning to handle this.
Thank you. The reason why I asked was predominantly the discussion is on the urban infrastructure and probably the metro infrastructure. But if there is a COVID kind of scenario, how to kind of...
Yes, the disasters, the emergencies, use cases are already there, and we have a living list of use cases. So you can submit your use case. That will be discussed during the exploratory phase of the Sangam initiative. Sure. And then which use case is to be picked up, that will be decided during stage 2.
Sure, thank you. Thanks a lot.
Thank you so much, sir. So before conclusion of the session 1, okay, please, Ji.
So it's a continuation of the question that was asked earlier. So does Sangam Digital Twin Initiative also, for use cases in the healthcare sector, health digital twins, for instance?
We have not constrained ourselves to a number of list of use cases. We want everyone to come forward and participate in creation of a living list of use cases, which will be discussed and deliberated during the exploratory phase, and then we will finalize which of the use cases we want to take forward in near future and which are the ones which can be taken in a longer term, right? Okay. So it is not restrained to maybe urbanization or urban kind of sectors, or maybe conservation of forests or something related to natural resource. Everything you want, whatever comes to your mind, you can submit as a part of living list of use cases.
Okay, a follow-up. So are there any specific constraints that we are supposed to think about in terms of data that we are going to use? Should it be data related to telecommunication?
No. As sir already highlighted that during a disaster in Japan, the auto connect data was used for finding the alternative routes.
Okay.
Right.
Thank you.
So before summing up the session 1.
Just a moment, I can clarify, that is important. So means whenever we will be submitting use cases, there will be some expectations from where this data will come, the kind of the data which is required for that purpose. That can be mentioned as a demand, that if this data is available, what can be done, what is possible. Who will provide this data? Will the entities or the agencies will also be participating in this Sangam digital twin. So data seekers and data providers both will be there. So it is not that DOT will be providing the data. Data seeker and data provider both will be participating in this initiative, and they can talk to each other and then devise a mechanism how it is to be handled.
Thank you so much, sir. We can conclude the session 1 now. Before conclusion of the session 1, the digital twin the telecom technologies and the AR, VR, they are not simply, used for training purposes. And simple training purposes can also result in saving of precious human lives, right? If you recall the, disaster of 2nd of January, wherein Japan Airlines, they had to do an emergency landing. The rigorous training that was, imparted as part of digital twin initiative of their, organizations, it saved 316 lives during that moment of disaster. So I would request all the speakers to come forward for a group photograph, then we can conclude the session 1. Thank you. Kindly come forward.
Good morning, everyone. I'm Pranay Divakar. I'm Assistant Director General in Department of Telecommunications. And for the group 2, I'll be the moderator. So for the group 2, just please, So for the group 2, I'll be requesting our speakers for the group 2, Mr. Alan Govan Manikam from Nokia Bells, to please come upon the dais. Dr. Dhiren Singh, Founder and CEO and Air Quality Specialist from Airshed, just to please come on the dais. Mr. Pulin Patneja, AVP from Airtel, just to please come on the dais. Mr. Prasad Kulkarni, Vice President, Oracle, just to please come on the dais. Thank you so much, the esteemed speakers on the dais. So as we are running a bit short of time, so we'll go faster. And I would request all of my fellow speakers just to please adhere to the timelines of 15 minutes that has been given to each of the speaker. So going ahead with this session of the group 2, I would first request Mr. Alangam Manikam. He's from Nokia Bell Labs Space. Mr. Alangam has around 28 years of IT experience, in which 24 years of experience is in the telecom only. He's having experience of Nokia of around 17 years. He's currently handling research activities in Nokia Bell Labs, Metaverse team, robot mobile orchestration and digital twin project. He has strong background in telecom core, telecom applications and database technologies. He authored multiple IPR initiating the new feature and products. I would now hand over to sir. Please load the PPT.
Hi, good morning all. Can you hear me? Okay, thank you. So I am from Nokia Bell Labs from Bangalore. So we do some solution research on the metaverse. So based on the solution research, whatever we have done on the metaverse from the factory side, I would like to take this as an example and move forward, because this is totally done by the Indian team in India. So I would like to start from here. So the product name is called, or the solution name is called FlexForce, which is called Metaverse-based Intelligent Factory Management System. So the Metaverse as a solution, it brings a lot of technologies, as you know, the XR-based digital twin, and also, as you know, these AML technologies for various anomalies or various use cases. And also it brings the metaverse, it can keep on adding the other applications. So we can see this, and also like the decentralization is one of the other things we can look at. For example, we can take the privacy and what level of privacy we can send it to the other guys, like what others can see, or like the access, all those things we can see. So I can start from here. And also like along with the indoor, so this factory management, whatever we have done is for the indoor, and also like I am also along with indoor, I am also taking the geospatial digital twin. So basically we can create the indoor or outdoor digital twin with the digital models, and you can see the fusion of, so basically the digital twin is having the fusion between the digital and physical models. So basically how do you fuse? Fusing is the main, the term that is used in the digital twin, because we have to fuse the connection, otherwise we will not give the life to the digital twin. So the idea is to be able to collect the data. So the data is as much as possible that you can collect it, and that's what we have done in the factory management system. And also we can see how it can be used with a geospatial digital twin. So the mobile data is expected to be used with, for predicting any traffic movements or traffic managements, and the traffic movements could also include what type of vehicle goes, for example, the ambulance goes, or the school bus goes, and so on. And also all those things we can do. And the data will be used for the infrastructure planning and public safety, all those purposes. For example, even it can be used for when the ambulance moves, we can find out wherever the emergency happened or any accident happened. So based on that, we should be able to simulate the situation, and we can see which the ambulance can reach the spot very faster. So those things also we can do it from here. So what we will be doing in this presentation, I am trying to bring up like what we have done in the industrial automation, and what we are planning to do the future enhancement, and also like what we can do or what we are supposed to do to meet the geospatial digital twin. So for example, this is a sample thing. This is a normal 4-road junction, what you see, and if a person with the MC1 goes from this, the first corner, and he is supposed to go to the second corner, you are seeing this, then you will also realize if there are so many MCs are going, just I am saying the mobile movement, it can be any kind of devices. So if it goes from A to B, then you know that like this is another path we can do, or the infrastructure movement, infrastructure changes that we can do. So this kind of the entire digital twin and simulation, all these things are possible by the data that is available, already available from the any telecom industries, and also the any infrastructure that you are having. For example, you are having CCTVs. From the CCTV, it's also possible to see any suspicious or any kind of unnoticed the material. Those things you can immediately bring into notice and all those things. So these are all already it's already available in most of the digital cities, and this is the same this kind of the support is also possible, the implementation whatever we have done already for the factory management system. So the traffic management that I mentioned with a lot of use cases maybe, and also you can see the digital twin which can be used for the simulation purpose. The simulation is also, it's very important to build the infrastructure, this kind of things. So once you build the infrastructure, it is always, it will be wasted if it is not going to be really useful. So we have to do the simulation, and we can see, for example, as I mentioned, the MC1 goes to the next level, maybe the next state probably in 20 minutes or 5 minutes, and if the other person, if you take the straight route, probably it will be in 2 minutes or 3 minutes by using the same mode of the transportation. So that way you can see like how many, the number of MCs, if it is going, if it is, for example, more than 50% or something, then it's probably the best use case to bring this. So this kind of simulation you should be able to do. And also the connectivity management is one of the main thing, which also I am going to talk in the next few slides, because the connectivity management, like Nokia is being the connectivity company, we need to take care more on the connectivity side. We are already like supporting a lot of connectivities, like how do you take the connection from, for example, you are having the 5G private network or something like in this kind of network, how do you take the connectivity management? For example, if you have the public network, public telecom network is there in that place, how do you take the connectivity support and all, we can also see. Okay, now I am trying to go to the next one. So this is like, as you can see, like the main important thing in the digital twin. So since, as I already mentioned, we are doing the solution research. This is one of the solution digital twin, which it will give you the end-to-end solution for the digital twin. So the first portion, whatever you are seeing, is the 3D visualization or the 3D models, or I can say this is called the digital twin that you can see. The next one is the place from where you are getting a lot of the data coming from the various resources like the sensors and also you can take a lot of materials there, and which also you can see there is a machine data. So there is a multimodal data, we can use it. For example, you can take the data from the different sources, and you see like how we can bring into the multimodal, maybe the AML kind of scenarios, and how can we like try to find out if there is any anomaly in the procedure that we are following, or if there is anything different from what we expect, and so on, we can see. So in the factory system, as I mentioned, like there is a digital twin of the factory is there, and also you can take the data from the various resources like, I mean sensors, I can say the PLCs or cameras or whatever it may be, and you can see the machine data. For example, the machine data will say like what is the stage of the movement of the, for example, PCB or the conveyor belt and so on. And the last one, you can see if there is any live camera feed, you can keep it for finding out anomalies. For example, we are manufacturing the PCB, and in the PCB, if you are finding any difference in the from the normal way, then we can immediately come to know. And all this data, we can collect it with the different, maybe protocols, and see, as you know, like the different sensors will give the data at a different frequency. For example, one sensor will give the frequency, maybe like the data will come maybe once in a second. Maybe the other sensor comes maybe tenths in a second or something, 10 times in a second. So those kind of data, how we can correlate, how we can take the data. For example, when your system goes for overload, not only the system or network goes for the overload situation, then how do you take the important data? Because otherwise your, the digital twin, live digital twin will not work. So those kind of scenarios we have to look at. And all this data collection comes into the picture, then we can see the overseer, means this is a place we'll have like different AML technologies for trying to find out any anomalies and so on. And also like we have the gatekeeper. Gatekeeper is the place where we have, for example, in our solution, like this is also like, we have shown in the IMC time. So the gatekeeper is the one place where we are keeping the blockchain-based, ledger preparation, and also like whenever the issues comes, it will be creating the, the kind of ticket for that, and the ticket will be open till it is getting closed. So till then, that means whatever the product you are, producing, we know that that is wrong. So we have some bug on that. We have to rectify those. So those are all the data will be, kept in the gatekeeper. And maybe like, so this is the place like, again, like we are trying to bring up, few videos like here. The first one you can see like this is the, how do you bring the 3D, digital twin for assembling and finding the simulation. This can be, whatever we have shown is here for the factory environment, but this is also true for when you go for geospatial environment, for example, either digital city, or you want to go for any kind of, like the infrastructure management, you want to bring some flyovers or metros and so on. In that kind of scenario, what we will do is like, we'll see, maybe I don't know, like. So how do I like run this, the first one? The first slide? Yeah. No, yeah, the first one is, the different things are videos.
So please try to run the video. Yep.
So can I click the next one? Maybe let me try. No, it goes back to the...
Goes back to the last slide. It is having the videos embedded on that. Can you please run them?
Yeah, the first one?
Yeah, in this slide.
The first, can you go to the first one?
Can you go to the first one, the force?
Yeah, please.
Yeah. Please go ahead.
Yeah, so this is the, where you will build the 3D modeling. And for example, this is the, assembly line. I'm not showing the exact assembly line because that's also having a lot of IPs. So you can see this is the kind of assembly line we are having. So whatever the material or whatever the new, cell you want to, bring it here, or you want to make the changes, because it's always getting changed for the product to product and so on. So we'll be maintaining a 3D library, you can see, with a lot of 3D models. These models, you will either get it from the supplier, or you will get it from, or you will be like making this by using like any 3D or the point cloud technologies, whatever the technologies we are having currently, we make all those things. Most of them, like we are getting it from the vendors. So once you get the 3D library, you try to find out what is the model you want to place it here. For example, this is one of the 3D model you want to place it at, in some places in the assembly line. This is maybe like for the new product or whatever it may be. So then we'll find out the scaling and location, all those things, and we'll try to find out the exact place where it's supposed to. Once you trying to download, it will be showing here. You want to you are trying to adjust and where it can be placed exactly. This way you can. This is for the the factory purpose. This can be you can do the similar kind of thing for any flyover. Building the flyover or building any kind of infrastructure. You should be able to do. And once you find making the changes in the digital twin. So for this you don't need to have any expertise. Normally the factory operators or users only doing it. Once the finding the placement, exact placement for the, the cells, you can place it, and also not only cell, it can be, this is the same thing for the conveyor belt and robot and so on, everything. And the next side, you can see the data. So this is one of the important area where it will show if the data collection is not proper, it will show the latency between the real and the digital. So if the real is, you are getting the data maybe maybe 10 o'clock 21 minute and 20 seconds. You are expecting the data to be in the same seconds, maybe something like 1 or 2 milliseconds. But normally, if you go in 4Gs, like what we have seen for kind of data of with 50 messages per second, the rate at which you are sending, probably the data you are seeing at the other side may be at the 10 milliseconds or 20 milliseconds or something now. But we are trying to see how we can do this. But this is what I am saying is a simple, the JSON structure data. When you go for any kind of the media data, this goes up. It shoots up a little bit more. So that we have to see and also we are seeing in 5G, trying to bring up even a little bit better. And also in 5G, we are having, when you use the private, 5G, there is a, the slicing is not there. So in that case, how can we go for the slicing also, the other things? And okay, that is the first one. Okay, the left side, left bottom. Yeah, so this is for once you find anomaly, how can you visualize? So you can do the visualization of the issues, whatever you are finding. Maybe for example, there are some screws or bullets or fell down on the board, and this may be due to any robot when it is picking the data. This is happening in many places we have seen, not only in our Nokia's factory. It's happening normally in most other cases. So those kind of anomalies can be found by our anomaly detection. So this is a simple case. This can be visualized or interacted through any kind of technologies. Right now we are using the VR headset, Oculus VR headset, we are using it, and also we are having some other way to use it through the AR model, and that is one. That is one thing. And the last video is on the gatekeeper. Can you please play the last one? So the last one, yeah. So there you can see how we can create the ledger of the different issues, whatever you are finding. And this is the kind of, it's not in the full sequence. And you can see once the issue is found, this can be allocated, and also you will be seeing the issues through any the email technology or maybe the SMS. The operator will immediately come to know on the same cycle of the product, whatever you are seeing, it will be corrected on the same cycle only. And the time taken is we practically seen maybe 1 or 2 minutes. I think 1 or 2 minutes in each stage. If there is any issues, I think it should be fine with the factory as of now. Okay, why I'm explaining all those things is the same way we can use it for the infrastructure management or any kind of the digital geospatial digital twin also. So maybe this is one slide for only the anomaly detection. So this is a very simple technology we are using. Only the AI algorithm we are using as a different one. You can see you can see the entire pipeline, and so there is the robot is giving or doing some activities, and you are seeing the PCB. In this case, for example, you can just imagine there is a PCB image is coming, and the PCB image you can see either normal image or non-normal. Non-normal could be abnormal, or the anomalous image is coming. Then we do the whatever the data is coming, we try to identify through padding 80 or like, reconstructive, patch algorithm. We are using some ML algorithm to find out what, why the error is coming, what the error is coming. If there is any error is coming, like immediately we try to, categorize as a anomaly or non-anomaly. If it is non-anomaly, like we are trying to take the data again as a trained data. And if it is non-anomaly, then also we are taking it. And the other way, like if it is anomaly, we are trying to show it in the digital twin and also on the gatekeeper to, booking the ledger. And here, the one important thing is like in the real life, it's also very difficult to take the training data. And to take the training data, we are creating the synthetic model here. We are trying to create the synthetic data and we are trying to use it here. So, okay, this is the different, anomalies you can find. Maybe like not one single object, maybe the multiple objects can be seen. And okay, so this is the next thing, like whenever you are seeing any kind of issues, how can you correct it? Maybe like today we just tried in some scenarios in the factory, we are trying to send maybe like some avatar or somebody inside the digital twin and trying to correct it. Maybe like only few scenarios we are having here. One is, like when the default position of the robot is changed. So this can be corrected by some human being, some avatars that we are sending it. So actually what we are doing is like whenever there is somebody is going and doing some action, either by using the sleeves or wearables that he is having, then we are trying to do some action on the robot itself to reset it to the default one. So that's what we are doing. Apart from that, we are doing some other activities like, for example, whenever there is you want to start the entire system or stop the entire system, there is a reset button is there. You can use the joystick or something from the Oculus or something. You can go and press the button through the VR, the virtual environment, then it will be happening in the real by executing some commands. Okay, this is like one of the simple things that we are already doing it. And okay, so this is the same way like what we can do with like the digital city or something. Like we can try to create the the 3D visualization of the city. So I'm not getting into the details of like how to create the visualization of the 3D city, because there are a lot of today there are a lot of ways you can do it by the drones sending somewhere, and you can create doing it. And also the same mechanism we are having it, and also the key portion in any digital twin is the second stage. How are you going to collect the data, and how fast you are going to collect the data, and what is the frequency that you are going to collect the data, so that the accuracy of the data is very good. So that the second is very, very important. And third one, you can see like we can use the cell towers and also like the cameras and also fast tag. Any kind of technology you can use it like to pull the data that is like the mobile data, the moving data that you can see it, and also there are a lot of 5G localizations or the SRS or something. You can use whatever you want. So all those things, these are all the main data that you can use it from the existing today what all the data we are having it. So all those things we can pull the data, and we can do the data collection. Again, this sensor data is very important, which is going to take like how much time we are going to use it. And you can see the last two areas are the same. Okay, I'm going to, this is the last maybe slide. And you can see here the first one is talking about how we are going to collect the data, sensor data, and so on. The last one is the 3D model map. So 3D model map, if you are having it, for example, in any geospatial database, you can have it like, for example, PostgreSQL or any kind of database, you can have it. And you can keep the entire model into the geospatial database. And the idea is, for example, like wherever you want, for example, you are in Delhi, and you can have a Delhi, the city map. I'm talking about the 3D map, and you want to zoom in or you want to see something, you want to have a very closer look at Karol Bagh or something, then the best idea is you can use this kind of 3D map. Means like you'll be having a bounding box, or you'll be having various technologies in the geospatial database, and you can look at only a particular, the model or the particular map, you can load it and you can do it. So this kind of things, you can see it in your mobile phone or any kind of phone, where your rendering capacity is not very much required. And the public safety and all, this can be very much useful, as I mentioned, like identifying any unnoticed or suspicious materials in this and do our similar anomaly technologies and so on. Okay, so this is like only like this is one of the another digital twin which is already running, so live. You can see like the person whatever he is doing, that is the only action. It is happening through the like manual. Others are it's doing automatically. And this is the manager view, whatever you can see. So when you see the same view, you want to give it to some, for example, that's a home run robot. Home run robot, you are calling the home run engineer, and the home run engineer is not able to reach the factory or something. He can see it from his place, and he can have the access to this the digital twin, for which we are going to give only the portion of the digital twin, not the entire digital twin, so that like he can get the access only to this, and he can operate by using whatever the facilities are provided remotely. So that is also possible. So this is also like kind of like privacy technology we are using here. Okay, this is a lot of technology. I mean, the devices that we are having in the Bell Labs already in the research, we are using it. And anyway, like this is also like how can you get the immersive technology experience and all. I think like that's all from my slide deck. Maybe I took a little bit more. Thank you.
Thank you so much, sir. So thank you so much for giving the insights into the Nokia solutions and the systems that are available and how they can be aligned to the Digital Twin Sangam initiative. So now moving forward, as we have understood that how physical world can be changed into a digital world, and now how the data can be fed from the different sectors like of environment or the telcos. So we'll be moving ahead with the presentation from Dr. Dhiren Singh, who's founder and CEO of Airshed Planning Professional Private Limited. He has worked with Sony and Sapient Technologies for Massachusetts Institute of Technology, Cambridge. He has completed national endeavor projects like National Air Quality Index, Niti Aayog Cleaner Air Better Initiative, Qatar Petroleum PM speciation study and air pollution study for Delhi, Kanpur, Agra, Jaipur and Taj Mahal. He has also developed the IPPU framework for the entire India to estimate greenhouse gas emission for the Tier 3 methodologies. He became an entrepreneur in the year 2017 and started a company, Airshed Planning Professional Private Limited, which mainly works in the field of air quality. I would request sir to please give his presentation.
Good morning to all of you, and this is the first time I have been to Bangalore, and I thank Department of Telecom to let me know that I am way off from all these technologies, since I moved from computers and all coding in the year 2007 and more into the scientific world. So I decided to incorporate this company in year 2017, which basically works in the field of air quality. So we have the three verticals. We are providing services in the field of environment, be it air pollution, water pollution, indoor air quality, and then we are also developing some products for other various stakeholders like MOEFCC, Government of India, and we have our own R&D team of around 10 to 12 professionals, and we are an incubating company in IIT Kanpur. So we have some technological license available with us that we are using to develop the product for the scientists and researchers across the globe. So we have nearly completed around 50 projects globally in the field of environment and air pollution both. So these are our few clients, and I'd like to move. So before, as you know, I told you I have moved into the scientific field. So I want to get into the first wanted to give you a feel of how air pollution system works and all system works. So on the left hand side, we have this, sources, we call it as in source, and the transport medium, which is atmosphere. So, and this air pollution, you have an N dimension. So if anything is released into the atmosphere, so you don't have a control over it. And then we have ways to check whether the air quality is good or bad through measurements on the receptor side. So nowadays, I hope everybody is aware of air quality and air quality index. So the government of India came up in 2015 with air quality index, which gives you a single number, and then that is directly associated to your health. If air quality is say 50, it is good, 100, it's moderate, or 400, it's severe. Nowadays in Indo-Gangetic Plain, so we have a severe air quality issue. So, but the main thing is you understand, like in any pristine environment, you do a monitoring, or you do a monitoring at, say, in Bangalore, and one number will come up, say 100 microgram per meter cube. So, are they both same? So in terms of, concentration, they are same, but their composition varies. That is where these, particles are very, very, adversely affecting our health. So over a period of time, interaction with professors of IITs, NIRI, and other institutions, so we developed some products in the form of, you can say, a collection of services to assess the air pollution impact on human health and how to mitigate them. And one thing over the last 10 years or so, where our government of India and stakeholder, finding it difficult how we can, manage this very important issue of air quality that is entirely related to our society. So we have come up with a product. I'll straight away show it to you. That is the real-time source apportionment. So you can go to any website, they will give you a number, 200, 300, and then the question comes into our mind, okay, this is 100, how we can go down to say 40 or 50 or maybe 15, which is the desirable limit. But still we don't have any solution to quantify it. So that is where our role comes into the play. So we give the breakup of those 100 into in terms of source contribution. Like this much is coming from say cement plant, this much is coming from thermal power plant, and this much is coming from vehicles. So that sort of thing we have developed. And since one of the speaker told the power of visualization is very, very important. But unfortunately, we don't have any kind of, you call it as meta or any simulation program where we can do all this kind of stuff. So I'm open to, getting collaboration or anybody who can, help us out in this field, say in terms of simulation and all. So this is what we did it for Delhi, and we developed a portal where all the data dissemination is open to public. So we were able to do, if somebody wants to see how on daily basis, what are the sources which are contributing, to my breathing level, what I'm breathing in. So you can straight away see that like this orange one is the green one is the vehicle contribution, biomass contribution, and the road dust contribution. So this looks like an, prior to 2020, it was in a form of charts, some schematic graphs, but that was not easily understandable by the regulators, government, and a normal public. But now we have developed the automized all this thing. So I'll show you this previous picture. So generally the scientists and whosoever involved in the air pollution, they used to do a sampling and then do some chemical characterization, chemical analysis, and then identify the sources. So what happened with the traditional, all the analytics and all, the time was somewhat around 6 to 12 months, and the government did the report by somewhat around 15 months or so. But what we have developed this product, you are getting on the hourly basis and on the daily basis. So this is daily basis, and you can also see on the hourly basis. So this is something very important to understand the pattern of, the sources which are contributing at our breathing level, so that this tool can be used in the decision making, by government or anybody who wants to make want to work in the field of air pollution. And this data is open to all. Anybody can go and access at the website called ourasman.com. And you'll also see, and then we have coupled so many scientific tools into this particular product. Say, for example, on the left-hand side, you can see this is an episodic event. So on 30th-10, so the particle concentration rose up to more than 600. So what are the causes? So we also integrated this backward trajectory model into it. So straight away at the height of 10 meters, you can clearly identify this is the wind parcel which are coming from this particular location, and you can clearly know what are the geographical location, what are the sources in those geographical locations which are contributing to your in the air pollution at your what you are breathing in. So this sort of solution was not available in our field, and then based on the same back trajectory model and the wind flow pattern, you can identify the area which are affecting or contributing to your breathing level. So here, I hope everybody has heard about the Bhopal gas tragedy. So what happened there was, consider this as in Bhopal, and the wind direction, predominant wind direction was from this side. And the factory, Dow Corning factory, was on the upstream of, the entire town. So accidental release coupled with wind velocity and wind direction, it goes to the entire town. That is how that disaster happened. So one of these scientific knowledges and what we have developed, the government and DOT can take advantage of, placing the big industries, refineries, according to the siting, where it should be placed. Maybe it should be somewhat downwind, or whether you allow them into the upstream and things like that. So you can take the government can take a decision, regulators can take a decision, and even the citizen, concerned citizen, if something is coming in the upstream and they are releasing something hazardous, so they are also now empowered with this tool. They can see and oppose that, okay, no, this is something is not in our favor to the entire population who is residing on the downstream of the town. And then something, molecular markers, which sources on that particular episodic event, which are the most probable, sources. So, and then we have, especially for the governments and the regulators, this is an automated control action plan which we have developed. So if you can see here, there are the two major prominent reasons for this particular point have been identified. This is region 1 and region 2. So the vehicular source is the prominent one. Secondly, they are long-range transport. So if somebody wants to, develop a policy or want to take a corrective action, so now they have a luxury. What would be the priority of sources? Where to tackle them? Where to take which source to cater first? So that sort of decision-making power is available with us. And based upon this is some priority, we will give it in automate. Just wanted to show you, the professor from UC Berkeley has visited us, and you can see this, his remark in the red box, thrilled to see this happening in India. It's actually way ahead of what we are doing in US. So maybe this is one of the key area where participations from the technological companies, government, and other stakeholders who can help in this cause, which is entirely related to society. So, and then I'll straight away go into this, and then while for the last 7 years, we are working, we have integrated GIS into in our every solutions. So this is the city of Hyderabad, and this is the area where more pollution emission is there. Now we have the static model, although it's not dynamic, and you can see there what are the source contributions. So straight away you can go up to this particular source, this particular source. So it is a decision-making tool which is directly impacting to humans. And this is one of the assignment of e-waste which we have done. So this is why I'm showcasing this to you, because still we have a lag. So there are so many people who are working on the digital models, simulations, things like that, but currently nobody is in this particular domain who can give us the luxury to put a source anywhere across the city and then simulate with the meteorological conditions, things like that. And that is where I'm keenly looking at the digital twin, because if vehicular pollution comes up, we were able to assess that, but the scenario like how the modal split is there, how many trips, from where it is originating, where it is going, so that sort of information can be, this particular information can be integrated with that, and it would be very much beneficial for DOT, Government of India, and to every citizen of this of India. And this is another thing which we did in water supply. So currently you can see this on the Ganga basin. So all the STPs along the river, all industries are lying here. All the treated effluent is going into the river. It was supposed to reused, but unfortunately not due to geographical locations. And so I don't think, thank you very much.
Thank you so much, sir, for giving us insights about Asman and how this has been appreciated by the foreigner countries also. So now we'll be moving ahead with one of the data infusion that is from the telcos, one of the leading telco. We'll be having Mr. Pulin Patneja, AVP from Airtel. Mr. Pulin is leading Airtel's network data lake and CLM projects. He has 18 years of industry experience, and his team, consisting of data engineers and data scientists, is dedicated to devising effective solutions for enhancing network performance and customer experience and helping Airtel to make data-driven decisions.
Hey, good afternoon, everyone. Hope I'm audible to everyone. So we are here to present the side of the Airtel. We all have seen the use cases of the digital twins, right? But for every digital twin to be in production, the first thing would be basically the data. Where will the data come from, basically? Because we can all create the machines around, but the fuel is obviously the data. That's what we are going to present. The use cases that we are trying to solve in Airtel, and how our infrastructure is going to help the different use cases, basically. So there are different digital twin use cases. As someone said, that there are multiple options multiple digital twin options available as well in the market, right? So one of the major use cases are the new infrastructure planning or the retail planning that we are going to go through, because we have the cities in place which has grown exponentially during the recent expansion in the infrastructure in India. But we never planned for the cities like this. We planned the cities as we grow, we keep on building the system. We never created the cities for the future, basically, right? With the technology in hand now, with the data in hand now, it will become more easier and more fine-tuned cities to be made that can be made for the future, basically, rather than only for the only on the need basis, right? This can also be used for various emergency procedures, or maybe the pandemic that we went through, how we can use this data to basically cater where the cluster is moving, how the cluster is moving, right? We can define all those things using the data, and also how the whole urban planning of the transport will be happening throughout. That can also be done through this digital twin, by creating this digital twin, basically. And also on the, for example, we have many events, for example, a Kumbh Mela kind of event, how a digital event and digital twin can create and find out that how many users are coming to that location, from where they are coming, for how long they are going to stay, based on the historical data as well, that how much demand and how much planning do you have to make this event successful, so that we are able to cater the different kind of people that are going to come from different ethnicity, from different religions, from different states, from different genders, what kind of facilities that we have to cater to, so that we can plan the whole infrastructure accordingly, or the whole event accordingly. And for that, the data would be the key for that. Right. So, as I already told you that the basic infra requirements, wherever the infra projects are there, right, data will be the need for this, providing the fuel stations, the health, education, etc., where the people are right now, what affinity of people are there, what specifics of the people are there, right, and we can plan accordingly. For example, in the urban, take the case of urban city transport planning, and we had an association with DOT for a small POC for the metro project, for the metro planning project, that for which we did the POC that how we can identify that how many people are going to be there, right? When are they traveling? In which mode they are traveling? In what volume they are traveling? And what route are they taking for this travel, basically, right? And how can we answer the questions like, is this the same trend in the weekdays? Is this the same trend in the festivities? Is this the same trend in the cases of some weather movements, etc.? So how we can plan the whole infrastructure accordingly, so that we can create our road infrastructure, our roads, our signals, all the things, our fuel stations in place, so that we can make these things running smoothly, even if there some calamities is happening. With that, how can we plan this whole infrastructure accordingly, right? So the ultimate idea of this POC was to find out the different clusters in Chennai, basically. How many clusters are there and what are the movements are there. So we were basically defining the OD matrix, the original destination matrix of the movements of the users from one location to the other location at different time frames of the day. So this is how the cluster is moving. I guess the video is not playing. This is the GIF. There's some issue with that. This is the cluster movement throughout the day in a Chennai circle for different users throughout the day. How they are moving throughout the city, basically. Now, how Airtel helps in these use cases. So Airtel has over the years have created infrastructure around the data where we have the connectivity, we have the inbuilt cloud where we are processing all the data. We have our own data centers to cater to all this data. Basically, we are and all the things are anonymized under security, so that there's no data leakage there. There's a data privacy over there, that no one is able to find out that for specific user this thing is happening. Everything is happening in an aggregated way, right? In a cluster way, right? Then we have created a layer of CPaaS. Then we have integrate different IoT, we have created an IoT platform to integrate with the different IoT devices. All the things are in place. So this is the kind of data that we are processing right now through our data centers. We are daily getting around 1.8 trillion records every day. That's the real-time data, most of the real-time users, signal strength, networks, health data, networks, health metrics. All the things are coming in a real time, and we are taking the decisions. We are solving the user's problem, finding out. Based on our various projects, we are able to solve the customer's problem from which used to take 30 days to just 3 days, and which has accuracy of 65 to 70% to around 89% accuracy. Because of the different feeds integrations that we have made, we have the data that can help the call centers and the field and the people in the field to solve the problems as quick as possible, so that we can provide always the best customer service to the end customer, right? And that's possible because of only the technology, only the whole data that we are able to cater into our system. We have data centers with the 30,000 plus CPU cores, 50,000 daily data processes. These are the amount of data we are dealing with. These are the amount of processing we are dealing with, and we are we are improving the customer experience. We are creating new solutions around it, that how we can make the whole ecosystem work around, right? So these are the three things that we have divided our data lake into. One is the customer 360, that is the customer's data, their affinity, their choices, where they live, and all those things. And also then the network, it's all about the network devices, the cell health, different antennas health, different microwaves in the power lines, different devices till the customer end, right? Even to the modem, what are happening around that, and how much is there any leakage over there? Is there any connection problem over there? Preempt that and solve before even reducing. Before even they're raising the complaint, to make the complaint as minimum as possible. That's with that agenda we are building our systems. Then also the product 360. Product 360 is the act around that, how we can contribute to the, for example, to this project of the urban planning, and also how we can create more systems around it, which enhances our customer experience, right? So different systems that are, for example, the recommendations, what kind of products to be sold to which kind of users, and what not to sell to which kind of users also, right? And what are the next best actions, where our site should be, right? For example, the amount of people are living over there, there are less number of sites over there, right? How we can plan our sites accordingly, so that we can provide the better services to you, and we can create our towers in that area, so that we can we can give the better signal strength. Right. So this is what a typical data use case, for example, in a prepaid data breach, and something anonymous is some anomaly is happening around that, and we want to find out that what is happening, because the real-time feed is coming to us. We are based on the users' different profiles, different contexts that we have. We can solve those problems and applying the awareness and send the communication to different channels accordingly. So these are different data sets of the users that we have already mentioned, that we have the locations, affluence, age, gender, interest and affinities, multiple derived heuristic profiling. We have various AI models to basically get this behavioral things around. And then we have network signal strength, their device health metrics. So what are the benefits of using telco data? Because I know everyone is using mobile, or everyone they don't go out of home without having mobile with them. Even they're sitting at home, they have a mobile with them. So we have the whole, basically it's becoming a signal of us as well, right? That how we are behaving, what we are thinking, where we are, all of these things are, so basically we are able to capture the whole humans into the data basically, right? And we have all this information with us in an anonymized way only, right? And we have a customer base not catered to only one of the regions. We have a customer base across all of India with different kind of people, coming from different socio-economic zones. So we have that kind of information with us. And obviously all data resides in India and is highly regulated. We are not dependent on some other data sources, some other countries to get this data from, some other organizations to get this data from. So because everything is regulated by Government of India, so it's all over there. Right? And we also, as I already shown in the slide, that we have those capabilities that can process large amount of data in a very fast time. We have created that infrastructure over the time, right? And that's why we are able to solve the problems in a record time. So that's the advantage of using a telecom data basically. Yeah, that's from my side. Thank you. Thank you.
Thank you so much, Mr. Pulin, for giving the insights how the large telecom data sets that are being generating can be leveraged and to put data insights into a digital twin Sangam initiative. Now, moving ahead in the group 2, we'll be moving ahead with the speaker from Oracle, Mr. Prashad Kulkarni, who is cloud security expert from Oracle. He has more than 17 years of experience and he works around India with the BFSI, telecom and pharma sector. I will hand over to him.
Good afternoon, everyone. Thank you so much to all the dignitaries and the DOT team for giving an opportunity. So I'm Prasad, I'm from Oracle. So from morning, right, like say we have heard about data, right? So why are we speaking today? Because last 10 years, we have been generating tons and huge amount of data, right? So today as an individual, right, as an individual human identity, I have been connected and leveraging various different gadgets, and every gadget what we are using today is generating data. And this gadget what we are referring to, probably it can be a wearable device or it can be a phone, mobile phone, where we can get a precise location as well, right? So now, as we see, right, that's all internet inside. So if you look at the statistics, it's growing, right? Like it's growing like anything. And every individual is so much surrounded by the gadgets. And each of these gadgets is emitting tons of data. And now when we segregate this, when we have an anatomy of these gadgets, right? Say for example, when I'm using a particular mobile service, my location, my access patterns, my behavior, be it in physical world as well as in the digital world, that data is collated and it's with the service provider, right? So that's something which is the data what we are referring to. At the same time, as we are referring, right, like say how many, I believe like many of us here, like probably we are already using connected cars, right? That's what we call it as internet inside as well, right? So a few of the examples in the previous talks by a few of good friends here, they referred about traffic management. They referred about sharing and collaborating data, right? So here, few of the examples would be when internet connected car and at the same time a person with an wearable devices and traveling to a particular location, right? So here, how many times a roadside assistance call or invocation would be done by that user, right? Or therefore by that human identity. Or how many times he or she, the identities, the car and the, the digital gadgets are stuck in traffic. So these data, right, that can be shared and that can be collaborated. So now with all this collaboration, right, what this protected and like say enhanced protection technologies, where it really helps, right? So overall, when we refer to this data and when we refer to this privacy, end of the day, as we say, like say identifying a particular individual, and it should not damage the reputation or also does not harm the health or the life of an individual, right? To make sure it's not damaging the individual's identity or the reputation, be it on digital or on the physical world. That's the privacy what we are referring to, right? So now that's the reason we have like say multiple data privacy laws which has been like incorporated by multiple countries, and even in India we have DPDP, right, which helps in making sure and protecting the individual's privacy, right? And every processing should happen with consent, right? So as we refer, the data is being generated, data is being emitted, right? The useful, how do we really harness and collaborate with multi-parties, right? Like be it like telcos or be it the automakers, and we have heard about few other examples like how the various different services, the digital services leveraged by the individual, right? While collaborating, it should make sure the sensitivity of the data is not really exposed. And with this exposure, it should not harm the identity. So that's the overall goal, or that's the like end of the day, it should not harm the human individual. That's the overall goal. At the same time, it should not like say deny the basic essential services. So that's where it really refers to the data privacy laws, right? So how do we really collaborate now? Every service provider here, they are collating large amounts of data. Due to confidentiality, due to privacy concerns, we cannot really collaborate with each other to open up a new economy, right? So those are the blockers, right? Those are data collaboration blockers. Probably we may have like blockers, what we can see is like data residency. If it's a highly confidential data, I don't want to move that data outside the corporate boundaries of my organization. Even though I'm very much ready to collaborate, but I don't want to move it to that, right? So that's the residency. And at the same time, if at all it is being shared, is the integrity, is it being altered? Is it being exposed, right? And at the same time, what about the availability, right? Like say, once the data is made available, right? So post getting the results, is the data still available, right? As and when required. So these are data collaboration challenges, how we can really unblock these data collaboration challenges and open up for a new economy by collaborating and sharing data and making sure that the underlying value of the data is not really exposed. And in turn, it is not harming or it is not really damaging the reputation of an individual, be it in the digital world or at the same time physical world, right? So that's where this privacy enhanced technologies comes into action. So as we speak right today, where this privacy enhanced technologies weren't existed earlier? Or is it just that when we started emitting tons of data by having these connected gadgets, these are coming into picture? No. Privacy enhanced technologies have existed in the environment, have existed in the market for a long time. But at the same time, the new paradigm as of today, the kind of a data we are generating, we require the new systems to handle the vast amount of data, the scalability, at the same time making sure the confidentiality of the data is maintained. So here in Oracle, right, we have multiple capabilities and offerings which helps various different organizations, be it from the startup and be it for the large organizations, how you can collaborate and harness the power of data by exchanging the data insights, right, with the other parties, right? So one of the example, right, like say, so overall this is called as privacy computing, end of the day. So privacy computing, making sure we are leveraging from infra layer to the processor and the app layer where we are providing enough robust or enhanced privacy mechanisms where we are not targeting an individual by personally identifying so-and-so activities either in financial sector or whether in the health or insurance sector, or the kind of driving behaviors which is really like say being assessed, and that data is being shared with the insurance providers to making sure what should be my next premiums, right? So that's the privacy computing. So within Oracle, right, like say we have a offering, right, what we call as a trusted execution environment. So here, in this privacy computing, we can categorize into two. One is hard privacy, other one is soft privacy. Hard privacy technologies wherein the data is not leaving your premises. It's there within the boundaries of your environment. Yet, you can still collaborate and have a multi-party computation and enable for data exchange. Second, soft privacy technologies, where you can leverage at the various different levels of the stack, be it at the infra layer, be it at the processor layer, right, be it at the application layer or at a database layer, and make sure it's all about consent and audit, and that's the privacy is maintained. So with this trusted execution environment, right, one of the paradigm is confidential computing. So confidential computing is predominantly wherein a data, as we always speak, data at rest, it's encrypted. Data in transit, it's always encrypted. How about data in memory, right? So data in memory is also encrypted. So that's confidential computing. So it's one of the paradigm or one of the method for achieving the use case of multi-party data computation, right? Another scenario, as I talked about, hard privacy requirements, right? So that's where we would like to have a what do you call sovereign region, right? So this is one of the offering from a technology company from Oracle, where you can leverage a dedicated region. You can set up your complete dedicated stack with all the capabilities of the cloud computing. Because from morning we have heard from our experts as well, the computing cost, CPU, memory, storage, network is very costly, right? So at the same time, having all the advantages of the cloud and building that stack within your premises and getting all the capabilities and services, right? So that's the sovereign cloud, right? And wherein the data always resides within your corporate boundaries, right? At the same time, if you want to have a miniature of a minimized version of it, not having the complete stack, just focused on certain components of it, we do also offer compute at your data center and also database at your data center, right? So that's completely a database cloud at your data center and compute cloud at your data center. Right? Those two components, and you can build your applications and leverage confidential computing on top of it, and also leverage trusted execution environments on top of it to achieve the use cases like secure multi-party computation, right? And a couple of questions came in from the audiences as well. How do we really build the use cases when the demands are for the actual data, right? So that's one of the technology what you can use is with the data science platforms, right? That is synthetic data generation, right? So there are, like say, models which are available. We need to train it with the help of like having a sampling algorithm and pumping the data set, which is not having the it is just holding the data value but not exactly exposing the data to the platform, right? So now with the help of that, we can generate vast amount of synthetic data which will help you in training your models, right? So these are the another alternate or a parallel models which are running that will help you generate a set of data. At the same time, so once we have this data, right, so we can, we need to leverage how we can maintain the privacy, right? Like say, as I said, does this privacy enhancing technologies didn't exist? On day-to-day basis we use, right? For example, we use our credit cards in financial, right? Many of the sense. So all transactions, whatever we do, right? The transaction history really does not contain your human identity details, your bank details, no. It's only the tokenized data. Even the tokenized data is somehow corrupted, or if it is exposed, it really doesn't expose the underlying sensitive data where a person who want to reverse engineer it to understand who is that the human being behind it, like who is the actual person who owns this data, right? So you cannot really do a reverse engineering. So that's the tokenization, right? So tokenization is something which you can leverage it for a small amount of data, right? Where you can bifurcate it, like saying personally identifiable information, be it even today, right? Our extended attributes like my geolocation, right? Like say my phone can locate my geolocation. I am in IIT, IIIT B, right? So that's an extended attribute is associated with me that acts as one of the personally identifiable information of Prasad, right? So now these kind of data sets you can identify, right? And you can tokenize them. So once you tokenize them, you are not really sharing the actual data. It is only the tokenized part of it, right? So at the same time, in conjunction with that, you can also leverage the masking techniques. So these are already existing within the ecosystem, right? The masking techniques would help you in mask anonymizing the various set of data which you are working upon, right? Then comes the homomorphic encryption, right? So homomorphic encryption is basically, it helps in working on an encrypted data itself. So, and even it's one of the paradigm for secure multi-party computation, right? So multiple authorities are working on and exchanging their data, and they are always sharing the encrypted data which is there in the processor. And that's where, right, like say even at the processing, the data is always encrypted, right? And when the data goes back as a result to your systems, it is again encrypted as well. So here it's making sure throughout the journey, from where it is emitting, from where it is generating, where it is being processed, and what is the resultant of it. In this whole journey, it's encrypted, right? And also, we can also leverage the differential, what we call private federated learning, right? So this basically wherein again, right, it's again one of the paradigm for multi-party computation itself. So predominantly what happens when we want to enable next generation AI-based solution and act upon the data, right? So we can have a single federated system wherein the data is pumped by multi-party, right? And the data is pumped over one single server, right? And that helps in making sure the privacy or the sensitive data or underlying data is not really exposed, but just the data insight is leveraged for computing, right? So that's one of the methodology as well. So here within digital twin, the importance of data privacy, and it plays a major role in opening up a new economy wherein we can leverage these technologies which are available as a part of a platform and which are offered from Oracle that can be leveraged by the small organizations as well as the large organizations, wherein you can also leverage a sovereign cloud and also the confidential computing or the T execution environments to meet your use cases and goals. Yeah. Thank you so much.
Thank you so much. Thank you so much, sir, for throwing light on how privacy-enhancing technologies can be used for multi-party secure computing. So with this, we'll open the floor for the group 2 for the question and answers from the audience. I would request the volunteers to please take the mics. If we are having any questions, we can, yeah. So we are having a question from the front row. Please come up with the mic.
Good afternoon, I'm Prakash from CDOR. My question is to the operator here. So most of the research and studies, we look at, we need data, but for all our papers or it's mostly comes from the Western world. So how can Indian researchers get access to some of the operator data in an open manner, maybe anonymized and tokenized or whatever, but some amount of data sharing from the operators to the research community, what can be done? Some, I would like to hear some thoughts.
yeah, please, you are having an orange button at the blue. Just please, yeah, at the bottom.
It's working.
I hope I'm audible.
Yeah.
So the data is private right now, right? In aggregated format, how that can be shared, it's not right now any policy with us that how we can share this data. But we can help in providing the solutions for that, so that since we have the data, and if we can have some other aggregated data with us, if we can have joint solutioning kind of thing, so we can definitely help in that case. But to share the data in any format right now, there isn't anything right now available for us.
Okay, we can have next question. Yeah, at the last row, please.
So my name is Ashutosh, and this is questions to Pulit from Airtel and to Department of Technology. Is there any policy there which is like citizens' right to personal data privacy? Because what we are thinking now is now sharing the data with, let's say, for the credit scoring. So generally, at the end of the day, we get a lot of spam calls and a lot of advertisement calls. Suppose even after several DNDs, we still get that, and it's an open problem for every customer that facing. But this is from the enterprise point of view, this is a channel for profit making. But there is something missing here is that my personal privacy, that where I can limit myself. Is there any portal where I can see that which companies are accessing my data, and I can put a stop there? Just like our Aadhaar, whenever I'm sharing my Aadhaar details, I also have a platform that where I can go and check that with whom I'm sharing the data. So something is there, or is there any plan to bring that? Because otherwise it becomes a complete mess.
So we can have a response from your side.
Says that key from where, for which sites your data is being shared, because from the data from the telecom provider side, no data is shared, no data is compromised. But for the spam protection, there's a joint activity going on, so that how we can reduce this spam activity, this spam calls, and the spam messages that user gets. So there's a joint activity going on around that to find out the solution for that, so that how can we reduce and how can we minimize this spam calls basically.
So with the response from Department of Telecom regarding this, so Department of Telecom last year has launched a Sanchar Sati portal, that is www.sancharsati.gov.in, which is having many citizen-centric services for empowering the citizens and securing them in the digital space. Also, the TRI is having their DND space wherein the spam calls are being handled. And apart from that, the query regarding the privacy of the data or how the data is being processed by the companies. So we have got the DPDP enacted, and as it will be evolved, I think frameworks will be there. Yeah, so there's one more thing that I want to highlight. So just 3 days back on 4th of March, we have got one more facility, that is Chakshu, that is for the citizens to report the suspected fraud communication that we are receiving in the form of calls, SMS, and that are regarding to the KYC expiry, KYC update, or regarding the impersonation from the government officials, from the departments. You can report, citizens can report, and they are analyzing and be helping to prevent the misuse of telecom resources in that.
Yeah, just to add a quick point, like sir has said the credit scoring, right? So there what happens is that if you put the DND activated, so what happens that the enterprise call cannot come to my personal devices. But what now the financial service providers are doing is they will call from the private numbers, so that it cannot be monitored. Every time it's a random call and you have to pick it. Or maybe sometimes if you try to block every call, probably you'll miss some important calls. So that's why
So there's one more input on that. So basically there is a dedicated 140 series in the telecom world with which such kind of commercial calls can come. But yes, there are instances in which 10-digit numbers are being used. So yes, government is working on that, and with the portals or with the initiatives that I have told, we'll be curbing them.
So any other question from the audience? Okay, with this, if we are having no more questions, we can have a group photographs with our speakers, and with this, we'll be summarizing the session. Please come up for a group photograph. With this, ladies and gentlemen, we'll be breaking for the lunch. Lunch is being served outside this auditorium in the Amantran hall. You can please proceed for the lunch. We'll be initiating the next session after 30 minutes. Please assemble back after 30 minutes. Thank you so much.
So people who are just standing, I would request them to please be seated so that we can just start in another 60 seconds. Good afternoon, all of you. I would first like to request everybody, because we've had lunch, so to give a huge round of applause for the previous speakers. So after having an interesting conversation in the session 1 regarding digital twins, generative AI, telecom data visual platforms from Meta, Samsung, Fabric Space, Autoverse, and then we had Nokia, Ashed, Airtel, and Oracle. So it was a quite enlightening session. So we've got the brief understanding of what Sangam is and what we are trying to achieve. And in line with this, in alignment, what happened at Sangam Delhi and session 1 and 2 of Sangam Bangalore, we'll be proceeding for a session 3. So for that, I would like to call upon Mr. Rajiv Saraf, founder and CEO Lepton, on the stage. Please give a huge round of applause. Next, I would like to call Mr. Yuvraj Tomar, founder Cloudworks. Next, I would like to call Mr. Raghu Krishnapuram, IUDX Program Unit. Raghu sir. And lastly, to make this session more diverse, I would like to call Mr. S.R. Nair, Senior Solution Architect, NVIDIA. So we start this session with Mr. Rajiv Saraf, founder and CEO Lepton. I'd like to give a brief introduction about him. Dr. Rajiv Saraf is a visionary business leader and a renowned entrepreneur, currently serving as the founder and CEO of Lepton Software, a leading geospatial intelligence solution provider. Under his leadership, Lepton Software, a pioneer in bridging digital maps to India, has grown rapidly and has now established itself as a trusted partner for several Fortune 500 companies. an IIT Kharagpur and Vanderbilt University alumni. He's also an advisor and angel investor for many upcoming startups. So for startups and businesses, he's an angel investor. This is something which I'm highlighting once again. Currently, he also serves as the Board of Governor member at NIT Delhi. So I would like to call Dr. Rajiv Saraf to talk about geospatial policies and geospatial intelligence and share his thoughts. I would request you to please start clapping. It is important to maintain the momentum in the energy in the crowd as well as for the speakers, because that is the transmission that happens. Thank you. Sir, I'll close this.
Hello. Hello. कैसे चलेगा?
Hello. Hello. Am I audible? Thank you. Normally the sessions after the lunch, immediately after the lunch, are probably not the most, the most interesting ones, and people tend to sleep or sort of doze off. I'll try my best to make it as interesting as possible. So let me start with a question. Would anybody here believe if I said that we have been using digital twins for last 30 years? We are not only using, we are not only consuming, we are also using it in our daily life every day in and out. I doubt anybody would say yes to it. Just like if I said that I have worked on AI 30 years back, and of course for that I have a proof to show. Is this a change? Okay, Nikhil? Yeah. So, no, go back. Please go back. So, I worked on AI 30 years back. Of course, that time it was called neural networks. And my thesis, my PhD thesis was how to design and optimize traffic control systems using neural networks, right? This topic actually involved, optimizing your, traffic signals that we use every day, and we are trying to use neural network, which was of course a PhD thesis. We had to model the intersections. We created, we also needed a lot of data to build these models. Of course, there were a lot of challenges that time, right? The biggest challenge was that the compute was not available for training with small data itself took a huge amount of time. And then the other biggest problem was, even if you wanted to deploy an adaptive traffic control systems, where do you really get the traffic data in the real time, right? The only methodology that existed that time was to deploy these closed loops within the roads, and you could only do it for a certain number of roads. You didn't have the traffic data that you could get for all the roads. So it was a problem, it was a solvable problem. The AI was just starting to happen, but of course the other pieces were not in the place. So similarly, so what has happened, it's not that, the AI, if you look at the AI journey, it's not that, the AI just stood there and suddenly the things have happened. In our background, again, similar to the digital twins, AI, we are also consuming AI in our lives every day, and we've been doing it and we as an organization has also been building on it for last, 30 years. It's not that, AI is something which has happened today. So over the period, if you look at what had happened, it happened in image classification, image identification we use in our GIS to build data out of that. NLP, natural language processing, voice to text, all kind of things happen, and these are the features that you continue to use in your application without even realizing that the AI was happening. It was the ChatGPT which actually brought the word AI to the masses, and that really was sort of for us the coming of the age of the AI. Certainly the AI, everybody is talking about it, and that is what we talk about when we say the coming of age of AI is with the ChatGPT and the Mid-Journey and the DALL-E. These are the products which are now brought into the mainstream, and we are talking about it much, much more. So similarly, I'm going to talk about how there's been a geospatial, the journey of digital twins as well. But before even getting into this, I want to just now take another example from our life, which we use, and of course, specifically since this event is sponsored by DOT, I'm going to take an example from the telecom world. And the example I'm going to take is very close to all our hearts, hands, pockets, whatever you want to say. All of us use mobile phones, right? Everybody uses a mobile phone. And all of us have seen how does the mobile phones work? They connect to the tower, the nearest tower that you are there, and you've seen those ugly structures coming on rooftops, on the ground, everywhere. But you must be thinking, how do they actually come up? Where do they come up? And where they are, why they are there, why not somewhere else? So they don't just come up randomly. They come up because they are operators, they have a simulation tool at the back end. If you think of it, what is a simulation tool or a planning tool? It's nothing but a digital twin. It feeds into it the digital map data, and within the map data, then they put a tower, then they have algorithms which models the propagation, and then tries to calculate whether your house is going to get a signal or not, whether the quality of service is going to be not, and based on that do a planning. So what the telcos have been doing for the last 25 years in their planning of wireless network is nothing but a digital twin. If you think of it, the only thing if you think of it, what has evolved? If I look back 20 years back, we used to plan on the maps which were 20-meter resolution, right? The models were more probabilistic. They were not so detailed. The computation was, of course, we didn't have that kind of computation available. Move from there to the 5G, from 2G to 5G, and now the customers that are using maps are 1-meter resolution. The models that are using is more, AI-based models, and they can do very accurate predictions. Now, as a Lepton software, if I look at it, more than 90% of the networks, the wireless networks in India, have been planned and rolled out on the mapping solution that we provided. And we have seen the journey to move from 2D to 2.5D to 3D. If you look at Geo, all the planning, they actually licensed data for 800 top cities in 3D to do all the planning. So this just gives you a glimpse of the data that has been used in the 5G planning by some of the operators. What you see are the trees, the vegetation, the systems can model vegetation, flyovers, buildings, rooftops. And this is the data that telcos are already using in their planning tool. The planning tool is nothing but a real world example of a digital twin. Right, so just let me ask you, how many people, when you came here, you actually used Google Maps to come here? Anybody here? And how many of you used Google Maps in the last 2 weeks? Almost everybody out here. I use the Uber from the airport to come here. Now, what I'm going to do is, I'm going to talk about 2 examples and I'm going to show how the whole digital twin world has evolved. And I'm going to take it, one example is from the consumer world, which is of course Google Maps. The second example, again, I'm going to take it from the telecom world, just because, again, it's an event which is organized by DOT. We have examples from other world as well, but we'll talk about the telco world. So I talked about the towers, I talked about the phone, I talked about towers. Now what happens once you connect to towers? Where does your traffic go? So the traffic, if there's an underlying fiber which you don't see, which goes across the city, which sometimes also connects to your home and gives you broadband, which carries all the traffic. right? If I talk of Vodafone, they had like more than 800,000 kilometers of fiber across the country. We probably don't even know that, right? If we talk of BSNL, they probably have 1 million kilometers of fiber across the country. And that's how the whole system keeps running, right? Your phone, your BTS, your fiber, all the things are working in sync together every day, 24/7, 365 days, and they're working together. How does that happen? So we have actually a product, what we call is network access. It actually allows the operators or telcos to basically plan their fiber network, to completely inventorize their fiber network. This is basically nothing but a digital twin of your fiber network, and then do analytics and do all kind of predictive analytics, and we'll talk about that, right? So the product, what the network access product that we have, it's deployed in more than 35 countries. We have more than 150 million pair fiber running on top of our solution, and it's serving 1 billion customers across the globe. Now, so I'm going to talk, as I said, I'm going to talk a tale of two, digital twins, one from the consumer world and one from the enterprise world. Now, I think the first true, and so I'm going to give it the first true digital twin that was there was the Google Earth, right? That was almost came out 20 years back, right? That was literally by saying ki jo dunya puri muthi mein, that was really the first time that you had the whole dunya in your muthi. You could go to your desktop, you could go and search your house, you could see your neighbor's house, you could see your office, but you could visualize, right? They had a limitation, you could just visualize. So to me, that was the first version of, digital twin. And in this screen, I'm sort of defining digital twins by 5 parameters, right? Visualize, simulate, experiment, automate, and predict. So these are 5 parameters. I'm going to show how they've evolved over the time and what are the components that were getting used in the different versions of digital twin. And similarly, what was happening when the Google Earth was being launched, and that was to me the first version of digital twin, version 1. Or to me actually that was 0.0. It was only visualization. In the telco world, what were they doing? They were taking their paper drawings and converting into the AutoCAD drawings, right? That's all they were doing that time, right? That was the thing, that was the technology we had, from paper to AutoCAD, and that was what was called digitalization. You couldn't really do much with that, except that it was easy to just search. If you wanted to search something, you would just get that, you could look at the drawing, and again, you couldn't really do much with that, right? Then, I think the next version happened was what we call the digital twin 1.0. What happened in 1.0 was, so the Google went beyond just visualization. So Google Maps got launched. You could go to your website and you could do a routing. So one function got built, right? There was a functionality that came and it said, hey, look, it's just visualization. Now you can actually simulate. I can simulate sitting at home. I could simulate if I had to go from airport to a triple IT, how much time it's going to take, what is the route I should be taking, right? That's what it could. There was no traffic that time, right? The first version came. To me, that was the first thing, real-time word application on Google Maps happened. To me, that was version 1.0 of digital twin. Sorry, the earlier one was 0.0. This I call the version 1.10 of digital twin. Similarly, in the network, we launched our product Network Access. What did it allow? It allowed the operators, we used Google Maps as the platform, and it allowed the operators to completely map their inventory. So they could now go and completely map the inventory. They could say, okay, where is my duct, where is my fiber pair, where my ONTs, OLUs, equipments, and how they are connected. All this documentation could happen. And sort of that formed the basis. And this was still, they were building and they could do things. If they wanted to do basic analytics, they wanted to find out how many kilometers fiber I have available, how many kilometers of fiber I have across the country. Those kind of queries they could do very easily, right? So that was the sort of first level of, I think that was the digital twin version 1.0, which basically now allowed you to simulate your network. You can now say, okay, this is where I have my fiber. This is where I need to put more fiber. You could plan. So that was to you the version 1.0. Now, version 2.0, let's talk about version. In the version 2.0, what happened in the Google Map, it came on your mobile and it started giving you real-time traffic. Now, how did that real-time traffic happen? Just think of it. It happened because all our phones or devices became IoT devices. Billions and billions of devices were sending data to Google. of where they were, how they were traveling. Based on the data, Google converted the data into actionable and created a traffic map. So now comes in huge computing. If you think of it, the IoT sensors have now, suddenly there was no IoT sensor in version 0.0, 1.0, and 2.0. We have IoT sensors coming in. So to me, that is a digital twin 2.0. The IoT sensors have suddenly come in without me realizing. We use it every day. Nobody's thinking about it. That was digital point. How did the real-time traffic come in? So that is, to me, digital twin 2.0. And similarly, if you look at our network access product, what happened? What we did was we integrated our network access product to operators, what we call it OSS. What is OSS? Operation Support System. It is nothing but, they have multitude of IoTs or BTSs which are spread across the country, which are sending, and anything happens, they get the alarms on the OSS system. We took those alarms and we were able to show them into network access to tell you where the complaints are. Then use that complaints and integrate it with the SMS and WhatsApp and send out information to the field force, right? So to me, that was the third stage of the whole digital twin evolution or the maturity. Digital twin 2.0, the stage was third. Go back slightly. And now in this particular case, if you look at what Google did, was you could also now predict, right? Earlier, based on the traffic time, they give you a slightly accurate prediction of how much time it will take. When I left the airport, it gave me a time that at this time you'll reach triple IT, and I just happened to be within a minute of that, right? So that was the kind of accuracy that that was happening with the IoT devices and all the information coming in the prediction engine. Now we don't even know what is firing the prediction engine behind it, right? What technology is really firing it. So there are a lot of other things that we'll talk about, right? So now you have IoT devices, you have cloud compute, which is doing huge amount of computing, able to do it in the real time, right? Huge amount of data coming in, just computing in the real time. And that cannot happen if you don't have a huge amount of cloud compute. You have smartphones and you have very cheap storage because this amount of data requires cheap storage. And so now comes the phase 3.0 or what I call digital twin 3.0. And this is where again the AI also enters. But look at what has happened first let's talk about what has happened in the Google Maps world. Now what is happening is, when you're traveling on the road, sometimes you might have seen those messages which says, there's an accident ahead of you, right? Or there's a car breakdown ahead of you. Just to sort of interestingly for India, we as a Lepton provide this data to Google. And of course, we provide a lot of other data to Google. Both this Google Maps and network access are very close to our hearts. So this to me is the sort of a next generation of digital twin, where you have some real-time data coming in, which allows you to take actions in the real time. That's what the whole focus of the Sangam was. How do we plan in the real time? So in the Google Maps, what is happening is that the feedback comes in saying, hey, there's an accident ahead of you. Google gives you a reroute. Right? That's what is happening. So that is your digital twin, 3.0, the version 3.0. What is happening in the enterprise world? What did we do in the enterprise world? So when these tickets are coming in, we would send the tickets to the field people. Now in the real time, let's say there's a ticket which has a high escalation. Let's say the connection to the Prime Minister's house has got broken and they need to be fixed. Everything has to change. And that has to get the top priority. So in the real time, with the automation, everything that gets a priority, the team goes there and fixes it, right? So I think that's what the next level of digital twin, where in the real time, the automation started happening. And you had real-time information coming in, the actions were being taken, the automation was happening, and without we realizing, a lot of AI was slowly working in the background. So that was your version 3.0 AI. You have GPU compute, your powerful smartphones, everything combining together is building your, what we call as, the digital twin version 3.0. And the next version, what I call, is the version 4.0. Now, I would say, things like, you can do voice-based, instead of typing where you want to go, you say, okay, I want to go to triple IT, you can speak, it converts your voice into text and uses that, so that's the part where AI is getting used. You have, augmented reality, you do a route, And I don't know whether it's launched in India or in a certain country, you can walk along, it can show you a video, it can tell you on the thing whether you should go left or right? So augmented reality has come into there. The virtual reality, the augmented reality, these features has come into the Google Earth world, right? Google Maps world. So to me, that is the version 4 of the digital twin world. I mean, the digital twins that we're talking about, that's the version 4. And parallelly, of course, on the enterprise side, in our solution also, now of course, the version is still in the lab, that's why I don't have a real images. You can actually, when the field force goes in the field, he can actually look at his phone, and with the augmented reality, I can show him on the map, on the phone, the way you can see it here, where the fiber is going, where the tower is, where the thing is. So it just becomes this aided tool to him. It's like an additional person with him, or additional eyes to him, where he can do things. So to me, that is where I think is the version 4 of the digital twin, which we are talking about in this world, where all the technologies of AI, VR, XR, everything is coming together. And with a huge, so I'll just take 3-4 minutes. So all this technology coming together, and from learning from whatever experiences we had, finally we decided, we have launched today, and I'm glad to say that we are launching our platform. The name is Rio. We are launching it today, which is a 3D digital twin platform, which also provides you all this functionality to visualize, simulate, experiment, predict, and automate. We have some functionality there. All of you must be wondering, what is Rio? Is it some acronym for some complex acronym like RESTful input-output or real-time intelligence operations? No. Actually, it's the name of my dog. So I decided to name it after my dog, and the reason being is cute, and I think our Rio platform is also cute. It's lightweight. He only weighs 5 kg. Our platform, the Rio platform, is also lightweight. It's very easy to manage. Doesn't a small dog, you can manage easily. Our Rio platform is also very easy to manage. And best of it, once you start engaging with it, you start loving it. And that's what I think that Rio will do to you. So we built this Rio platform, we are launching it today as an official thing. And I'm also glad to say that in the beta, while we're in the beta phase, we have actually deployed it for, again, one of the telco customers. This platform has already been deployed for Saudi Telecom, and they are using it to plan and visualize their wireless networks again. So, and it all brings in the whole 3D maps, and I'll just quickly show you 1-minute video around the. Sorry, the audio on this one is not working. But you can see this is Gurgaon for you. Showing you the 3D model of Gurgaon. And you can go to floors, you can see the details. This is your cyber hub, or cyber city. You can see other details on the right-hand side. You can see the vegetation. And you can do a rendering at a global scale. You can bring the whole India data. We have integrated the 800 cities, 3D maps with us. You can model your towers. You can immediately do a prediction, and on the right you can see how many buildings are covered. You can change some parameters, you can change how many buildings will not get covered. And this is happening on the fly. This is not something that you make some changes and you have to wait for half an hour and you come back and do that. If there are certain kind of telco services that require line of sight, it can do those kind of calculations for you. So there's a lot of engineering built into it. There's a lot of the 3D data built into it. The whole analytics is built into it. All of this is coming together as a part of our Rio platform, which we also already deployed as a solution with the Saudi Telecom called Smart Signal. Next. Now, while we talk about digital twins, and we have this experience of now 20 years, or more than probably 20 years, 30 years working on it, I just wanted to highlight certain rabbit holes. So, we tend to think of, and we think of digital twin, first thing we think that digital twin can solve all our problems, right? And same thing, digital twin does not mean that I need to have a map of 1 centimeter accuracy. It's not about that. Our thought process will be driven by outcomes. The first thing is, what is that I want is an outcome. If I'm doing a city level planning, like if I can talk of telcos, if I give them a 1 centimeter accuracy map, probably the computational requirement, something will go up by 100 times to consume that map, and I don't see there could be any they were not going to get any ROI for doing that, right? So we have to look at what is the problem that we want to solve, and based on that, we should think of the inputs that has to come into that. Whether, for most of the telcos, we think a 2 meter, 3 meter accuracy maps are good enough. At a certain frequency, if you go with a very high frequency, maybe you still require better maps. But most of the applications will work at that. So we should not get carried away by thinking that we require, everywhere we need to have. Yes, if you're going to design, if you're looking at one building and you're going to do a BIM, yes, maybe within that building you require very detailed data, but not if you're doing urban level planning or urban city planning. That's the first thing we should be careful about. We should not think of data and then think of outcomes. It should be the other way around. We should think of outcomes, what is that we want to achieve, and then we should go and see what do we really want with that, what is the accuracy we want. Same thing is, the second is UI UX focused. Every digital twin as an output need not have a map as an interface, right? People want to see outputs. People don't want to see maps. So something we should always think about is that the UI and interface that we provide is something that people are very familiar and people can very easily use. So that's another thing we should think about, and not trying to create a very beautiful interfaces which nobody probably can then use. And we also have to be vertical. We have to be very verticalized in the sense there will be different solutions for different industry. There will not be one solution that can fit into every industry. Every industry will have its own set of analytics and things, and that's what we need to take care of. And the last, so when I said the coming, so I think what has happened now, I talked about the coming of age of AI with the chat GPT and the mid-journey. I think this is the coming of age of digital twins. So how many of you have you heard this word WYSIWYG? WYSIWYG? I think very few people. So anybody who's not probably a computer nerd, maybe. So WYSIWYG was the word, actually it means what you see is what you get. This word actually came almost, 35, 40 years back, when, I don't know if the old professors, somebody might remember that earlier when you had to write a document, you would actually write the code within the document, and then you would go and see, you write italic / and the word will become italic. And then the word processor came, where whenever you typed something, it actually looked like what you were going to get when you took a printout. And when Windows got launched, and when you created apps, and you could have Visual C, and you created forms, so you could see what it will look like without actually going and trying to do coding first and then trying to figure out how it's going to look like. So the WYSIWYG was what it was. What you see is what you get. I think when I talk about the coming of ages of digital twin, this is the age now, where the digital twins have become so close, they will try to model your real world as close as possible. And that is going to happen because the data, the underlying data is there. You have huge amount of IoTs which are also sending you data in the real time. You have huge amount of computing available, and the AI models which are all coming together with the AR and VR technology to make it happen. Thank you.
Thank you so much, sir, for the insightful session. Is actually what we thought, and what you delivered is exactly what you see is what you get. And some important summary that I would like to bring in is, sir has highlighted about the use cases, about network planning, about 5G and FTTH planning through the high precision digital 3D maps. So this is a very important use case as far as telecom sector is considered. And moving ahead with our another distinguished speaker, who is Mr. Yuvraj Tomar. He's a founder at Cloudworks, and he's a visionary leader in digital twin technology and enterprise metaverse. Yuvraj stands at the forefront of pioneering solutions for the future. With the rich background in IoT, 3D and AI, Yuvraj has led numerous initiatives for his company Cloudworks that showcase the potential of digital twins in enhancing operational efficiency, sustainability and strategic planning. Joining the Sangam initiative, Yuvraj is excited, as we could see, is excited to contribute expertise and insights towards the shaping resilient and efficient and interconnected infrastructure for tomorrow. And also I would like to mention that he was also, if I'm not wrong, part of Shark Tank Season 2, and he raised funds as well at the Shark Tank as well. So I would like to ask you and request you rather to share that experience as well. So a huge round of applause. Keep the energy, keep the momentum going. Thank you. Yuvraj, over to you.
There's a video link in the end that has to be clicked. Check, check. Testing, testing. Hello. Am I audible in the back? Good afternoon, everyone. Am I audible to all? Great. My name is Yuvraj Tomar. I'm the founder of Cloudworks, and I'm here to present how we can integrate road traffic data to create sustainable digital twin technologies for the future and enhance urban mobility, with a specific focus on Cloudworks Studio, which is our no-code platform for creating digital twins. Now, when we combine road transport data and digital twins together, we get something that is out of the blue, in one sense, a solution that can model, simulate, monitor, control, and revolutionize how we approach urban mobility. The digital twin ecosystem and the whole value that digital twin create, I believe is the same nuance that has been mentioned by all the speakers in the session throughout. So I won't reiterate most of those aspects. I'll jump straight to the use cases. What will we get once we start combining road transport data and digital twins? One such use case, or one of the most foremost use case, is basically traffic flow optimization. Getting real-time data on how different parts of the cities are moving, different vehicles are moving within the city, and simulating them to create the most optimized traffic flow, especially during peak hours. This would reduce the time to, let's say, reach a particular destination. This would reduce the congestion by up to a factor of 20%. All of this reduction eventually is the amount of productivity that is given back to the economy in the form of an increment in productive workforce or in certain other aspects. Other use cases would be around infrastructure maintenance planning. We all would have noticed this problem. Whenever a new bridge is being constructed, whenever a new road is being constructed, there are significant delays, there are significant mismanagement in traffic. And oftentimes we choose to avoid those roads wherever these things are happening. Now, if a digital twin is in place, we have the right kind of data to stimulate aspects. We have the right kind of data to understand what would happen if we, let's say, block these two roads. How much of an impact in traffic delays are we expecting? Planning this, simulating this, having this visualized in a city map, and then having this visualization shared with all the stakeholders, right from the traffic person who's working on the road to the directors who are managing this. This would help resolve the whole notion of how do we plan our structures better, how do we plan these bridges better in that regards. And likewise, how we can manage the traffic in real time. I believe most of us would have heard that news, especially the people who are coming from Delhi, that whenever there's a traffic jam or whenever there's a block sometime in the road, the police and the government, they actually deploy a drone to understand or to visualize the points where the traffic is stuck. And then they plan the different ways or the different exits based on how they're receiving the data from the drone. Now, once we have a digital twin in place, we don't need to do all of that. We're already getting all of that real-time data from the telecom providers, from satellite data imagery, from other means of visualization. And we're able to play around with that data. We're able to simulate that data. And we're able to create some sort of visualization how we can manage the flow of traffic so that our citizens are reaching the places and the destination in the most optimal time. Another advantage and another nuanced use case that a lot of people don't really think about this is understanding noise pollution with the help of road transport data. Now, a simple example and a very simple, let's say, use case in this case would be smoother surfaces versus corrugated surfaces have a different scenario when they interact with noise. A smoother surface would bounce the noise back into the, let's say, reflecting all the environment, whereas a corrugated surface would dampen it. So if we take this notion to our bridges, we take this notion to our road support structures, the smoother a road structure would be, the more noisier the environment around that would be. And the corrugated bridge structure would be, the less noisier the environment around it would be. And all of this, again, could be simulated with the help of digital twins, where you can visualize the bridge, or where you can visualize the structure in that nuanced position and create different, let's say, noise pollution parameters on which would be the best area to have a society over here. Another such use case would be intermodal transport connectivity. How do we connect different modes of transport? Let's say from a taxi or a cab to a bus to a train, and thereby to other means in some sense. How are different modes linked together so that a person who is conducting a longer journey, let's say an intercity journey, they have all the data points visualized to them. They're not feeling lost with the information. They're not feeling that this is something that they don't need to look out or they need to work out for. Another scenario would be around emergency response management. Whenever there is an event happening or whenever there is a critical alert happening, how far is the police or how far are the emergency medical services from that particular location? All these situations, again, can be planned with the help of digital twins. Pedestrian flow analysis. How often a pedestrian or how often are people following a particular road, especially if you talk, let's say, Delhi or certain busy populated areas of Bangalore for that notion, the Connaught Place market, for example. If we understand the flow of pedestrians around that area, we can understand the flow of traffic and how to guide the cars and the vehicles properly around that area, especially during hours of peak, let's say, traffic and pedestrian flow. And likewise, we can even simulate smart parking solutions because we already know which areas are occupied, which areas are not. We can thereby help the citizens guide to the right areas, right, and help them manage their parking times very efficiently. Another such use case would be around event traffic management, especially when there is, let's say, a very big concert happening. You would have heard the recent news that Taylor Swift concert in Singapore basically was a very big boom to the economy. One of the other reasons why that boom to the economy happened was because the city planned the concert in such a manner that the citizens that are enjoying the concerts have all the facilities available to them at the best possible, let's say, scenarios and the best possible optimization parameters. This is the same thing that we can optimize for our metro cities. We can plan major events for all these main pop stars or even international pop stars. And one of the reasons why these international pop stars don't or they refuse to come to India is primarily because of our event infrastructure planning. Now, if we have a digital twin with the right kind of event simulation scenarios built for traffic, for other amenities, why wouldn't anybody else come or want to come over here once we have enough data to prove to them that we have this infrastructure and this logistics capability sorted out? So digital twins would help us solve one such scenario in these cases. And one of the last use cases that I want to just touch upon is upon public transport efficiency. How we can monitor and change certain aspects of public routes and understand what if we change this drop point of a metro station from, let's say, HSR layout to Bangalore Road or to some other Bomanhalli or to some other area. How would it impact the citizens or how would it impact the livelihood of people who are residing nearby those areas? So these are just some of the use cases which I wanted to delve deep on, and these are again some 10 odd use cases that we can open up more. The point or the notion that I want to highlight with all of you is that digital twin is essentially a new way of understanding software. It's a new way of consuming information. As long as we have the right information, which is through our telco data providers, which is through our satellite data providers, our IoT sensors, historical data providers, we are now having this data visualized in a more nuanced and a more immersive manner with the help of digital twins. And with that, we're able to control, we're able to simulate, predict, monitor, and analyze what will happen based on those parameters. So definitely this is the future of how software and of how data visualization is going to happen. And I'm glad that our government is jumping on this bandwagon. Apart from the Australian government, I believe Indian government has one of the best initiatives in digital twin, and the Sangam Digital Twin initiative is one of the testimony of that. And given how this whole situation is architected, and even in our Sangam EOI, there is a definite architecture there mentioned on how different ecosystems players can come together and work. On the same note, we have also designed our technology architecture in a manner that different people and different elements, right from the hardware layer that you see on the left to the real-time data layer in the bottom or historical data layer on the top, all of them can come together and aggregate in the form of some visualization that we can run on our platform, and we can forward that to other ecosystem players in the form of a 3D viewer, in the form of a data viewer, or even a published application. So in the end, it's like a Lego system. Whichever layer the best data or the best visualization fits in, we can expand on top of that. And on that note, I'd like to just give you a quick summary of what our company CloudWorks is about. And after this, I'll conclude with a quick demo video to showcase some of the capabilities that we've enabled in digital twins. Now at CloudWorks, our primary forte is in enabling the capabilities of Industry 4.0 and Industrial IoT with the help of digital twins. We've already done this for some of big name clients such as Mercedes, Swinburne, and Capgemini, where we have created digital twins of auto parts, of shipping terminals, and of electrical substations, which are really complex machineries and really complex environments. And we've helped them achieve significant reduction in the mean time to troubleshoot, the mean time to optimize failures, and basically increase the overall productivity of an organization by as much as 40%. We do this with a three-pronged approach. Our first plan is to come up with a digital twin action plan where we understand our organization's problems, we understand the challenges that you're facing, and we come up with, let's say, a means and methodology on what kind of features we can implement with those digital twins. Then we come up with certain use cases that define success parameters for you. Those use cases could be around, say, pure simple visualization, could be around simulation, could be around data analytics, could be around any of the parameters that are one of the killer use cases for your businesses in some sense. And finally, we implement this as an application to give you significant ROI in the form of an application implementation. We've done that all across the globe, across 9 countries, with 20 types of digital twin products and use cases created from smart homes to smart buildings to AR applications to enterprise metaverse applications and other digital twin solutions. There was a video actually. If you'd allow me, I'll just quickly play a demo video and help you all understand our parameters once. No, it was actually before the slide. Should I give you the YouTube link? It's in the PDF. I shared a new one just now.
No, we don't have video with that, with the PDF.
Or if I could give you the link, can you play it directly?
The link, just give me the link.
I'll just forward it to you.
Later we'll have it. We can have it later. We can have it later. Till the time we'll call the other speaker.
Sure. I guess I'll take a leave in the meanwhile. We will share a video, or we'll play a video for all of you in the meanwhile, or in a couple of minutes later, where we could highlight some of the use cases and some of the capabilities of digital twin that we have completed as a company. That would help you visualize the power and visualization and the real-time capability that we've enabled. Thank you for the opportunity, and in the meanwhile, I'll leave you all to the next speaker. Thank you.
Thank you, Yuvraj. Indeed, I hope that all the use cases that you've mentioned and you've submitted as part of the living list or as a response to our UI, I believe.
Yeah.
So moving ahead to our third speaker, and so our third speaker is Mr. Raghu Krishnapuram, Senior Scientist, IUDX Program Unit. Sir is a Senior Scientist at FSID ISC. His work experience spans both academia and industry across continents over almost 4 decades. Sir has an illustrious work experience. He has worked with IBM Research, IBM TJ Watson Center. He has led numerous projects. And in fact, I would request everybody to search his name on Google. You will find him as a Google scholar. So that is something again brilliant. And Sir is, as part of IUDX, is also working as part of DPI's third layer, as we talk about, which is the data exchange. And as Secretary Sir at Sangam, Delhi, mentioned that we need to break silos and take data from diverse places. So this data exchange would actually help us in that. So without further ado, and with a huge round of applause, please welcome Mr. Raghu Krishnapuram.
where is this one?
Front, back. Green one is front.
Okay. Okay, good afternoon and thank you everyone for this opportunity. I just noticed that I am the only non-industry speaker in this whole program, but that's okay. Actually, I also worked for industry for many years, but I think I have something very important to say and hope people will appreciate it and understand what I'm saying. So this morning in the welcome session as well as in other sessions, people talked about data, the importance of data, bringing different data sources together, using the data, building applications, all of these things. But none of the talks actually focused on that and how to do this, right? So that's what I'm going to be talking about. And we actually have created an asset, and I think this would be very useful. And I'll explain how this can be used to build digital twins. And we've had some thoughts about it. In fact, we were embarking on the same exercise, but it's a good opportunity that we saw in today's meeting. So, okay. So I'm going to be talking about what is called the IUDX, which stands for India Urban Data Exchange. This is actually a project that was funded by the Ministry of Housing and Urban Affairs. So it's actually a Government of India sponsored program. And we've been receiving funding for it for almost 4 years. It started around 2019 initially. And so the idea here was to create a data exchange that would bring both public and private data. Initially it was non-personal data. I'll also talk about how we can include personal data in this, but it's a data exchange that we built. And what it does is it brings all the data together in a form that can be shared by multiple users. It's completely open source. It's collaborative because government, industry and academia are coming together to do this. It's all being done at ISC as a project. And we also have governance and policy and economic aspects of this addressed. And this solution has already been deployed across India, actually many, many cities, about 38 cities already. And there are many variants of this data exchange. So it is, for example, there is a variation we created for the government of Telangana, which is called Agriculture Data Exchange, ADX. And there is a privacy preserving data exchange. There is a UGIX, which is geospatial data exchange. So I'll talk about some of these things a little bit later. But just very quickly, what is IUDX? So IUDX, again, as I said, is you have a lot of public data, you have private data, and all of this you want to bring all this data together, but you want to bring this together in a way that can be used very easily by other people. The data should be shareable. The data formats should be standardized because every data source has its own format. So if you just put out all this data, nobody can use this data. So one of the big exercises we did was actually to standardize all this data and also standardize all the APIs. So that is actually a big thing because anybody that wants to use the data, they know what the data means, they know the semantics, etc. And so we bring in data models which are open data models. We bring in best practices in the field and many use case templates, etc. And also policy and also issues related to data monetization. So all this data, once it comes into IUDX, it can be shared with anyone, but only with the consent of the data owner. So the data owner is still the data provider. For example, if the city is giving some data, they are the owners, and without their permission, nobody can get this data. So that's how this whole thing works. As I said earlier, so at the top layer, you have actually standardized APIs. And also standardize open data models, which is very important because you don't want data, people should know what data they're getting and how to use it and what are the semantics. And it could be open to anyone that wants to use it. So the point is that any application may require data from many different sources. So for example, telco data could be used by many, many people. So a telco company or any other source, they could not be sending data to so many people. It's actually a waste of effort and also a lot of egress charges you would incur. So all the data could come to one place, right? So, and from many, many different sources. Whoever wants it, they can use this data combined in various ways to build many different applications. And it has three different aspects. One is the catalog server, which allows you to describe the data, what is in the data, and people can search for it and find the data. And there is a consent server, which is looking at security, privacy, payments, all of these different things. And then the resource server, which actually transfers the data. So this is how it works. And it's all cloud-based. It is completely open source, and we have followed the best practices. So it can be used very, very safely. So for example, as I said, the access control is designed in such a way that the owners have to permit. So without their permission, nobody can use the data. Can you hear me? Yeah. A lot of privacy aspects are already addressed. It is secure by design. It's already certified by STQC, etc. Right? So now, the other thing that's important is that we have followed ontologies. The ontologies that we followed, they're all semantically backed through JSON LD and RDF-based ontologies. So this is not something we've thought up on our own, but we have used the best practices around the world. And so that makes it very easy for people to use the data because they understand what is in the data and what are the semantics. Similarly, more advanced concepts are built from fundamental definitions. So this is like a hierarchy, right? So you have ontologies built based on more fundamental concepts. You actually build more advanced concepts, etc. So you can build very, very complex ontologies this way. For example, if you want to represent a very complex thing, you can start from the base and then you can build up the ontology. And similarly, it's not just for representing data or objects, but there's also this ontology can be extended to capture the semantics of processes. So processes also will have some semantics. So you can also describe what is in a particular process, what is the input that the process requires, what are the semantics of the input, what is the, for example, the process or analytic algorithm, what is it producing, so that people understand what is coming out of this algorithm, and it can be used by other people because they understand what is happening. And so that way you can chain these algorithms and processes together very easily. And it all makes it very interchangeable. So if you don't have something like this, what happens is you will have, in our case, because we're talking about digital twins, you may have a multitude of digital twins. Each one is using its own data formats. Each one is using their own algorithms, etc. And they're not interchangeable. You cannot mix and match them. So you'll create, hundreds and even thousands of silos, which actually is probably not what we want to do. So that is one reason actually we wanted to pitch this today. So the other aspect of this is that initially, of course, we started with just the data exchange layer, DX layer, which is shown at the bottom. But many times what happens is many applications, they don't want the raw data. They want actually some process data. For example, a very simple way of processing data would be to clean the data. You want to cleanse the data and then let users make use of the cleansed data rather than each one subscribing to the raw data and then they are doing their own cleansing. So that's not what we want. And similarly, you can also provide historical averages of certain things. So some algorithms will require historical averages. So to compute historical averages, they have to download a huge amount of data and they'll have to do all the processing. So we could actually do that. So the process data could be specific for different domains. So for example, solid waste management would have its own requirements for process data, air quality, ITMS, etc. So some simple analytics could also be provided. So for example, in the case of transportation, if you have data coming from the GPS locations, the buses, etc., we could actually build a very simple algorithm that would estimate the expected arrival time, and the expected arrival time could be provided as a service, and people could download that service and build applications on top of that. For example, multimodal transportation, you could combine a lot of this information and to build a multimodal transportation. So that's basically and one example of process data would be, we have camera feeds from many locations. For example, in Bangalore, I'll talk about this later. So rather than providing the raw camera feeds, you could actually process that and then just provide vehicle counts, how many vehicles are passing at any particular time, etc. Similarly, vehicle speeds could be computed from the video data. Rather than transmitting the raw video, you could just send the vehicle speed information. We could also send the queue length, like how much traffic is piled up at a particular intersection. All of these things would be examples of processed data rather than raw data, which can be used by applications. So this is another example. If you want to know like how vehicles are turning at a particular intersection, how many are turning left, how many are going straight, etc. That information can be generated using the raw video by using some tracking algorithms. So the IODX actually is deployed, as I said, in over 38 cities, and many, many types of data we already have from these 38 cities. The cities are listed here. In fact, LCTA is one of them. Okay, in fact, this whole effort started here. Then we have, environmental, bus transit, solid waste, all of these are there. And then we have actually many, many use cases. Some of them are already talked about, right? So now, when this project was still ongoing, we actually started this other, just a minute, this other project called UGIX, which is about geospatial data exchange. So with this, we are collaborating with Survey of India, and this is a new project that we've embarked. And so this is allowing us to exchange geospatial data, and this is funded by DST. So the idea is to integrate geospatial data into what we're already doing for the cities. So that's the other thing. And we've also done many others, as I said, the agricultural data exchange and things like that. So, and we're also addressing some of the privacy issues, for example, providing trusted compute layers, and also other kinds of differential privacy and various other things, because many of the data is private, so we have to look at that. And finally, I just want to show this one picture to illustrate how this IODX can be used in the digital twins project. So you have the data exchange here. You have a lot of data coming from many, many different sources. And so the thing is that I said the data comes in many, many formats. So you will have to standardize all this data, and you can store this data in some standard form. Now we are talking about AI and algorithms and prediction and so on. So all of these algorithms would actually require training data. So to create the training data, the training data cannot be, you cannot use the raw data for training, because the algorithm would require very different formats and so on. So you can create a data exchange for training data, which would extract data from these various formats, and then you would allow them to build various models like weather models, hydrological models, pollution models. All these models could be built. And there are fundamental models, and there are other models which use the fundamental models, right? So for example, traffic depends on weather, it depends on various other things. Now, once you build the models, of course, you can send this. If you have real-time data, that will go through the models, and you can use it for prediction. And this data can go into, for example, your digital versions of the physical world to visualize what-if scenarios and various other things, right? So you can either take make some decisions based on the predictions, or you could do what-if scenarios if you have the digital versions of the physical world. So this is how this whole thing, the cycle would work. So that's the kind of thing that. So one thing to remember here is that the physical world is changing very, very often. So this is like a cycle. This is not frozen. So you have more data coming in, and everything has to be updated constantly. So I think that's. I just want to mention that we have signed an MOU with the Bangalore Traffic Police, and we are actually doing something for them. Like for example, we're getting data from 6,000 cameras, and we can show the hotspots of where the violations are happening in the city, and so on. And also just one. I don't know. I think this one has just one last slide here. Professor P.P. Mujumdar of ISC. So we're also working on actually urban flood prediction model, where we use the digital elevation models and hydrological models and a lot of other data and the weather prediction models to predict where flooding may happen in different parts of the city. You can see how the flood is growing. You can see, and the floods could be predicted 48 hours in advance or 24 hours in advance. So in fact, if you recall, in Bangalore 3 years ago, there was like a very large flood, right? And that flood was predicted by this algorithm 2 days in advance. So if somebody had paid attention, they could have actually done a lot of work to prevent the damage. So that's all I want to say, but I'll be happy to answer any questions maybe later. Yeah? Okay.
Thank you so much, sir, for the insightful presentation. And as we already know, Honorable Union Minister Ashwini Vaishnaw sir recently launched Niti for States. So the government also has a clear mandate of collating all the database together from diverse sources to have a data-driven governance. And you at a very center stage are also helping in that. So thank you so much, sir. A huge round of applause. So now we move, and also I'm really sorry that I keep pressing the button, it's really intimidating, but we need to give time to everybody, so everybody has their own presentations. Yeah. So moving towards the next speaker, we have Mr. S.R. Nair, Senior Solution Architect. Yeah. So he has 25 years of experience in the field of visual computing. He's currently working as Senior Solutions Architect for NVIDIA Graphics in Bangalore. His focus areas include accelerated compute infrastructure, high performance computing, professional visualization and graphics visualization. He's passionate about emerging technologies and is a proud evangelist of AI and accelerated computing. So would request everybody to give a huge round of applause once again and welcome our next speaker.
It's a very humbling experience to be standing here after such beautiful, technologically intense presentations. Unfortunately, you're not going to see that kind of depth in my presentation, so anticipatory bail, right? I work as a Senior Solutions Architect for NVIDIA, and if you're following the news, if you're following the technology industry, NVIDIA had been a pioneer in the AI area. Before we ventured into AI, we had been the pioneers in graphics, creating graphics, whatever you see on the screen today. Some part of it our company is involved in. So what I want to talk to you about today is about the metaverse, which is basically another name, if you actually ask me, for digital twins in a different avatar. And what I want to talk about is some of the use cases, very few, and a platform which basically helps you to create beautiful digital twins, virtual worlds. That's basically what I want to discuss with you today. All right. Okay. So if you look at NVIDIA from our point of view, the metaverse is an extension of the internet that we have today. It's a 3D evolution of the internet that we have today. The data that we see in 2D, the data that we explore in 2D, it basically extends into 3D. That's basically what metaverse is all about, as far as we are concerned. And metaverse, it basically incorporates a lot of things. AI is definitely going to be at the back end of it, because a lot of intelligence has to go into a digital twin for the digital twin to act or to be of any use. So AI definitely is going to be a major part of that. And then a lot of visualization is also a part of that, because without proper visualization, digital twin it doesn't look good, and many of the functionalities of a digital twin cannot be performed if the digital twin is not of a high visual quality. So that's basically two components which basically will converge when we talk about digital twins. And Metaverse is already here, as some of our speakers mentioned. AI is already here. We have been using it for a long time. Digital twins are already here. We had been using it for a long time, even though we didn't call them digital twins, or even though we didn't know that we are using digital twins. But today, these are in a different avatar altogether. And the pictures that you see here, the photos that you see here are actual use cases of digital twins from the enterprise market. You can see virtual avatars on the virtual avatars here. You can see AR, VR application of metaverse. There is plant or warehouse automation, which you see here. This is a scientific visualization of a particular component in metaverse. This is an application created in metaverse for designing the antenna placement of 5G networks. So this is basically using ray tracing technologies to visualize, simulate beam formation of 5G with antennas, and you can see the kind of visual fidelity that has been built into it. And this is very important for this kind of use case. And then you have the plant simulation. You can see an automobile assembly line here. This is autonomously driven vehicles. How do you simulate conditions for an autonomously driven vehicle so that you can train that? And the last one which you see here is basically a replica of the Earth itself. So the kind of scale that we talk about when we talk about metaverse is huge, and it keeps on changing. When we ventured into creating metaverse, or the platform for creating metaverse, and we talk about platforms, right? We don't talk about, I don't bring a metaverse and bring it to you. I don't build a metaverse. I give you the platform, I give you the tools to build your own metaverse, your own digital twins. That's basically what I do. And when we are exploring the platform, the ideal platform for creating metaverses or digital twins, there were certain basic fundamental requirements that we had in mind. First of all, it has to be based on open standards. Open standards encourage collaboration, it encourages contribution from the community, so the technology has to be based on something which is an open standard. The technology has to be scalable, because today the scales of metaverse or the scales of digital twin are varied or vast. It can be started from something like a simple product as a digital twin. It can be something like a plant as a digital twin, or it can even go to a planetary scale. So according to your requirement, according to your definition or the change in definition, the solution, the platform should have the capability to scale accordingly. It should be capable of creating realistic simulation, physical simulation. You are basically creating a digital twin, which is a replica of something which already exists or which you are planning to build. So whatever happens in a physical world with that particular model, particular product or solution or plant or ecology, that has to be replicated in your digital twin. That's only then it's a digital twin, otherwise it's just a replica, it's a model. So simulation has to be a major component of your digital twin, so the platform should be amenable to integrating simulation at various scales and various depths. Of course, and last but not the least, it should be compatible with AI. You should be able to easily integrate AI into it, whether it's an AI model or whether it's AI which is integrated into the platform itself. It should be amenable to integrating AI into it. So these are some of the basic fundamentals which we considered when we were thinking of creating a platform for digital twins. So when we are talking about open standard, we considered different technologies, different platforms in the industry, and we finalized on something called as Universal Scene Description, right? USD. Now USD is an open standard. It's an open source project which was created by Pixar, which is a leading 3D animation company in the world. Their requirement was very simple when they created it. They had multiple different teams which were working on the same project, which was a 3D project, or multiple different teams spread in different locations working on the same project. Now, parts of these projects were being handled by different applications, different teams. So the data which was flowing in from these applications, these teams, were diverse. They were not of the same type, they were not from the same application, they were not of the same format. And they wanted to integrate all of this into a single scene. And that's where the thought process of a single standard, which is open standard, for creating or managing assets in 3D came into picture. And that's how they created this open standard called as Universal Scene Descriptor. And we selected Universal Scene Descriptor, or USD as we call it, as the candidate because it had many functionalities which helped collaborative creation. For example, you can actually layer different types of data into USD. And you can also create multiple copies of that layer. So if I have a certain layer which has to be edited by, let's say, 2 different applications, I can create 2 different layers of that data, and the editing can be done non-destructively. So my universal source, my single source of truth, that remains as is, whereas the editing happens on the layer. So that's basically one of the reasons why we selected USD as a standard for creating our metaverse platform. So once you have this platform in place, and this platform which I'm going to talk about is called Omniverse, NVIDIA Omniverse, it can basically connect pretty much every segment of your digital creation, whether it is your architects or whether it's your AI-enabled avatars or your participants in the form of reviewers or designers. All of them can be brought into one platform without having to worry about how the data is going to flow in, or how the data is going to flow out, or how the integration of all of these components are going to happen in that particular project. And once you have the metaverse in place, once you have the digital twins in place, it unlocks a whole new class of simulation capabilities so now the one which I have shown here is basically an automobile plant where a car is getting assembled. Now for these kind of customers, time saved is money. Right? If I can assemble 10 cars instead of 8 cars in a certain given amount of time, then I'm going to make more money. I'm going to save a lot of money. So the example which I have taken here is basically of that of plant design or a plant assembly line, but it is applicable to any digital twin process that you can think of. 2 more minutes. So this is again a known fact. Digital twins basically create superpowers for the enterprise or for any of the markets. You can teleport, you can travel to the past, you can travel to the future, you can simulate multiple different scenarios, what-if scenarios, and that's basically what the platform should be capable of when you think of it. And now when we talk about digital twins, those are at different scales. The first one which you see here is basically a product digital twin. This is a car configurator. The second one which you see here is a factory floor. Third one is a city scale where you can load a complete cityscape into the platform. And the fourth one which you see here is at a planetary scale. Why we did this is because we wanted to create a replica of Earth so that we could study the climate changes, the actions, the effects on climate scenarios, and that's basically what we are doing with one of our scientific customers. Omniverse basically brings all of these components together. Your designers, creators, engineers, everyone. All the data can be stored in a single place, which enables collaboration. It can be perceived in possible different ways. You can integrate AI into it. You can integrate physics into it, materials into it. So everything that you need to bring into a digital twin is basically possible in Omniverse. And because it's a platform, you can actually build on top of this. So this is not just like it's not a tool, it's a platform. So you can bring in any type of data. You can create connectors. You can create microservices on top of this. And pretty much anything is possible if you have this platform in place. Without going into too much details of Omniverse as a platform, these are some of the generative AI technologies that we have integrated into Omniverse, creating scene backdrops. Now, this is very interesting. You can just type in a description and the generative AI models will create that scene for you, right, that particular description for you. Similarly, you can create different styles, different types of 3D assets just by typing in a description, adding a stop sign here. I said add graphic to the stop sign and it will basically add something like this. Rest, it will add rest. So it makes it very easy for the creator to experiment with different scenarios. You don't have to be a 3D creator for doing this. You can actually use generative AI to create things like that. Again, you can also create, reconstruct scenes. For example, if you want to create a folk scene in Bangalore, if you want to create a scene where Bangalore is covered in fog, and I am trying to direct traffic properly, I can actually create that scene in Omniverse, because I don't see much of the fog in Bangalore today. Or I can say that show me a scene where it snows in Bangalore. I can even do that. So you can actually recreate, or you can synthetically create scenes. You can synthetically create data so that you can train your AI network using that. All right. So before I stop, I'll just show you one small video of Deutsche Bahn. Now, Deutsche Bahn is a German rail agency. They have around 5,300 stations and around 33,000 kilometers of rail network. What they wanted to do was increase the number of trains or increase the number of services without having to add more amount of tracks. So they created a digital twin of their entire railway network, including the tracks, the stations, the trains, everything. And this is basically a success story of that. Please play the video.
Digitales Deutschland, or DSD, part of German railway network Deutsche Bahn, is designing and building a digital twin of its rail network to maximize transport efficiency and capacity without building new tracks. Realizing a digital twin of 5,700 stations and 33,000 kilometers of railways is a massive undertaking, requiring a custom 3D pipeline connecting DSD's HD map with CAD datasets and simulation tools, including those from Siemens JT ecosystem. In NVIDIA Omniverse, based on Open 3D Framework Universal Scene Description, the teams are able to connect and aggregate critical data sources into a single high-fidelity model. With a single source of truth, DSD can use the digital twin to test and validate the entire network, enabling continuous improvement in the deployment of vehicles and railways, maximizing operational efficiency and speed while reducing costs. Beyond simulation, the digital twin will provide the environment to train the complex AI that manages the fully automated railway system. Running on NVIDIA OVX, the digital twin can be synchronized to the real-world trains and rail networks via 5G-enabled sensors and 5G Edge microcells. If a train's cameras or LiDAR sensors detect a potential hazard, its precise location can be quickly relayed to the rest of the trains in the network, preventing a collision or congestion. If the AI-powered computer vision-enabled cameras at a station notice an issue, an event can be triggered to instantly notify personnel. The intelligent sensors are trained and optimized on a combination of real-world and synthetic data generated by Omniverse Replicator, ensuring the models can perceive, plan, and act when faced with any scenario. With Omniverse AI-enabled digital twins, Deutsche Bahn is working to increase efficiency and capacity of the existing rail networks, reducing waste and carbon footprint, while keeping passengers and goods on time.
Thank you so much. That's it.
Thank you so much, sir. Thank you so much, sir, for enlightening session on the Omniverse, Metaverse. I hope you create my digital avatar as well. And so also we promised that we need to play Yuvraj CloudWorks video. So before we go into question answers for this session, I would request the team to play the video for CloudWorks. Do you want to come?
Yeah, good afternoon, everyone. So this video is a just quick demo walkthrough of the kind of enterprise solution that we've created for one of our large system integrator clients. It consists of a combination of 3 whole units, which are a factory, a warehouse, and an electrical substation, combined in one unit altogether. So this is a screen recording of our real-time application, as you see over here. Yeah, Kaushik, you can forward to the factory part a bit ahead. So it's a concept meta city that we've created, which has a lot of moving parts, especially this factory, which is moving in real time, fetching all the data from real-time IoT sensors and allowing you to visualize it in this kind of a manner. It is powered with all the analytics. So as you click on any of these analytical frameworks, it will open up the right graph, the right values, the right parameters, allowing you to control, monitor, and even visualize what is happening inside your factory in some sense. We take it a level ahead by even simulating certain processes. For example, for this particular inspection area, you can simulate what would be my box output if I increase, let's say, a certain number of machines, or if I decrease a certain number of machines. And accordingly, you can see how the machines are behaving in real time, which part that they're working on, and at which stage are they working on in the particular process. And we supplemented and we overlay data in the form of these heat maps. So you don't have to look at tons of graphs, charts, and dashboards. All the data is overlaid in the form of these colored gradients from red to green on top of the 3D assets. So it's entirely visual. In one look, you know which area of the factory are consuming more energy or emitting more carbon dioxide or having certain idle time on different processes accordingly. And with our X-ray view, you can even pinpoint specific areas. For example, only look at the IoT-based devices, or only look at devices which are consuming the most amount of energy, and segregate them from the rest of the view. Yeah, Kaushik, you can go to the warehouse scene now. And similarly, we can even consider this entire aspect for an entire warehouse, where in this particular scene, we modeled an actual warehouse, which is a facility in Spain, Guadalajara. And this warehouse has more than 15,000 bins in consideration, which are being monitored, controlled, and simulated in this 3D digital twin environment. I can just forward a bit. Yeah, so you can see the scale of the warehouse that we're capturing and we're tagging over here. Again, all the data is all real time. It is fetched from the enterprise warehouse management software that is implemented by SAP. So we are directly integrating all our existing ERP data and creating this kind of an immersive scene. Yeah, Kaushik, I think we will skip over to the pathfinding scene in the warehouse. The heat map of the bins and the pathfinding, yeah. So similarly, if you look at the heat map feature, this brings a lot more value when we look at these bins in the same color gradient rather than just graphs and charts. And understanding alerts, creating annotations, leaving remarks for the rest of the team also becomes very seamless in this entire 3D editor. You can pick or draw or annotate certain areas, leave comments for your on-field workers or for other people in the team to look at, to inspect, and solve the problem accordingly. Yeah, I think lastly, we can skip over to the substation scene. Now, this is the most complex scene that we've created. It is actually a digital twin of the Manesar substation that is there by Power Grid. It's a 440 kV GIS plant. Now, apart from modeling the transformers, connecting them with real-time data, the most complicated unit or the most complicated scene over here was the substation unit that is housed inside. Now, you can see the level of detail that we're capturing. Kaushik, you can skip ahead a bit. Yeah, so you can see the level of detail that we're capturing for the substation twin that is housed inside. Right from, I would say, almost a centimeter level accuracy to getting all the wires, all the junction boxes, all the connections, everything in place. Now, once we're able to visualize this complex machinery, this complex unit in this digital twin, overlay it with real-time data, the benefit that the organization gets is it helps them reduce the time to troubleshoot, helps them reduce the time to solve any errors and issues. And as it was evident by Power Grid in one of their domains and use cases, in the previous scenario, a troubleshooting issue would take a week or even 2 weeks to solve. Whereas with the help of digital twins, it's now taking just 1 day to 3 days to solve end to end. So this was the quick demo and the quick video that I wanted to play for all of you to help you understand the kind of capabilities and the kind of solutions that we at Cloudworks are enabling with real-time applications for our clients, giving them significant ROI and real-time and real tangible returns and benefits with the help of advanced 3D visualizations and advanced complex solutions, as you see in the video. Thank you.
Thank you, Yuvraj, for such an important use case. Our Honorable Prime Minister has a couple of weeks back launched the world's largest grain storage scheme. So it would actually find a good use case over there as well. So with this, we come to end of session 3. I would request the audience to ask questions from the speakers. Anybody who has any questions? So there's somebody who's, yeah.
Yeah, and all the presentations were good. I specifically wanted to discuss on the IUDX program unit. I mean, that's a big problem that you've solved in a sense. Data exchange of, I don't know, unformatted data or whatever. I know, I'm not going to ask you how you solved it because that's going to be a very complex problem, I presume. Some of the aspects that I want you to throw light on is how did you have the data providers standardize the data? Because that's, why would A, B, C standardize the data just because you're asking it? Did you enforce them to do it, or they said, because what is the value add that they saw in standardizing the data? That is one. And how different is it from the MUGD platform that the government of India is already giving? I think there is open source data that's available for us, and I'm assuming it's just a data exchange platform, but I mean, I have loads of questions, but I would want you to help me answer these.
Raghu sir.
Yeah, can you hear me? Yeah, about sanitization. Okay. So about the sanitization, actually it's the owner's responsibility. So we will exchange whatever they give us. So we're not actually doing anything for them. But without, can you hear me? Yeah, so without their consent, we cannot exchange the data. So they'll have to permit us to do that. Whoever wants, they will send a request, and the owner would have to approve. But we don't really sanitize the data or do anything. As I said, what we are trying to do is actually, in some cases, also provide process data. So the original data, we can process the data to create some new properties or new features out of it, and that also can be exchanged. We don't enforce. We take whatever form they give us, and then we convert that. We have adapters that to convert them to the standard format. So that is it. Yes, yes. They will have to explain to us, but we'll convert the data. I'm not sure if I couldn't hear you very well. Yeah, of course. If there's a lot of providers, yeah, we will have to scale. So we built our platform in such a way that it is scalable, but yeah, at some point we may have to revisit. Yeah.
Thank you. So we come together for a group photo. And any more questions?
I'm Prakash from Sira. This is also regarding the data exchange. Two aspects. One is privacy aspects. Usually we are associated only with the person or his Aadhaar number and so on. But when you pass the city traffic, the vehicle movement, the vehicle's number and so on can also be extracted out and so on. So
yes.
How do you draw a line? Where does the personal and where does the city boundaries come, right? Let's say even let's say the telecom data, you are tracking the signal of a mobile from point A to point C. You actually know his movements or the vehicle number. So usually it's almost as private as this one at a meta level. Maybe somebody can always track me. So how is this handled? First question. Second one, the data exchange aspect, is there, can an attempt be made to engage organizations like TSGSI, which is the telecom standards body, so that there is some sort of interplay between the data models here and the standardization that is happening there?
Right. Yeah. Yes. So the second aspect, I agree. I think we have not actually hosted any telco data, but that would be a good discussion because I think telco data is very, very useful. Regarding privacy, as I said earlier, it's the owner that has to decide what data can be shared, what they don't want to share, and how or who they should be shared with. So we don't actually allow anyone to download the data or access the data. The owner has to permit. and the owner also can specify what data can be shared and how it should be shared. So the privacy has to be addressed by the owner. But so having said that, we also have some technologies, data preserving technologies. So we can take the data through those technologies and make that available. If that is suitable for the owner, we could have that discussion. So, yeah.
The point I'm making is that you are saying that the owner has the access and owner can say yes or no. I'm saying the legal or the privacy framework should also get into the architecture. I know that is.
It is actually part of.
It's not just an access, it is also even the owner can have it or not. Let's say I'm just having a CCTV in front of my house. Can I take snapshot of everybody, right? Even though I'm the owner of the data, do I have the privacy rights of the other people? So that legal framework should also become a part of the data model and the language.
I'm sorry for the interruption. The follow-up question can also happen later. Thank you. A huge round of applause for all the speakers, please. So we'll gather for a group photo, and I would also like to request DDG Asif Kadian sir to take care of the proceedings. First, we can have a group photograph of all the session 3 speakers, please.
Yes, I'll.
Good evening to all, and this is a panel discussion on pioneering solutions for tomorrow, but we have a limited time. We have to finish this before 4 p.m. So now I will invite a few panelists. First of all, I will invite Dr. Anirudh Roy, who is a CTO Genesis. Sir, please join panel. Dr. Anirudh Roy is from Genesis, and he has spearheaded Delhi State Spatial Data Infrastructure and National Spatial Data Infrastructure projects. He has also served as a technical head of ESRI India and project scientist at CSRE IIT Bombay. He has done his PhD in environmental science and engineering. He is currently volunteering as a member in FICCI National Space and Geospatial Committee and as a technical member of the Geospatial Committee. Thank you, sir, for joining this panel. Now I will call Mr. Kannan from Bentley System. Mr. Kannan is Regional Executive of South Asia Bentley System. Thank you. Please have a seat. He has done he is business management professional in IT and over 25 years of experience. So thank you very much for joining this panel. Next I will call Mr. Anant Sampath, who is Director Siemens. Mr. Anant has spent more than 27 years in the information technology industry. In this tenure, he has been working with customers in different industry segments like consumer products, manufacturing, IT and ES, telecom and public sector. This involves some of the customers' problems with solution selling, application software, platform software, and IT infrastructure products with a good understanding of IT services. Now I will call Mr. Karthikeyan Subramaniam, Business Head, Samsung, to join the panel. Mr. Karthikeyan Subramaniam has been working in telecommunication system for 2 decades. His primary interest has been research and development of managing 4G and 5G systems. He is currently managing 10 plus global operators as Business Head of Management Software Group. Thank you for joining the panel. Now I will call Mr. Karthik Raja, who is founder of Mozart. Mr. Karthik Raja is helping companies achieve error-free digital experience, synthetic testing and diagnostic platform as a service. He has over 2 decades of experience. He has also founded 5Metrics and Red Pill Solutions. He has worked as a consultant with HP and Arthur D. Little. Thank you, sir, for joining the panel. The last panelist is Mr. Chinmay Matt, CEO and founder, Nimble Vision. He has also done his engineering in electronics and communication and masters in embedded system. Thank you for joining this panel. Welcome to this panel. And panel discussion is on the pioneering solutions for tomorrow's infrastructure planning. And today we have gathered experts from a variety of areas. And in next few minutes, I will request you to just share your experience and your work. So I will request you to restrict that within 2 minutes, please share what you have done because we have a limited time. And then we will dive into the conversation and explore some of the questions to be answered. So I will request from Genesis side.
Thank you, sir. So from Genesis, for the audience, I'd like to just put across one of the aspects of digital twin, and Dr. Rajiv has explained in the previous speech, that in year 2005, Google has been the pioneer in bringing the digital twin. Those who work with open source and open standards, and if you follow that, you see NASA Worldwind, it started in year 2004 as the first open initiative for digital twin. Unfortunately, for the lack of funding, it ended in 2022. It was on the open source. So with that background, let me tell you 2-3 things. The Sangam initiative is all about confluence. Alone, nobody can do much. It's like multiple people joining hands, and that is how you co-create value for the nation building. 2-3 things, just as opening remarks. Very important is that first and foremost is the geometric twin, which is the fundamental, is the foundation layer. The update of the data and the periodicity of the update, it differs. A traffic is very dynamic. Air pollution, it happens, it is very dynamic, but the Mother Earth, it will not change much. So digital terrain model, digital surface model are the 2 different things. While we have been talking about the digital surface model, that how buildings and trees are there, the terrain, which is very important, and I'll just take one use case just for you to relate. Our previous speaker has spoken about the Bangalore flood. We all know that great hardwares are there, softwares are there, great minds are working. But worldwide, the accuracy of the vertical accuracy, what we talk about, is around, we take it from SRTM data, or the data which is coming from other satellite sources, it is 3-meter elevation. What is required that you do not know 10 feet plus minus when you predict the flood. So it is very important that based on the use case, appropriate scaling should be done, appropriate technology should be used. So we as a Genesis, what we felt after there has been an initiative and a reform by Government of India, which is called National Geospatial Policy, which has given plethora of power to the private industries to map every inch of the land. We have started our content program to create very accurate 3D replica of the cities, and on top of that, we start building with help of the solution providers the other value-added applications. This is in brief.
Thank you. Now I will request Mr. Kannan to speak few words.
Good afternoon. First of all, thank you so much for inviting Bentley Systems for this event. On behalf of the management, I would like to thank all the organizers, especially Mr. Kalyan, and of course the eminent speakers from here who have actually given us a lot of ideas in terms of what's happening out here. Coming to Bentley Systems, of course, when I say Bentley, most of the people relate to cars, but we are not a car making company. We are actually making the infrastructure, or I would say provide platforms for engineering the infrastructure on which these cars can run. So we are primarily a company which has been focused only on the infrastructure engineering space, and we are about 40-year-old company headquartered in a place called Exton in Pennsylvania. So coming to this particular area of expertise in Bentley, right? We've been seeing the kind of technological advancements in the infrastructure space. We focus on areas like transportation, water, energy, cities, urban infrastructure, etc. Okay. One of the major advantages that I'm seeing today in India is how data is actually getting collated. Okay. Different kinds of data which are being sought after, whether it is your data coming in from geospatial technologies, as Dr. Roy pointed out, or we are talking about geotechnical data, which is behind, or the subsurface data which is coming up, what are the EDMS systems, the ERP system, the drone data, IoT sensor data, etc. All those things getting integrated. And I'm happy to report that there are a lot of projects which are now in its, I would say, different stages of its project life cycle. Starting from concept till operation maintenance. You take concept, you do planning, you do design, you do analysis, you do construction, you do handover, and then the operation maintenance. The major challenge today, in my opinion, that we need to solve, and I'm citing the Sangam initiative. In fact, Dr. Mithal Gorai, when I met him during the lunchtime, he said, are we kind of expecting something which is unreachable? The answer is, sir, definitely it's possible if we actually put our minds together and thoughts together, work together, right? So the thing is, there are different kinds of data sets which are available, and Bentley as a kind of leader in this space has really made certain projects possible using the digital twin. Okay, so I think from a thought standpoint, a thought process standpoint, I think this is a very good forum to kickstart something like what you have actually talked about. Enough amount of data. And by the way, when we say digital twin, it is going to be an evolving platform moving forward. It's not going to stop somewhere. We can't say that, hey, these 10 things from a digital twin. No. Tomorrow there will be 15 more things which will be awaiting for us to kind of add up. So we need to be ensuring that the platform is going to be ready enough to accept all those things so that it is going to serve the purpose for which it has been intended for. Because if you take, a lot of people say that, hey, this digital twin, is it operational or not operational? We have to keep improvising on that. And especially when you take any kind of project today, the largest span is going to be around the operation maintenance. Because many of the people who do who talk about digital twins, they talk about digital twin in separate phases of project life cycle. But when we think of a digital twin, we need to talk from the concept till the last day of the project, which is your last day of your operation maintenance, right? So I think that is how the thought process need to be. And we need to, so start your digital twin for any kind of greenfield project, start your digital twin right from the design stage, okay? If there are any brownfield, start doing your whatever, retrospective work which needs to be done through scanning and other things now. So I think that the stage is set for everyone for their contribution in terms of, whatever platforms here or technologies you can actually provide. Thank you.
Thank you. Mr. Anand.
Good afternoon, and thank you for this, for inviting us to this session, Dr. Mittal and Mr. Asit sir. Quite simply put, a digital twin as a concept is a virtual layer of a process, a product process, and a service. We, as Siemens Software, we do undertake a lot of projects specifically for manufacturing industries or industries who want to get better insights for their and improve their processes. But then when I saw the EUI document, I realized that while conceptually we might be doing it for specific industries, I guess it just opens our mind and horizons to, what is the actual art of possible to get to where you want. I mean, the insights that you're looking at, probably at multiple layers, at cities, at how industries perform, and this entire initiative, I think, I would really be. I really want to keep my eyes very close to where this would take us and participate in full, so that we really are able to realize the potential. It helps us move from. Right from my childhood, I've always been hearing that we are a developing economy. I think, maybe someday some of these concepts will take us to a developed economy. So I guess, that is what I would like to look at from this entire initiative standpoint.
Then come again. Mr. Karthik. Yes, can you speak 2 minutes that, how do you think that this...
Okay, so I think I think a lot of people have spoken about the platform itself. I was thinking more in terms of some of the use cases on the platform, which, some parts of it which we do, and I'll give some examples of what we do in the public sector itself. So in Philippines, for example, we have a similar platform on the smart cities, but what we use for that, in addition to traffic information, is to just come across security issues which government apps will face, and how potentially it bases the traffic, bases the kind of profile, what are the kinds of security issues you will face in different malls or different metro stations or whatever public spaces at what instant, so they can send some kind of warning to the customers themselves. And similarly, I think in the US, I think they are now about to shut down the 2G and 3G networks. In a very similar model, on a smart city build, basis the terrains. They want to predict where the gaps of 2G and 3G will affect, whether the satellite will cover it, not, and then give it as a customer care app for the customers to come in and press the button and add data. So there are different parts which people do, but I think holistically we will be in a position, I think, to combine all these parts and just talk about what the digital experience would be. That would be a great use case across the entire smart city.
Thank you. So just to cut that process, because I have only 10 minutes to finish, so I will ask questions directly now. So first question is from Mr. Roy. Since morning, we have seen a lot of presentations, and presentations were fantastic. This was really a good digital world which we can see. But sometimes we feel that, is it really realizable or not? Means it is only on presentation, or that can be done. But Genesis, I believe that Genesis has done digital twin work in more than 23 cities. And when we see the digital twin of the city, it seems that it is a costly affair. And it is difficult to get the clearances for doing survey job and all that. So my question to you is that, in your experience, what are the most common challenges encountered when developing digital twin?
Okay, thank you. Very quickly, I'll put across the thoughts. Number one, to our view, digital twin is not monolithic. When I say monolithic, that means we have got a city, those have multiple line departments participate. So we can have a digital twin of roads. We can have the digital twin of the telco network. We can have the digital twin of the dams. So each and every sector can have a digital twin of its own, and it requires a specific thing. When it comes to the requirement, we felt no one sensor, actually real world is very diverse, very complex. So there is a discrete data, there is a continuous data, there is a terrain data. So in order to map that, various kind of surveying equipments are required. We felt satellite data is definitely there, but it is not meeting many purposes. So we felt that drone should be there. When we got into drone, we could see that it is giving a purpose, but we cannot scale it up. So we got for the manned aircraft. So it took us a lot of time to acquire those manned aircraft, get the request permission from the DGCA, and when we actually operate, we getting the line department permission, the local administration permission, but by and large, let me tell you, things have eased out. Number one. So data acquisition part is one part of it. Second, data processing. Individual desktop environment, but now there is a cloud infrastructure we have automated, and now we are leveraging that to jumpstart and make the process very quick. Third part is dissemination. When we disseminate the data, the end users want either in the browser environment or people want in the handheld devices. Even in the handheld devices, somebody wants in Android, somebody wants in iOS. So interoperability is the key. And I think the challenge can be solved through standardization, like the one you heard about. But Bureau of Indian Standards, Survey of India, ISO TC 211 and OGC, these are the standard bodies. Ample data set standards are there, we are leveraging it and we are delivering the solutions.
Thank you. Thank you. Next question is Mr. Kannan. Once digital twin is created, it is not of that much value if what is happening at the moment is not known to that digital twin. So when real-time data is infused to this digital twin and it breathes the life and then it is more useful. So what are the challenges in achieving that, how to infuse the real-time data to the digital twin and integrate with the other systems?
Okay, so good question, sir. Actually, that is what is the kind of advantage of a digital twin, right? Because typically when you see the evolution of technology, we all started with normal CAD drawings, then people talked about BIM, now we are talking about digital twin. The difference is that digital twin is basically an intelligent virtual replica of your real world asset, right? So time factor, which is real time, and human interaction. Both are the additional components beyond what you actually take as a. But for those things, today we have technologies, right? We have IoT sensors or drone kind of data, which are live streaming data to any kind of stuff. For example, there are a lot of examples which, Mr. Tomar was showing, right? He was talking about a plant data, inside a factory. Similarly, there are digital twins which are available for multiple industries. Today, Bentley is involved in specific projects, which is working with Ministry of Housing Affairs and under the Amrut project and JJM project. There's a very interesting project of 24/7 water supply which has been implemented in Ayodhya using WaterSight, which is a digital twin for water actually, and it's real time. Okay. Similarly, there are solutions like bridge monitoring and inspection, dam monitoring and inspection. These kind of solutions are completely real time, getting up to even about 5 to 6 seconds of data which is actually getting fed. So technology is available today, and technology for capturing information, technology for transmitting information, technology for accepting that information and processing it. It is all seamless, sir. It is all operational today. I don't think there should be any challenges here, unless otherwise of course, there is a lack of communication network, then there is a problem. And I think that is where, DOT comes into the picture, right? You are a key foundation of getting the data transferred from the source to the destination.
Thank you.
I mean, you have taken this initiative. I think the foundation starts from you. Yeah.
Thank you. Thank you. Next question is to Mr. Anant. During this journey, there are only 2 outreach programs we have conducted, and we have discussed with many players. And one use case was discussed, that why DigiYatra is confined to only airport terminals, why DigiYatra cannot be extended to downtown, and digital twin creates a trust and that trust is exchangeable, tradable between two stakeholders or two actors. And I believe that Siemens is in the application software, and you are interested in participating in our UI, as you mentioned earlier. So how do you think that how Siemens is positioned to take it forward, this Sangam Digital Twin initiative?
Sir, you know, when we looked at digital twin, Siemens per se, we undertake a lot of digital twin projects more from a manufacturing industry standpoint, be it a auto industry or be it a consumer product industry who's into discrete or a process manufacturing. But then when you look at the concept of digital twin per se, like Mr. Roy said, you use it for smart cities, you use it for healthcare, you use it for education, you use it for, the use of digital twin is only as much as your mind can expand. You just need to figure out the best possible technology. We understand the concept. As Siemens, we understand the concept. We can work with the government to make some of these use cases into reality by using some of our software products.
Okay, thank you. Just I have, his next question is to Mr. Karthikeyan. In your presentation, you mentioned that KPI, telecom KPI, may be very helpful for many of the digital twin use cases. And there was a question from the audience that there is a privacy issue, means a lot of spam, they are getting spams because the data which is made available for this purpose, that also leaks out and that is used for some other purposes. So what do you think that how this KPI data or telco data can be made available for the innovation purpose, but at the same time, from privacy perspective, protections may be there. So one presentation was there about the exchange of the data. Exchange of the data, you need more than that, or that is good enough?
So it's a good question. So in telecom, which are tightly related. Say for example, you have performance data, you have a kind of fault data. So in case if there is any drop in performance, there will be an indicator in fault. All this kind of, we can bring some kind of correlation to this. To answer your question whether we need a kind of real data or can we synthesize data to kind of simulate things, we can bring in equation model, like if there are any faults in a particular, if say for example any degraded KPIs happening in a particular area because of which the throughput is kind of dropping from the last week, then we suspect that actually it can be because of some fault. The fault can be something related to some network devices may go down, or it can be related to some change in the configuration. So all these three things, configuration, performance, fault, are somewhat related, and we can some kind of bring an equation and say that actually that instead of going for a real data, we can also simulate
the synthetic data for training purposes and for others.
Yes.
Thank you very much. Next question is to Mr. Karthik, and my question is that people have created digital twin for the water distribution network, but that may be only an engineering excellence. If really we want to take advantage of that, and for example, I take that if on a railway station, digital twin of the water distribution network is created, and authority persuades you that don't use plastic bottle packaged water, use public water taps. So people say that they don't believe that it is a safe and clean. Whether digital twin can help to create a trust among the people that quality of the water coming out from the public water tap is as safe, as clean, as good as in the case of the plastic water packaged bottle.
Good question, actually. I mean, I think one of the people who have influenced me a lot has been Dr. Richard Thaler, who came up with the concept of nudge for good. And I think a lot of policy makers have used this. In GDPR, basically they have an mandatory opt-in, right, instead of an opt-out. They have a mandatory opt-in, and that created GDPR, right? Just changing an opt-in from an opt-out to opt-in changes the kind of messages and the stuff you get. And these kind of things just work very well with just one button change and one rule change, and that's what Nudge does. So I'll give you a couple of examples of how Dubai did it, right? So they have two initiatives they had done. They did a 30 by 30, which is a fitness month. Every 30 days, everybody does 30 minutes. And in that 30 minutes, wherever you are, if you're in some nice location, it will just tell you, hey, in this location, other people did this kind of exercises. So you can just do that, and it just nudges you to do the 30 by 30 and put the pictures on Instagram and so on. Same way, they didn't have a water issue, but they did have an issue that people were using public bottles, so plastic bottles. And plastic bottles is a huge energy issue. So they came up with the concept of Dubai Can. Like a basic can, and they said this is, so if you take a Dubai can from that local place and be able, this is the nearest Dubai can, and if you are able to go to a water filter, this is the amount of carbon credits that you're going to save.
Mr. Karthik,
these kind of things that come
we are over time, so we have to close it. You can summarize in one line that what is your takeaway from this?
Yeah, hello everyone. I am from Indian Vision. We are into smart water and sewage management using IoT, AI and ML.
Just in one line you finish, because I have to close this.
So for us, the automation along with VR was an evolution for us. With operational efficiency in industries, the RWS is needed, including municipalities. Today, if you see Bangalore is running out of water, and we are helping BWSP and other RWS to conserve this water, every drop of water, with the IoT, AI and VR platform.
Yeah, thank you. Thank you very much. Thank you all for the panelists. I have to cut short because tonight was short. Thank you.
Thank you so much everybody for this insightful panel discussion. So we will have a short quick tea break of 10 minutes and return, and the closing will start at 4:15. Shri BVR Subramaniam, CEO Niti Aayog, Dr. Neeraj Mittal, Secretary Telecom, Shri RR Mittal, DG Telecom, Dr. Debabrat Das, IIIT Delhi Bangalore Director, all dignitaries, officers, our guests from the industry and startups, academia, and enthusiasts from various fields. A very good evening to all of you. Welcome back and welcome to the final closing session of the Sangam Bangalore Outreach program. This session will showcase the leadership perspective for steering Sangam towards transformative success. We are overwhelmed to see huge participation of industry pioneers, startups, academia, innovators, and forward thinkers in the Sangam-Outreach program. The enthusiastic participation in today's events underscores the industry's readiness to support Sangam's vision. With advancement in technology and a collaborative approach, Sangam is poised to redefine infrastructure planning and execution, promising more efficient, sustainable, and community-inclusive outcomes. We are honored and privileged to have amongst us all for this closing ceremony, Shri BVR Subramaniam, CEO Niti Aayog, which is the apex public policy think tank of the Government of India, and Dr. Neeraj Mittal, Chairman Digital Communications Commission and Secretary Telecom. Shri BVR Subramaniam is an Indian Administrative Service Officer of the 1987 batch from Chhattisgarh cadre. Sir has held important assignments over the last 3 decades in Madhya Pradesh, Chhattisgarh, and Jammu and Kashmir, along with a stint at the World Bank. He has been the Secretary in the Ministry of Commerce and Industry, Chief Secretary Jammu and Kashmir, Principal Secretary Government of Chhattisgarh, and has held positions in the Prime Minister's office. Dr. Neeraj Mittal is serving as Secretary Telecom and Chairman DCC. Sir is an Indian Administrative Service Officer of the 1992 Tamil Nadu cadre. Sir has served as the Principal Secretary IT Government of Tamil Nadu and has also served as Senior Advisor at the World Bank Group. Sir's deep passion and experience in technology has led to the conception of Sangam initiative. May I now request our esteemed dignitaries, Shri BVR Subramaniam, CEO Niti Aayog, Dr. Neeraj Mittal, Chairman DCC and Secretary Telecom, Professor Debabrat Das, Director IIIT Bangalore, and Shri RR Mittal, Director General Telecom, for your esteemed presence on the dais for commencement of the closing ceremony. I request everybody for a huge round of applause for our esteemed guests. Thank you, sirs. I request Dr. Rajkumar Upadhyay, CEO CDOT, to welcome Shri BVR Subramaniam, CEO Niti Aayog, by presenting a bouquet to sir. Now I request Shri Robert Ravi, DDG from DOT, to present a bouquet to Dr. Neeraj Mittal to welcome sir. I request Shri S.S. Galgali, DDG Security, Karnataka LSA, to present a bouquet to Shri R.R. Mittal and welcome sir. I request Shri Asit Kadyan, DDG DOT, to present a bouquet to Dr. Debabrat Das and welcome sir. Thank you, sir. We are delighted to have amongst us today's industry leaders who will share with us the insights about Sangam Digital Twin Initiative from the perspective of the industry. For knowing the industry's perspective about Sangam, I would like to invite our first speaker, Mr. S.S. Narayan Swamy, Head of Innovation Center, Japan and Asia, Oracle.
very good evening, and it's a privilege and honor to be there in this stage, and it's great dignitaries, and it's always seeing this kind of situation where, where we are going, where we are marching towards, and Sangam is a kind of a unified focus, I would say. So let me start with a couple of things. My involvement has two things, actually. In India AI program, working very closely with METI, that is Information Technology, and the second one is GPA, that is Global Partnership of AI. So in this context, I think three things came up, and I'll talk about digital twins, how it can be a context of an impact there. First thing is India AI. The context is how do we really change the way the landscape of India, right? So we were around 80 plus technical architects. So I'm also a technical guy, around 33 years of experience in product development. But the best part of it is creating work groups. So first thing is, I would like to thank Honorable Minister Rajiv Chandrasekhar, and with his presence, and the Secretary of METI in terms of giving an opportunity for me to contribute in one of the work groups. So when I look at that, and when I look at the Sangam, I very much feel that, today's presentations, right, it was expected in the India scenario was to see that how do we really create a blueprint for the next 3 to 4 years? How do we really change that? So when I looked at the Sangam unified architecture, there were three major scenarios and the context, and I think the sir and the secretary, the initiatives, what has been taken here is amazing, because one in Delhi, now in Bangalore, next is in Hyderabad, and also the context is if we have invite people from the industries as well as from private and also the public sectors who are like the scientists across India, and we create this significant work groups and start initiating the real-time use cases, because most importantly, if you take a virtual digital twin, it's basically simulation models. I think today I saw the startups giving a great, excellent view about how you can simulate scenarios. Similarly, when it comes to a context about predictability, you have two things, a prescriptive and predictability. So one example I can say is we have around 200 plus patents in MSET algorithm, which is basically a multi-time variant system which is used in NASA. And one of the challenges was put for us was on the NIC part of it and transportation and agriculture by DST, so Department of Science and Technology. So I was working with very, very talented scientists across the country, at least 15 of them. And the first thing they said is, Sri, if there is a way, if there are a scenario like a pandemic situation happens, can you actually trigger 5 anomalies and create a context about how it can be simulated? So if you look at from a tier 1 city, yes, definitely we can do that. When a tier 2, might be to some extent. Tier 3, definitely it is difficult. And tribal area, it's next to, might be possible, might not be possible. Why I'm saying this example is how important is digital twin. Because if you look at the context of today's, the way Sangam has laid out, it's a great transformation, because the transformation is not, as I said, many speakers spoke about 20 years, 25 years, 30 years back, a lot of these activities were there. Yes, AI was more or less called as a neural networks. Scenarios like AI were simulation scenarios. CAD systems was more like how does it really look at transformation, etc. But coming back to the Sangam scenario, if you look at the context today and what we are actually marching towards as an industry from Oracle, I would definitely say this is a fantastic golden opportunity. Because how do we really contribute towards India? So when we started working on this India AI blueprint, it was not easy, because what we did is we took 5 weeks scenario, and my leader was CDAC chairman, Hemant Dargil, and we are a part of 5 to 6 companies in one working group. And finally we presented this back to the IT ministry, and that really actually helped us to actually go and get the approvals, and then we had this impact. So the impact was tremendous. So what I'm saying is, closing down my comments, in particular to Sangam, if we have something initiative like that, if we call out for, I think Sangam is already doing that, calling for use cases, calling for a proof of concepts. But in addition to that, if we have some working groups created for 6 to 8 weeks, dedicated scenarios. I think transformation is a big, big thing, and we can do wonders. And once again, thanks, sir, for all the dignitaries, and thank you very much for IoT, the way things are happening in terms of telecommunication, how we are bringing scenarios to make difference. Say, for example, in IoT or in the terms of telecommunications, right? There is a lot of impact. So once again, thank you very much, and I hope at least something we can actually do for India, and especially for given this kind of impact, what we are creating, it's really a great transformation. So I would definitely say, please look into the unified architecture what Sangam has put forward. There's a lot of transformation and situations which we can carry out. Thank you.
Thank you so much, Mr. Narayan Swamy, for your insightful talk. Now I would like to invite Mr. Ali Hussain, CEO Eras Investment, to share his views about Sangam Digital Twin Initiative.
Good evening, gentlemen. I'm going to make this short and sweet. Firstly, thank you to the Department of Telecom for having us today. Also specifically Niti Aayog for being here. I think the way India has changed from a digital infrastructure and a consumption standpoint, I think a lot of credit goes to the work that Niti Aayog has done over the last 5 to 7 years in specific, right? I think a lot of people are asking this question, a company like Eros, which has been in the film business for the last 47 years, what are we doing in this space, right? So I think close to about 3 years ago, we made this transformation to look at the next evolution of entertainment. The next evolution of entertainment actually comes at the cross-section of blockchain, it comes at the cross-section of generative AI, and it comes at the cross-section of gaming, which eventually gets into extended reality or virtual reality. So the team has been actually developing fictional spaces in high quality and high fidelity, which allow for consumers to either exist in the form of yourself or in terms of an avatar, right? So think of Sangam and the digital twin as an extension of a real city that gets extended into a virtual experience. I've heard a lot of companies talk about infrastructure, talk about data points to be able to map a city, but I haven't heard anybody talk about the quality of the experience, right? Somebody talked about this morning about how do you bring in a city into creating a high quality experience, but is that experience going to be a 4K or an 8K experience, or how do you make that happen? How do you make that happen across devices? How do you make that happen across not just your handheld or browser, but your smart TV, also the latest kind of Apple Vision Pro or the Oculus devices in Meta, right? So our jobs is looking at central technology and working with game engines, specifically either Unreal or Unity, where we don't need to reinvent the wheel, but we look at creating world-like experiences within that. Another concept came up about how to use blockchain technology, right? So a lot of privacy questions, a lot of consumer kind of pull questions are going to be linked to how we ensure that we're able to provide a permissionless experience within the ecosystem, but that's completely guided by rules that are set up within the blockchain infrastructure. And I think thirdly and most importantly, the multiple partners and the data sources coming together, I think will allow you to create a higher quality of the output that we can actually bring and the experiences that can bring. The data will play a key role. You need to have companies that have the experience of running 25 million, 50 million DAO to understand how to develop an architecture, to understand how to create a product journey that allows consumers to come in. We can create a fantastic experience, which is an immersive experience, but unless you create something that's worthwhile for the customer to live in, there won't be any action on their part to engage. So I think creating this consortium of quality partners, including the right infrastructure players that have an aspect to deliver this at the highest quality is very important. Lastly, I think the important thing is this will also become a fantastic showcase of a Digital India project to the world. So ensuring that it is of world-class capability, both in terms of user experience, both in terms of quality, and also usability will become an important facet of this project. So again, would like to thank Asit, the rest of the Department of Telecom. I think it's a fantastic project. We'd love to contribute in any capacity, and thank you for listening to me today. Thank you.
Thank you, Mr. Ali Hussain. Next, I would like to invite Dr. Srivastava for her talk.
Thank Thank you everyone for having me here. It's a privilege. I first want to congratulate DOT for a really aspirational and groundbreaking challenge here. I think Sangam has the potential of creating value for the country in so many ways, and I was listening to many of the sessions this afternoon and just really, really inspired. Not just for the country, I think, from a perspective of whether it is biodiversity, whether it is logistics, city planning, but things that our startups can do for the world and really go outside and create those technologies and create and take them to the world. So to me, that makes it very, very exciting. I would comment on 3 or 4 technologies in the short time that I think would be really, really important as one looks at building a platform, building an ecosystem of this type. One, of course, which many folks talked about is the cloud. I think the ability of the cloud to bring in both in terms of compute, but also security and specialized technologies like quantum computing to solve very nascent problems that you will not be able to solve with normal computing, with the traditional computing. Some of those areas are, while we don't talk about them on a regular basis, today we are seeing companies in the material sciences world, in the world of even, if I look at the space agency, how they're thinking about spectrum allocation using optimization. Some of those really specialized cases that you think about the cloud mostly from a compute perspective, but as very specialized compute cases is quite remarkable. The second would be clearly the discussion that we've had multiple times on data. As you share data, as you think about personal data, as you think about data that needs to be kept private, the whole range of technologies which are considered as privacy-enhancing technologies becomes important. And there has been a long legacy of things such as homomorphic encryption, things like referential privacy, confidential computing, and a lot of innovations that are happening to ensure that data can be shared between different parties, and can be computed upon without decrypting it, which just changes the game in which how multi-party computation can happen. So I think the whole range of thinking about getting value from data at the end of the day, while preserving privacy, while preserving intellectual property, while incentivizing people to create value from data, those technologies are very much there and are being used. The third, which we heard quite a lot about, which is the nature of the conversation called digital twin, I would expand that to slightly talk about the broader area of spatial computing. I think the whole idea of thinking about digital and physical as a continuum opens up very different set of use cases. It's not just only digital, not just only physical, but the continuum of digital to physical. And things such as if you think about, let's say, a disaster someplace, and you're able to bring the digital markers of, let's say, where supplies are kept, and somebody's from a physical perspective, but from a digital perspective, somebody with just a simple smartphone can locate them using the cloud. It just opens up a whole different set of capabilities. So I think thinking of digital and physical as a continuum becomes important. And today what's happening in the world of broadly what is called metaverse or spatial computing or digital twin, whichever terminology you like, I think a lot is happening now where generative AI adding on top of that. Because imagine now you are able to have a digital version of a machine and you can look at the picture and the machine and the AI can actually see what is the wrong with the machine. Because that's possible. Because now today these large language models, these intelligence actually have visual capabilities. They are multimodal. And then that, what is seen, let's say, in a machine that is broken, for example, being able to take into the cloud and get information from somebody like an expert. In fact, we did a very interesting use case in Karnataka, where in a small town, in a surgery that was happening, a senior surgeon could remote assist somebody who was doing a surgery, perhaps not a very senior surgeon, but could see digitally using HoloLens to see what was happening in the surgery. So that entire gamut of digital physical becomes very important, and of course AI becomes a big part. And the last part I would say is the whole nature of, while we call it generative AI, I think of it as really a change in the paradigm of AI where you can now talk to the computer in your language. Thus far, we talk to the computer in the computer's language, but now you can talk to the computer in your language, and the computer understands. The second part of it is the machine actually is a reasoning engine. It is not just a model. It's actually a reasoning engine. So the ability to now have a conversation, even with video, audio, multimodal, like I said, just changes. I'll give you an example. There is a project called 10-bed ICU, which if you've heard about it. What it is doing is that it's creating intensive care units in remote areas, and they are using the visual capability of a large language model to be able to help and assist people who may not be very trained in emergency response support, but be able to train them because the machine can see what is wrong with the patient and be actually able to assist you. Add that language capability to it. So now you have somebody who's, let's say, Assamese, can actually speak to the computer in Assamese, get understanding of what needs to be done in that situation when a person, for example, is under danger. So the possibilities of what can be done with technology, I just talked about 4 of them: the cloud, privacy enhancing technologies as a range of it, digital twins and spatial computing as a broader concept, and finally AI, which is just at a different level of movement. There's just tremendous possibilities. I'm so excited about this initiative and look forward to participating. Thank you.
Thank you so much, Dr. Rohini Srivastava, for sharing your insights about privacy, computing, and digital twins. Moving forward, after the insights from the industry leaders, let us hear from the leadership of the government. So may I now request Dr. Neeraj Mittal, Chairman DCC and Secretary Telecom, for his special address.
My first welcome to be Subramaniam sir here, who has consented to be part of this extremely important initiative of the government, where the government wants India to be a developed nation by 2047. We need to plan ahead, and his presence here is a testimony to the fact that initiatives like Sangam are very top of priority in government's business. This initiative actually arose because the Honorable Prime Minister had made a statement this year, I think the previous year, sorry, saying that India's infrastructure needs to be futuristic. Then we had another meeting wherein the government saw that the planning is happening in silos. We have the different ministries who are possibly planning the best in their respective silos, but possibly not talking to each other. The Planning Commission, and that is why Sir is also here, the current avatar, the Niti Aayog, had that function to play of an integrative role across the departments. But the landscape has changed from the Planning Commission to Niti Aayog to today because of 3 very big changes. One, great volume of data, rich data, various formats of data becoming available in the government, outside the government, in private sector, with citizens, which is available for converting data to knowledge. Number 2, even if this was available earlier, we could not have done anything with it without massive computing power. So over the last 10 years, the computing power has exponentially increased. As one of the speakers from Microsoft has said that about the cloud computing has become something ubiquitous. And the third is we are getting to a point where new data collection is possible, where you can put IoT devices anywhere for new and fresh data collection. So instead of possibly counting vehicles with a stopwatch by a person standing on the road, which is a traditional way of doing it, you just have a device and you have massive, cameras, and we saw presentations where, all this counting is happening now digitally. With all these capabilities, coupled with the examples given here, the quantum, the AI, many things which are not feasible have become feasible. And this aspirational, many speakers have said that this is aspirational in nature. It is aspirational in nature. And we wanted to reach out to the industry, to the academia, to the startups, to the students, to see what is the best way of going forward. Coupled with the fact that telecom has a very rich data of almost every citizen in the country in real time with many of our operators. It was a very low-hanging fruit to use this data for example, city planning. There were several use cases given by a colleague here who showed how just simple telecom data can lead to so many different use cases, just one set of data. Think of what power can be if we put all of the data which we have in various verticals together. So thank you so much for all of you who have come here. I'm looking forward to the guidance of Sir on how NITI Aayog possibly looks at this initiative and how it can take the country forward into being the most developed country in a few years from now, in a decade from now, and definitely by 2047. So with these words and a massive thank to all of you, I would like to see a lot of suggestions from all of you of what we can do in response to this so that we can plan an actual concrete program with the collaboration with big companies, mid-sized companies and startups. So thank you so much.
Thank you, sir, for your inspiring and engaging words. I'm sure your address has truly ignited a sense of purpose and drive within the audience. Now it is time for the most awaited address of the day. I take the honor to invite Shri B.V.R. Subramaniam, CEO NITI Aayog, for his keynote address.
My friend and colleague, Dr. Neeraj Mittal, the director of IIIT Bangalore, other distinguished guest speakers, participants. I'm extremely delighted to be here. It's nice to be in Bangalore. I am a part of some speaking circuits, so I do talk a lot here and there. So if I was in Bombay, I would have a very different audience, three-piece suits, perfectly coiffed, etc. And suddenly you come to Bangalore and you find, this is a different world. It's a tech world, and techies have their own fashion statement, which is quite different, So, you have to be anti-establishment. So, be relaxed. What matters is what you do and not what you wear. So, thanks a lot for actually organizing this thing. I'm also carrying, this is the only talking points I have, which is the people who have actually spoken today. And, and I suddenly feel like an ignorant fool because about 80% of the companies' names I don't know. I mean, Microsoft is obvious, so, Eros is obvious because maybe we've ended up in a lot of their theaters or whatever, but, or they've seen their, stuff on screen. And none of the topics are known. So I guess I'm the right person to close the session in terms of saying, okay, it's enough, let's move on to interesting things. But let me, on a more serious note, India is growing fast. I'll call it, the momentum is with us. Okay, the growth momentum is with India. And if we do the right things, we'll keep going like this for the next 20, 30 years. It could be a variety of reasons. I'm not going to go into any of that, It could be geopolitics, it could be demography, it could be economics. There's a whole host of issues where all converged. It's our karma that all of them have converged on India today. With a top-class leadership, this country is moving ahead fast. The only thing is we need to keep doing the right things and don't mess up. And I think there's no escaping, we becoming a developed nation, a $3 trillion economy becoming a $30 trillion economy. $30 trillion 25 years from now is bigger than the United States today. just to give you an idea of the size and magnitude of what the change will be. The second part of the change is, if a $3 trillion and you're going to go to $30 trillion, 95% of India that's going to exist 25 years from now has not yet been built. That's the big thing. What you've seen today, what you see in the country as something fascinating, this city has changed phenomenally in the last 20, 30 years, is just 5% of what needs to be done over the next 25 years. Because that's the exponential growth that's going to be there. That's the power of compounding. So the $27 trillion of GDP per annum has yet to be added, which means that much more infrastructure, that much more facilities, that much more services across the nation. That tells you, can you keep doing things the way you did in the past? I think that becomes the question. Take telecom department, if you wanted to have a transmission between two places, you went by line of sight, one fellow standing with a pole here, with a telescope, trying to see, do I have a line of sight? Those days are gone. We have moved to better stuff, but I'm sure in future, when you magnify this across sectors, across different landscapes, you have to use technology in newer ways, and I think it's becoming more and more possible. The old-fashioned hit and trial method won't work. And I think that's the big lesson I learned from an idea like digital twins. And I think some of my words have been stolen by my colleague, Neeraj. It's the same thing, in the sense that there's an explosion of data. He was giving me some number of so many billion devices, I don't know what. But data is there everywhere. I'll talk of Sarkari data. And the 50 crore Aabha, which is Ayushman Bharat health identity cards. Think about that kind of data that is being generated. It doesn't exist in the world. And unlike educational data, health data is money. Who is having what illness where, what is the density of illness in different parts, what is the disease spread that is happening by age profile, by region, by weather, by time of the year. You realize that. I'm just talking about one area. You can go area after area and after area. There's an explosion of data. The question is, are we even using a fraction of it? I'm sure some of it, private sector uses it. Hindustan Lever will sell soap because it knows there is a wash program, hygiene is needed, so where there is more of hygiene issues, you can push more soap into the market. But the issue is there is so much more to do, and we are not even scraping the surface. And the second thing, the point which is said, it's not just the quantity of data that is available, it is the explosion of technologies that is there, in terms of the way you can actually touch this data and use this data. And the third thing is, the new ways which have developed, internet, telecom, whatever, by which people can actually collaborate across barriers and come up with collaborative solutions. So I think these are changing the landscape. And I think in this context, a digital twin is a very good concept which has immense use. And I'm not limiting it to infrastructure. It looks like the most obvious thing. But I can talk of a couple of things other than infrastructure. Infrastructure, certainly. That is there. You create, I just saw the video there about a factory, I think it was Genesis or Genpact was showing that, about how you can model that, about energy consumption, carbon. I'm sure during the day there were a couple of other such examples. But that's a sitting example. Some work has happened. You've had Gati Shakti doing something, but that's about static data. Okay, the fact is we should have done that 20 years ago. The people who designed Google Maps, a lot of them are sitting in Bangalore, and key people are sitting in Bangalore, not just the people who do the coding. And the point is, it's much more than that. You got live data, real-time data flowing through the systems. Are we developing capacities to use that real-time systems for decision making? I think that's something very, very important. It's about traffic management, it's about route management. I've seen bits and pieces. I won't call it digital twin. I've seen in Surat. I think the best integrated command and control center in the country, which comes under smart cities, is probably in Surat. I'm subject to correction. There are a lot of industry people here, but I was thoroughly impressed. There is this, it's almost like a 70 mm movie screen on which people can see what's happening. You can actually see bus routes, congestion, and actually give real-time messages to buses to increase frequency on certain routes because there is congestion happening on certain routes, etc. And they have integrated whatever data is there at the city municipal level onto that integrated system. And they've got about 200 consoles within the room each handling different areas, and they can switch the screen to different subject areas about cleaning, about, whatever municipal services are there, sewage disposal, sanitation, all that kind of stuff is there. They've integrated CCTV cameras so that you know whether waste collection has happened, potholes are there or not, are they being attended to, so a whole host of stuff. But this is, I would say, too elementary. It's nowhere near a digital twin, because this is about, closest it's coming to is real time. But we're not about digital twin, we're actually talking about modeling for the future. So you're actually planning to peep into the future, lifting the veil. The best we have done is we know the past so we can take a decision. Other is we know something real time so we take a decision for today. What you're talking of is lifting the veil and looking into the future through modeling and whatever data is available to take decisions about the future. So I think that's a very, very powerful device. It reduces wastage, it cuts costs, it probably speeds up things. How many times haven't you seen buildings getting delayed because I've dug into the ground and pipe aa gaya niche? Highways, I know, I had a problem in Jammu. The biggest, at the entry to the city of a highway going to Akhnur, which is strategically important, they stopped the flyover because there's a pipe under the ground, massive drainage pipe. So till they actually reposition, this is such common sense, you should not have aligned it. So what I mean is, this is one example which is too crude, but I think there's a lot which could be done. The benefits are many, but the biggest thing is, and this is something which bothers everybody in government at the top, we work in silos. Information, data comes in some place. If they are smart, they'll end up using the data there, but you don't use it across boundaries. And I think that is where the contribution of the idea today at Sangam is most critical. The source of the data and the utilization of the data are possibly at two different places, or multiple sources and multiple users, all different. I think that's the strength. And take the Department of Telecom, and I've had this chat with your secretary. You're generating tons of data. Not in terms of who, but in terms of, it gives you, where does Google get its traffic data from? It's getting from that mobile phone in some fellow's hand. Similarly, you're generating a lot of stuff. Can that be processed and used for other purposes across? I think that's very important. And it can be used in a manner in which organizations can plan together, can think about the future together, and that's how you save costs, etc. But that will require a fundamental change in the way we think and work. It's very difficult. Forget government, it's impossible even in the private sector. Matrix organizations have tried, failed some places, succeeded some places. It's very difficult. But I think if we do it, I think we would have cracked a very big thing. We will be saving billions of dollars in doing it. But then you look at where this data is coming. Telecom is obvious, one source of data. The entire digital public infrastructure which India is creating is also generating data. And they're actually planning to use it. After all, what is the AA framework, account aggregator framework? It's actually about taking data and using that for credit decisions. And I'm sure in this room or in Bangalore, there are tons of fintechs who are trying to actually capitalize on that for lending decisions. Okay, but can that data be used for other purposes? For ATM locations? For some other decisions? Can it be used for some other decisions which have nothing to do with finance? That is where creativity is needed. So the person generating data may have no idea what that data is useful for, is the point I would like to make. So what are the sources of data? You've got telecom, you've got DPI. I was just thinking, you have all these stacks. You have a health stack, you have a logistics stack, you have a land record stack, you have about 10 stacks, agri stack, which is being built in the country. All of that will generate data, which will have utilization elsewhere. And I think that's very, very important. And my concern is, when all these are there, we may end up building up very, very narrow solutions which serve that sector alone, because they're the only ones who have access to that data. But if you actually have processed data, data is the new oil. But just as you can't use oil unless it's refined, you can't use data unless it is processed. Okay, and that processing, who would do becomes the biggest question. In my view, I think there is money to be made. If there are telcos, they can make money by picking up data, processing it, and throwing it open to others. They can sell data and make money out of it, as long as you have addressed the privacy and other issues. But the kind of stuff, and it's across the board. So I think originators of data should see the potential of making money from the data, but not necessarily in a sales pitch for individuals kind of a term, but in terms of a planning way. It's a B2B relationship. And the other side, because that's the way, while government can push and make some headway through some mega projects, you'll have to have an explosion of ideas which will come and 1 million people on either side actually start talking. Okay, you're a creator of data, I'm a user of that info which comes, and I will use it for a digital twin for this purpose. I think the possibilities are infinite if you unleash this power. And I think that's the direction in which we need to work, and that's important. Look at a government point of view. Forget anything else. Just spatial planning, allocation of space is a big issue in government. I mean, digital twins. Planning new infrastructure, digital twins. Process flow management, digital twins. You can actually build a digital twin of an office and see how files are moving, where are delays there, what are the bottlenecks. After all, a government office is not different from a factory floor. And government was probably as inefficient as factories were 30 years ago. It's the same. You can apply the same principles and do it. Just as you have some, instead of this electronics, some machine going around in a factory, you have 2 peons going around in an office with files. So, so the question is you can apply similar principles to make governments efficient. Secondly, there's an entity called the citizen whom the government serves. Can you build digital twins to actually see how service is delivered and then try to see how those things can be modeled and improved for future? Based on data that is there from it. And then of course you can add layers of AI onto it. And that can give you faster, better solutions, ideas. Because AI is doing something which is quite different. I mean, I have the personal belief that, you had the computing revolution, it drew the marginal cost of computing to zero. It drove it. And then you had the internet revolution, it drove the marginal cost of distribution to zero. That's how you have the Amazons and Flipkart. And I think AI is going to drive the marginal cost of creativity and content creation to zero. So it will lead to some other thing which we don't know. So, I mean, if without internet you wouldn't have an Amazon. So once AI is there, you will have some other beast coming up, which is fine. I mean, that's the way the world moves ahead, So I think we are at a fabulous junction. It's a beautiful concept. Its potential is immense. And this country is at the right juncture. We are not a mature economy where if you have to build something new, you have to dismantle something. You are at a place where most of the stuff that you have to see is yet to be built. And if that is to be built efficiently, built faster, built in the most effective manner to make the most money, I think this is the right thing. I've been through all the topics which are there, excellent stuff. And there's no end to it. I've seen there's a section on environment, biodiversity. There's no way there is no application there. You can use it massively. I can think of 5 ways in which you can use it for wildlife parks and other things. So thank you very much for inviting me here. Great potential. I compliment the department, secretary, his colleagues for doing this. There's one more, I think, later this week or next week. I wish you all the best, and I'm hopeful that some big ticket things will come out of this. Thank you very much.
Thank you so much, sir, for your enlightening words. Your words have not only inspired us, but also provided valuable perspectives on the importance of collaboration and innovation. Under the valuable guidance of visionary leaders like you, we believe that together with the help of technology, we can build something big for the betterment of our nation. So now the floor is open for questions. So if anybody has any questions, the floor is open. So if there are no questions, so I think there is one question.
Hi, my name is Asutosh. So after this, what next? One is that we'll be coming up with expression of interest. And second thing, probably Ashish sir was saying that we'll be having a demand for the data and who is going to be the supplier of data. So I think most of the proposals, I'm speaking my mind loud, but most of the proposals will come that we want to implement something, we need this data. So mostly the demand for data come, but how are you going to foresee that who is the supplier of the data? And those suppliers may be the telecom network providers and all these things that we have this massive data. If somebody is going to use it, floors are open. So is it possible to get that data? I mean, already demand side we are okay, but supplier is little difficult.
See, your question is very right, and the idea here is to actually assess what the demand side will look like on data. We will work with all sister departments in Government of India. There's a lot of data which is available. There is a national data platform within the NITI Aayog. Of course, that data is not current, but data is available. Sir was telling that there is a huge amount of crores of data points are available already with us in various forms and shape. Telecom data we will facilitate to provide for prototyping, for development based on their proposals. Yep. Sorry, I have stolen the mic, but let me tell you. I think we have to move in the government also towards data-driven decision making. I think that's the big step. So rather going the old-fashioned way, we should go the new way, which is including concepts like digital twin. You can go all the way down to district levels, block levels, use localized digital twin concepts, show some use cases. I think the big thing is show use cases. Show use cases at the national level, which could be across the board or in one sector. Show use cases at state level. Show use cases at district levels. Once use cases start getting demonstrated, then you will see an explosion of ideas. That's how things will move actually. You demonstrate 10 use cases in the country at any of these levels, I can assure you within a year it will become 100 or 1,000. Because then the creativity, what happens is, how do you crack the first one? And that's where you are right. You know, the data provider and the data user don't even know each other right now. Use cases will start establishing it. Business models will start coming up. You know, that's it. You're sitting in a city of startups. 90% of startups don't end up doing the business they started with. They'll end up doing some other business. That's how you evolve in real life. So I think that's the way, and I think government will play a role in pushing the story forward.
Hello. Yeah, I'm from IODX, India Urban Data Exchange, which is a funded project by the Ministry of Housing and Urban Affairs. So we're a data exchange platform trying to share data between the providers and the people who need it. And one area where we're always stuck is actually getting useful data. For example, in Bangalore, there was a drone survey, a plane survey for high definition maps for flooding use cases. That is stuck in some other department, and we've been spending a lot of time trying to get it from them. So you talk about data-driven decision making, but without the drive of these government departments to kind of share the data, I think, you know, that's a huge barrier to getting things like digital twin sorted. So what are your thoughts on that?
No, I think I talked about NDAP, which NITI runs. We have about 1,400 data sets which are there. Half of them are in PDF form, forget sharing. We actually take it, scrub it, and then convert it to electronic and then upload it. And it's used a lot. The point is, your problem is widespread. I think that's necessary. And I think there is a larger game plan in mind to have common data sets with standardized formats for interoperability or exchange, etc. It will take a year or two to roll out, but I think that's very, very essential. I think people are now aware of the problem because we are getting stuck for lack of that.
Hi, my name is Vivek. I have a question about the data source provider. So like you talked about account aggregator, banks have to provide the data, GST has to provide the data. There is no incentive for them to provide this data. So is there a framework or is there a way that whenever any data source comes, the incentive is built for them? So take an example for account aggregator. Banks have to have the infrastructure and keep running it, right? And in that scenario, there is an extra cost for them and they are not getting anything back, right? So the reliability of that infrastructure, the quality of that infrastructure is something like should be built, either should do it day one or there should be incentive that if they are running it with the production grade quality. So what do you think about it?
Okay, you're dealing with a very different entity when you talk about banks. Banks are one of the most heavily regulated entities.
So they have a particular business model, so I can understand all that, etc. But rest assured, that doesn't prevent, or it has not prevented, an explosion on the fintech side. Okay, that is it. There are challenges. I don't believe, 1900 India was not a country which drank tea. Most people in India drank milk or lassi. And the great tea companies, Lipton and Brook Bond, used to go around villages on bicycle distributing free tea in small cups so that people get addicted to tea. How many people in the country today begin with milk in the morning except children? So what I mean is, I'm giving that as a very crude example that the people who own the data don't even know potential users, which are far removed from their own sector. And the people who could potentially use don't know the sources of data, which they could actually use effectively. So actually that's why use cases will start helping. You need to establish a few use cases and then creativity will come in. I think that's that. Take the account aggregator framework itself. It is a fabulous concept. Companies have come up. There is hesitation in the banking formal setup to actually invest in that, etc. But it's picking up. There will be every sector will have a disruptor who is willing to take it up. Whether maybe State Bank may be unwilling to do it, some IDFC first will come and say, I will do it. And that's how disruptions begin. The other fellow will jolly well end up copying for their own survival's sake. So we have to trust market forces to some extent.
We have one last question, sir.
Sir, I have an observation. This digital twin to succeed, I think there's a need of standardization. I'll just quote one example. We did a smart city around the country. If you look at each smart city is implemented in a different way. If I'm an application provider or a device provider, if I succeed in Surat, in Bangalore I will have to do again. If I go to Delhi, it will be very different. So therefore, there need to be standard. What it will bring, the moment the standard comes, economies of scale and the lesser effort. So if my device has worked in Bangalore, it will immediately work in Delhi, immediately work in Ahmedabad. For example, in smart city, there are already 1M2M standard which have been declared as a national standard in our country, but none of the state governments are following it. So there is a need for standardization based on the global best practices. So once standardization comes, we can derive the economies of scale, economies of scope. That's my suggestion.
So I was, in Tamil Nadu, in my last position, I was the MD and CEO of the Tamil Nadu Smart City project. What you're trying to say is, that we need to have a shelf of projects because every city has its different needs, and therefore this smart city program was not same across all cities. They said you can do this, money is limited, you choose 1, 2, 3. But one across all cities should be the same. Two across all cities should be the same. So you are both right and a little away from the target because every city will be different in its requirements. That is why there is variation from Surat to Delhi to Kanyakumari to Coimbatore. But if you install a smart pole in Kanyakumari and you install a smart pole in Surat, the smart pole specification should have been common, which will give economies of scale. So you are right to that extent. Thank you.
Thank you so much for this interactive session. Now I request Shri R.R. Mittal, Director General Telecom, to present a memento to our chief guest, Shri B.V.R. Subramaniam, CEO Niti Aayog, as a token of gratitude for gracing this event. Thank you, sir. Now I request sir to present a memento to Dr. Neeraj Mittal, Secretary Telecom, as a token of gratitude. I I request Shri R.R. Mittal, Director General Telecom, to present a memento to Dr. Debabrat Das, Director IIIT Bangalore, as a token of gratitude for allowing us to host this event here. Thank you. Thank you so much. Now I request Shri Naveen Jakar, ADG DOT, for the vote of thanks.
Thank you, Kumud. Respected Shri B.V.R. Subramaniam, CEO Niti Aayog, Dr. Neeraj Mittal, Secretary Telecom and Chairman DCC, Shri R.R. Mittal, Director General Telecom, Dr. Debabrata Das, Director IIIT Bangalore, illustrious industry leaders, esteemed entrepreneurs, senior officers, ladies and gentlemen. On behalf of Department of Telecom, I extend a formal vote of thanks for gracing today's outreach program of the Sangam Digital Twin Initiative with your esteemed presence here at IIIT Bangalore. Today marks an important milestone in the remarkable journey that embodies the spirit of innovation, collaboration, and technological advancement. This is the second outreach program. I express my heartfelt gratitude to our esteemed chief guests, Shri B.V.R. Subramaniam, CEO Niti Aayog, and Dr. Neeraj Mittal, Secretary Telecom. Your leadership and vision have been instrumental in shaping the vision of Sangam Digital Twin Initiative and bringing it to the life. I express our sincere gratitude to the guests of honor, Shri R.R. Mittal, DGT, and Dr. Debabrata Das, Director IIIT Bangalore, for sparing valuable time from their busy schedule to be a part of today's outreach program. We are deeply honored to have among us esteemed dignitaries and senior officers from DOT and CDOT. Your unwavering support and guidance have laid the groundwork for a transformative initiative like Sangam. I also extend heartfelt appreciation to each of our industry experts and entrepreneurs. Your presence here today serves as a testament to your dedication towards fostering growth and progress in the society. Your dedication and commitment towards this initiative will be the driving force behind the realization of our collective goals. Last but not least, our sincere thanks to the TCI, IIIT Bangalore administration, volunteers, and everyone involved in the meticulous planning and execution of this event. Your attention to the details and tireless efforts have led to the successful culmination of today's event. In closing, I once again extend my deepest thanks to all the enthusiastic participants present over here. I firmly believe that your unwavering enthusiasm towards this initiative of DOT will lead to the success of Sangam. Your presence today here signifies the beginning of a new chapter in our collective pursuit of excellence and progress. Thank you once again.
With this, we come to the end of today's event. Thank you everybody for joining. We are signing off till the next event in Sangam, Hyderabad on 12th March. Please be there in Hyderabad as well. Thank you.